Hello and welcome. In this course, you will explore core data concepts in Microsoft Azure. To begin with, you will familiarize yourself with important terminology and get a taste for the key job roles and their responsibilities in the world of data. Also, in the first module, you will have the option to cover Microsoft Azure fundamentals and cloud computing advantages. Completing these two lessons is not a requirement to successfully complete this program, but we highly recommend you take them if you are not familiar with those topics. In Module 2, you will learn about relational and non-relational data, exploring their characteristics, data structure and platforms, and where to use these types of data. Finally, you will explore concepts of data analytics, including data ingestion and processing, and data visualization. This course will also prepare you to dive deeper into the topics of relational data, non-relational data, and modern data warehouse analytics in Microsoft Azure. There are a wide variety of roles involved in managing, controlling, and using data. Some roles are business-oriented. Some involve more engineering, some focus on research, and some are hybrid roles that combine different aspects of data management. Mastering Azure Data fundamentals can help you jumpstart your career, whether you're new to the field or a seasoned professional, and prepare you to dive deeper into more advanced job roles in Azure Data Services. Obtaining the Microsoft Azure Data Fundamental certification can be the first step in preparing you for your next job in the world of data. 3 key job roles that deal with data in most organizations include database administrator, data engineer, and data analyst. You will learn more about these roles in this program. Are you intrigued by this career field and wondering how to get started? Let's meet a few candidates and explore their career paths and how they got started. Jose lost his job during the COVID crisis. He had graduated with a bachelor's degree in history a few years before. Jose is an IT help desk specialist and is new to cloud services. He decided to enhance his career and make the switch to go to the field of data, with the goal to later become a database administrator. Database administrators manage databases, assigning permissions to users, ensuring data is available by managing backup and restore procedures. Jose is an ideal candidate for the Microsoft DP900 Azure Data Fundamentals Professional Certificate to start his career in Azure Data Services. As Jose passes the Microsoft DP900 exam, he will be one step closer to achieving his professional goal. He can then get some work experience in the field of data services and later pursue the Microsoft Azure Database Administrator Associate Certification pathway. Jose is a beginner in data services, but has already mapped out his career and certification path. With a view to getting ahead, Jose is working hard at gaining the work experience he needs to find his first great job as an Azure Database Administrator. Letitia has a master's in computer science, but she still wants to further advance her career and upskill in a competitive work environment. Letitia has more than 5 years of experience working as a software developer, but she wants to add new credentials to her portfolio and go beyond software app development by moving into data services. Letitia is an ideal candidate for a role as an Azure Data Engineer. Data engineers are vital in working with data, applying data cleansing routines, identifying business rules, and turning data into useful information. Letitia completed the Microsoft DP900 Azure Data Fundamentals Professional Certificate exam and went on to successfully complete the Microsoft Azure Data Engineer Associate Certification pathway. Ingrid is looking for ways to advance her existing career field and upskill in a competitive work environment. She has a master's in business administration and more than 5 years of experience working as a project lead in technology firms. She is familiar with the cloud data services available from Google and Amazon Web Services, but is looking to specialize and become an Azure Data Analyst. Data analysts explore and analyze data to create visualizations and charts to enable organizations to make informed decisions. As a project manager, Ingrid works with people, processes, and technologies to continuously deliver business value. Ingrid successfully completed the DP900 Microsoft Azure Data Fundamentals exam. She knows that the Microsoft certification has helped validate that she stays ahead with today's technology. She also knows that these studies have boosted her confidence and given her renewed job satisfaction. Ingrid works for a great company and may even be rewarded with a salary increase as she progresses. Based on these scenarios, you can see that Microsoft gives you the ability to start a specific certification path that matches your career aspirations, while improving your skills at the same time. There are different certification paths for you to choose from, depending on your expertise and background. The certifications are structured into 3 expertise levels. The fundamental certifications are targeted towards those just starting out with the technologies covered or looking to change careers. The associate certifications are targeted towards professionals that already have at least 2 years of practical experience working with the technologies covered. And the expert certifications are targeted towards professionals that have a minimum of 5 years advanced levels of practical experience and skills with the technologies covered. We have provided links to the various Microsoft certifications at the end of this lesson so that you can explore them in more detail. Mastering the Azure Data fundamentals can help you jumpstart your career, whether you're new to the field or a seasoned professional, and prepare you to dive deeper into the many technical opportunities Microsoft Azure offers. Microsoft Certified Azure Data Fundamental Certification is an opportunity to demonstrate foundational knowledge of core data concepts and how they are implemented using Azure Data Services. This certification is intended for candidates beginning to work with data in the cloud. Passing the exam DP900 Microsoft Azure Data Fundamentals is the right choice if you want to further your career in Azure Data. Prior to taking the exam, candidates should be familiar with the concepts of relational and non-relational data and different types of data workloads, such as transactional and analytical. In Microsoft DP900 exam, there will be 40 to 60 questions. There are different question types used during the exam, including scenario-based, single-answer questions, arrange in the correct sequence, drag and drop, mark review, etc. To obtain the Microsoft Azure Data Fundamental Certification, you will need to pass the DP900 exam, which covers the following topics with varying weights. In the exam, you should be able to describe core data concepts, how to work with relational data, how to work with non-relational data, and analytics workload. At this point, you may be wondering if you will have access to the information that you'll need to successfully pass the DP900 Microsoft Azure Data Fundamentals exam. The answer is yes. Each domain area is mapped to this program. Once you successfully complete a course and graded quiz, you will be awarded a Coursera certificate. You will also receive a certificate on successful completion of this program. Next, you'll receive an electronic notification that allows you to unlock a 50% discount certification voucher code. Once you have unlocked the code, we encourage you to register and schedule the exam. You will be given directions on how to do this and how to prepare for the exam. Good luck with your preparation.
Hi, my name is Waleed Mir, and I'm a Microsoft Technical Trainer. Today, I'm going to talk to you about Azure Data Fundamentals. In my opinion, the main impact Cloud Data Services has had on businesses over the last number of years is that it has revolutionized traditional data solutions. Cloud data solutions are highly available and more accessible to users and businesses of all sizes. This is because you pay for what you use, and the customers don't need to pay for all the hardware and software, facilities, or extensive configuration and maintenance of full technology stack to run them. Hence, the cloud-based data solutions cost less, they are more scalable, more reliable, more secure. This helps businesses adapt to changes quickly or meet their needs as the demand changes. Cloud-based data services has had great impact on application development and data analytics. Cloud is changing the way applications are designed, including how the data is processed and stored. For example, instead of a single general-purpose database that handles all of solutions' data, polyglot persistent solutions use multiple specialized data stores, each optimized to provide specific capability. As a result, the perspective on the data in a solution changes. There are no longer multiple layers of business logic that needs to read and write to a single data layer. Instead, solutions are designed around data pipelines, that describes how the data flows through a solution, where it is processed, where it is stored, and how it is consumed by the next component in the pipeline. Having this data available in the cloud makes it easier for businesses and to apply analytics that can help them make informed decisions with speed and simplicity. These insights from all your data can be derived more efficiently with a limitless analytics service that brings together data warehousing and big data analytics. One of my favorite cloud data services in Azure is Cosmos DB. With changes to data and application development in today's world, we require services that are highly responsive and always available. Azure Cosmos DB is fully managed NoSQL database service that has less than 10 millisecond response time and guarantees speed at any scale. It provides instant scalability, business continuity, which is assured with SLA-backed availability, and enterprise-grade security. With features like multi-region write, data distribution globally, and real-time access with fast read and write, it can be considered for a solution to a number of scenarios, for example, IoT, smart devices, or sensors across ocean, desert, or jungle, monitoring temperature change every minute, or it could be collecting live game data from players across the globe. It surely is an amazing service that can be a key component to your solution with endless possibilities. To begin a career in data storage or data management, some background knowledge of databases is useful. However, it is not necessary. DP900 Data Fundamental course covers all the fundamental concepts of data along with services and features that are available in Azure. To prepare for a career in data analytics, you can start your journey with DP900 Azure Data Fundamentals course, which covers basic concepts, tools, and technologies that can be used in Azure to understand modern data warehouse and data analytics. You can then progress on to associate level certifications for data analytics. To help people in their career path in cloud data services, Microsoft has a number of pathways you can choose from, like data analyst, data engineer, database administrator, and data fundamentals. You can find all the study materials on Microsoft Learn Path website, and additional documentation on features and services are available on docs.microsoft.com.
Hello and welcome to this lesson where you'll explore core data concepts. Over the last few decades, the amount of data that systems, applications and devices have generated has increased significantly. Data is everywhere. Data is available in different structures and formats. Understanding data and exploring it reveals interesting facts and helps you gain meaningful insights. In this lesson, you'll learn about how you can organize and process data. You'll learn about relational and non-relational databases and how data is handled through transactional processing and through batch and streaming data processing. To consider how the tools and techniques learned can be applied in real-world scenarios, imagine you're a data analyst for a large consumer organization. The organization wants to understand customer buying patterns from supermarkets. The organization has a number of data sets from different sources, such as till information or point of sale, weather data, and holiday data. The organization would like to use Microsoft Azure technologies to understand and analyze these data sets. This scenario will be used throughout the lesson. With this scenario in mind, by the end of this lesson, you will be able to identify how data is defined and stored, identify characteristics of relational and non-relational data, describe and differentiate data workloads, and describe and differentiate batch and streaming data. Data is now easier to collect and cheaper to host, making it accessible to nearly every business. Data solutions include software technologies and platforms that can help facilitate the collection, analysis, and storage of valuable information. Every business would like to grow their revenues and make larger profits. In this competitive market, data is a valuable asset. When analysed properly, data provides a wealth of useful information and helps inform critical business decisions. Data is a collection of facts such as numbers, descriptions, and observations used in decision-making. You can classify data as structured, semi-structured, or unstructured. Structured data is typically tabular data that is represented by rows and columns in a database. Databases that hold tables in this form are called relational databases. The mathematical term relation refers to an organized set of data held as a table. For example, a table that stores details of customers in an e-commerce database can contain information such as customer ID, title, first and last name, and others. In a relational database, each row in a table has the same set of columns. In a second example, a table can hold information about products that the organization sells. Such information includes product ID, name, product number, color, standard cost, list price size, and weight. Semi-structured data is information that doesn't reside in a relational database, but still has some structure to it. Examples include documents held in JavaScript Object Notation, or JSON, format. You can have a pair of documents representing customer information. In both cases, each customer document can include child documents containing the name and address, but the fields in these child documents vary between customers. In document 1, there are the fields first and last for the customer's name. In document 2, while storing similar data, the fields with information about the customer's name are title, forename, and last name, without spaces in the column name. Another type of semi-structured data include key-value stores. A key-value store is similar to a relational table, except that each row can have any number of columns. For example, in a table, the first row can have 6 columns, and the second row can have 5. You can use a graph database to store and query information about complex relationships. A graph contains nodes, information about objects, and edges, information about the relationship between objects. There are relationships between items, but the data is not structured. For example, Anne DJs at a nightclub where Sam dances. Not all data is structured or even semi-structured. For example, audio and video files and binary data files might not have a specific structure. They're referred to as unstructured data. Depending on the type of data, such as structured, semi-structured, or unstructured, data will be stored differently. Structured data is typically stored in a relational database such as SQL Server or Azure SQL Database. Azure SQL Database is a service that runs in the cloud. You can use it to create and access relational tables. The service is managed and run by Microsoft Azure. You just specify that you want a database server to be created. The act of setting up the database server is called provisioning. You can provision other services as well in Microsoft Azure. For example, if you want to store unstructured data such as video or audio files, you can use Azure Blob Storage. Blob is an acronym for Binary Large Object. If you want to store semi-structured data, such as documents, you can use a service such as Azure Cosmos DB. After your service is provisioned, the service needs to be configured so that users can be given access to the data. You can typically define several levels of access. Read-only access means the users can read data but can't modify any existing data or create new data. Read-write access gives users the ability to view and modify existing data. Owner privilege gives full access to the data, including managing the security, like adding new users and removing access to existing users. You can also define which users should be allowed to access the data in the first place. If the data is sensitive or secret, you may want to restrict access to a few select users. In the example where you're a data analyst for a large consumer organization, you have decided to give read-only access to the whole management team. The management team have no need to modify data, but have security clearance to see any data. Read-write access is given to the app that salespeople use to record sales. The individual users won't need to access the system directly, but will make edits via their app. Data analysts and data managers will have owner privileges because they need to manage the access of other users and administer the system. Data processing solutions often fall into one of two broad categories: analytical systems and transaction processing systems. But you might be wondering, what is a transactional system? A transactional system is often what most people consider the primary function of business computing. A transactional system records transactions. A transaction could be financial, such as the movement of money between accounts in a banking system. Or it might be part of a retail system, tracking payments for goods and services from customers. Think of a transaction as a small, discrete unit of work. Transactional systems are often high volume, sometimes handling many millions of transactions in a single day. The data being processed has to be accessible very quickly. The work performed by transactional systems is often referred to as online transactional processing, or simply OLTP. To support fast processing, the data in a transactional system is often divided into small pieces. For example, if you're using a relational system, each table involved in a transaction only contains the columns necessary to perform the transactional task. In the bank transfer example, a table holding information about the funds in the account might only contain the account number and the current balance. Other tables not involved in the transfer operation would hold information such as the name and address of the customer and the account history. Splitting such information into separate tables is called normalization. This also helps reduce redundant data, such as storing the same information, for example names and addresses, multiple times in different tables. Next, we will discuss this process in more detail. Normalization can enable a transactional system to cache much of the information required to perform transactions in memory and speed throughput. While normalization enables fast throughput for transactions, it can make querying more complex. Queries involving normalized tables will frequently need to join the data held across several tables back together again. This can make it difficult for business users who might need to examine the data. In contrast to systems designed to support OLTP, an analytical system is designed to support business users who need to query data and gain a big picture view of the information held in a database. Analytical systems are concerned with capturing raw data and using it to generate insights. An organization can use these insights to make business decisions. For example, detailed insights for a manufacturing company might indicate trends, enabling them to determine which product lines to focus on for profitability. Most analytical data processing systems need to perform similar tasks: data ingestion, data transformation, data querying, and data visualization. Data ingestion is the process of capturing the raw data and will generally require what is referred to as ETL, or extract, transform, and load. This data could be taken from control devices measuring environmental information, such as temperature and pressure, point-of-sale devices recording the items purchased by a customer in a supermarket, financial data recording the movement of money between bank accounts, and weather data from weather stations. Some of this data may originate from different systems with different formats. To process and analyze this data, you must first store the data in a repository of some sort. The repository could be a file store, a document database, or even a relational database. During data transformation or data processing, the raw data might not be in the format that is suitable for querying. The data might contain anomalies that should be filtered out, or it may require transforming in some way. For example, dates or addresses might need to be converted into a standard format. After data is ingested into a data repository, you may want to do some cleaning operations and remove any questionable or invalid data, or perform some aggregations such as calculating profit, margin, and other key performance metrics, KPIs. KPIs are how businesses are measured for growth and performance. In data querying, after data is ingested and transformed, you can query the data to analyze it. You may be looking for trends or attempting to determine the cause of problems in your systems. Many database management systems provide tools to enable you to perform ad hoc queries against your data and generate regular reports. In data visualization, data represented in tables such as rows and columns or as documents aren't always intuitive. Visualizing the data can often be useful as a tool for examining data. You can generate charts such as bar charts, line charts, pie charts, plot results on geographical maps, or illustrate how data changes over time. Microsoft offers visualization tools like Power BI to provide rich graphical representation of your data. You can categorize data in many different ways, depending not only on how it's structured, but also on how the data is used. Now, you'll learn about the characteristics of different types of data. Relational databases provide probably the most well-understood model for holding data. The simple structure of tables and columns makes them easy to use initially, but the rigid structure can cause some problems. For example, in a database holding customer information, how do you handle customers that have more than one address? Do you add columns to hold the details for each address? If so, how many of these columns should you add? If you allow for 3 addresses, what happens if a customer has only one address? What do you store in the spare columns? What then happens if you suddenly have a customer with 4 addresses? Similarly, what information do you store in an address, street name, house number, city, zip code? What happens if a house has a name rather than a number, or is located somewhere that doesn't use zip codes? You can solve these problems by using a process called normalization. Typically, the end result of the normalization process is that your data is split into a large number of narrow, well-defined tables. A narrow table is a table with few columns, with references from one table to another. As an example, the customer ID key can be copied into a table with their respective address key. However, there are some disadvantages. Querying the data often requires reassembling information from multiple tables by joining the data back together at runtime, accessing the various narrow tables. These types of queries can be expensive to process. As an example, even though 2 customers, let's say Jay and Francis Adams, share the same address, the storage of the address only occurs once. This is not the case in a document database, as we will see next. Non-relational databases enable you to store data in a format that more closely matches the original structure. For example, in a document database, you could store the details of each customer in a single document, as shown by the example in the previous unit. Retrieving the details of a customer, including the address, is a matter of reading a single document. There are some disadvantages to using a document database, though. If 2 customers cohabit and have the same address, in a relational database you would only need to store the address information once. In this example, Jay and Francis Adams both share the same address. Therefore, their address information is only stored once. In a document database, the address would be duplicated in the documents for Jay and Francis Adams. This duplication not only increases the storage required, but can also make maintenance more complex. If the address changes, you must modify it in 2 documents. Relational and non-relational databases are suited to different workloads. A primary use of relational databases is to handle transaction processing. A transaction is a sequence of operations that are atomic. This means that either all operations in the sequence must be completed successfully, or if something goes wrong, all operations run so far in the sequence must be undone or rolled back. Bank transfers are a good example. You deduct funds from one account and credit the equivalent funds to another account. If the system fails and the transaction cannot be completed, the funds must be reinstated in the original account by rolling back the transaction. They mustn't be lost. You can then attempt to perform the transfer again. Similarly, you shouldn't be able to credit an account twice with the same funds. Each database transaction has a defined beginning point, followed by steps to modify the data within the database. At the end, the database either commits the changes to make them permanent or rolls back the changes to the starting point, when the transaction can be tried again. A transactional database must adhere to the ACID, atomicity, consistency, isolation, durability properties to ensure that the database remains consistent while processing transactions. Atomicity guarantees that each transaction is treated as a single unit, which either succeeds completely or fails completely. If any of the statements constituting a transaction fails to complete, the entire transaction fails and the database is left unchanged. An atomic system must guarantee atomicity in each and every situation, including power failures, errors, and crashes. Consistency ensures that a transaction can only take data in the database from one valid state to another. A consistent database should never lose or create data in a manner that can't be accounted for. In the bank transfer example described earlier, if you add funds to an account, there must be a corresponding deduction of funds somewhere, or a record that describes where the funds have come from if they have been received externally. You can't suddenly create or lose money. Isolation ensures that concurrent execution of transactions leaves the database in the same state that would have been obtained if the transactions were executed sequentially. A concurrent process can't see the data in an inconsistent state. For example, the funds have been deducted from one account but not yet credited to another. Durability guarantees that once a transaction has been committed, it will remain committed even if there's a system failure, such as a power outage or crash. Database systems that process transactional workloads are inherently complex. They need to manage concurrent users possibly attempting to access and modify the same data at the same time, processing the transactions in isolation while keeping the database consistent and recoverable. Many systems implement relational consistency and isolation by applying locks on data when it's being updated or modified. The lock prevents another process from reading the data until the lock is released. The lock is only released when the transaction commits or rolls back. Extensive locking can lead to poor performance, while applications wait for locks to be released. Distributed databases are widely used in many organizations. A distributed database is a database in which data is stored across different physical locations. It may be held in multiple computers located in the same physical location, for example, a data center, or may be dispersed over a network of interconnected computers. When compared to non-distributed database systems, any data update to a distributed database will take time to apply across multiple locations. If you require transactional consistency in this scenario, locks may be retained for a very long time, especially if there's a network failure between databases at a critical point in time. To counter this problem, many distributed database management systems relax the strict isolation requirements of transactions and implement eventual consistency. In this form of consistency, as an application writes data, each change is recorded by one server and then propagated to the other servers in the distributed database system asynchronously. While this strategy helps to minimize latency, it can lead to temporary inconsistencies in the data. Eventual consistency is ideal where the application doesn't require any ordering guarantees. Examples include counts of shares, likes, or non-threaded comments in a social media system. Analytical workloads are typically read-only systems that store vast volumes of historical data or business metrics, such as sales performance and inventory levels. Analytical workloads are used for data analysis and decision-making. Analytics are generated by aggregating the facts presented by the raw data into summaries, trends, and other kinds of business information. Analytics can be based on a snapshot of the data at a given point in time, or a series of snapshots. Decision makers usually don't require all the details of every transaction. They want the bigger picture. An example of analytical information is a report on monthly sales. As the head of sales department, you may not need to see all daily transactions that took place, transactional information, but you definitely would like a monthly sales report to identify trends and to make decisions, analytical information. Transactional information, however, is an integral part of analytical information. If you don't have good records of daily sales, you can't compile a useful report to identify trends. That's why efficient handling of transactional information is very important. Data processing is simply the conversion of raw data to meaningful information through a process. Depending on how the data is ingested into your system, you could process each data item as it arrives, or buffer the raw data and process it in groups. Processing data as it arrives is called streaming. Buffering and processing the data in groups is called batch processing. In batch processing, newly arriving data elements are collected into a group. The whole group is then processed at a future time as a batch. Exactly when each group is processed can be determined in a number of ways. For example, you can process data based on a scheduled time interval, for example every hour, or it could be triggered when a certain amount of data has arrived, or as a result of some other event. An example of batch processing is the way that votes are typically counted in elections. The votes are not entered when they are cast, but are all entered together at one time in a batch. Advantages of batch processing include large volumes of data can be processed at a convenient time. It can be scheduled to run at a time when computers or systems might otherwise be idle, such as overnight or during off-peak hours. Disadvantages of batch processing include the time delay between ingesting the data and getting the results. All of a batch job's input data must be ready before a batch job can be processed. This means data must be carefully checked. Problems with data, errors and program crashes that occur during batch jobs bring the whole process to a halt. The input data must be carefully checked before the job can be run again. Even minor data errors, such as typographical errors in dates, can prevent a batch job from running. An example of an effective use of batch processing would be a connection to a mainframe system. Vast amounts of data need to be transferred into a data analysis system, and the data is not real-time. An example of ineffective batch processing would be to transfer small amounts of real-time data, such as financial stock ticker. In stream processing, each new piece of data is processed when it arrives. For example, data ingestion is inherently a streaming process. Streaming handles data in real time. Unlike batch processing, there's no waiting until the next batch processing interval, and data is processed as individual pieces rather than being processed a batch at a time. Streaming data processing is beneficial in most scenarios where new dynamic data is generated on a continual basis. A financial institution tracks changes in the stock market in real time, computes value at risk, and automatically rebalances portfolios based on stock price movements. An online gaming company collects real-time data about player game interactions and feeds the data into its gaming platform. It then analyzes the data in real time, offers incentives and dynamic experiences to engage its players. A real estate website that tracks a subset of data from consumers' mobile devices and makes real-time property recommendations of properties to visit based on their geolocation. Stream processing is ideal for time-critical operations that require an instant real-time response. For example, a system that monitors a building for smoke and heat needs to trigger alarms and unlock doors to allow residents to escape immediately in the event of a fire. Apart from the way in which batch processing and streaming processing handles data, there are other differences. Data scope. Batch processing can process all the data in the dataset. Stream processing typically only has access to the most recent data received, or within a rolling time window, the last 30 seconds, for example. Data size. Batch processing is suitable for handling large datasets efficiently. Stream processing is intended for individual records, or micro batches consisting of a few records. Performance. The latency for batch processing is typically a few hours. Stream processing typically occurs immediately, with latency in the order of seconds or milliseconds. Latency is the time taken for the data to be received and processed. Analysis. You typically use batch processing for performing complex analytics. Stream processing is used for simple response functions, aggregates, or calculations such as rolling averages. Microsoft Azure provides a range of technologies for storing relational and non-relational data. Each technology has its own strengths and is suited to specific scenarios. In this lesson, you have learned how to identify how data is defined and stored, identify characteristics of relational and non-relational data, describe and differentiate data workloads, and how to describe and differentiate batch and streaming data. Hello and welcome to this lesson where you'll explore roles and responsibilities in the world of data. Over the last decade, the amount of data that systems and devices generate has increased significantly. Because of this increase, new technologies, roles, and approaches to working with data are affecting data professionals. Data professionals typically fulfill different roles when managing, using, and controlling data. In this lesson, you'll learn about the various roles that organizations often apply to data professionals and the tasks and responsibilities associated with these roles. In this lesson, you will explore data job roles and explore common tasks and tools for data job roles. There are a wide variety of roles involved in managing, controlling, and using data. Some roles are business-oriented, some involve more engineering, some focus on research, and some are hybrid roles that combine different aspects of data management. You will now explore the most common job roles in the world of data. Your organization may define roles differently or give them different names, but the roles described in this lesson encapsulate the most common division of labor and responsibilities. There are 3 key job roles that deal with data in most organizations. Database administrators manage databases, assigning permissions to users, storing backup copies of data, and restore data in case of any failures. Data engineers are vital in working with data, applying data cleaning routines, identifying business rules, and turning data into useful information. Data analysts explore and analyze data to create visualizations and charts to enable organizations to make informed decisions. Let's now take a closer look at the roles in the world of data. An Azure Database Administrator is responsible for the design, implementation, maintenance, and operational aspects of on-premises and cloud-based database solutions built on Azure Data Services and SQL Server. They are responsible for the overall availability and consistent performance and optimizations of the database solutions. They work with stakeholders to implement policies, tools, and processes for backup, and recovery plans to recover following a natural disaster or human-made error. The database administrator is also responsible for managing the security of the data in the database, granting privileges over the data, granting or denying access to users as appropriate. The data engineer collaborates with stakeholders to design and implement data-related assets that include data ingestion pipelines, cleansing, and transformation activities, and data stores for analytical workloads. They use a wide range of data platform technologies, including relational and non-relational databases, file stores, and data streams. They're also responsible for ensuring that the privacy of data is maintained within the cloud and spanning from on-premises to the cloud data stores. They also own the management and monitoring of data stores and data pipelines to ensure that data loads perform as expected. A data analyst enables businesses to maximize the value of their data assets. They're responsible for designing and building scalable models, cleaning and transforming data, and enabling advanced analytics capabilities through reports and visualizations. A data analyst processes raw data into relevant insights based on identified business requirements to deliver relevant insights. Database administrators are tasked with managing and organizing databases. A database administrator's primary job is to ensure that data is available, protected from loss, corruption, or theft, and is easily accessible as needed. Some of the most common roles and responsibilities of a database administrator include installing and upgrading the database server and application tools, allocating system storage and planning storage requirements for the database system, modifying the database structure as necessary from information given by application developers, and enrolling users and maintaining system security, ensuring compliance with database vendor license agreement, controlling and monitoring user access to the database, monitoring and optimizing the performance of the database, planning for backup and recovery of database information, maintaining archived data, backing up and restoring databases, contacting database vendor for technical support, generating various reports by querying from database as per need, and managing and monitoring data replication. Most database management systems provide their own set of tools to assist with database administration. For example, SQL Server database administrators use SQL Server Management Studio for most of their day-to-day database maintenance activities. Other systems have their own database-specific interfaces, such as pgadmin for PostgreSQL systems or MySQL Workbench for MySQL. There are also a number of cross-platform database administration tools available. One example is Azure Data Studio. Azure Data Studio provides a graphical user interface for managing many different database systems. It currently provides connections to on-premises SQL Server databases, Azure SQL Database, PostgreSQL, Azure SQL Data Warehouse, and SQL Server Big Data clusters, amongst others. It's an extensible tool, and you can download and install extensions from third-party developers that connect to other systems or provide wizards that help to automate many administrative tasks. SQL Server Management Studio provides a graphical interface enabling you to query data, perform general database administration tasks, and generate scripts for automating database maintenance and support operations. You can use SQL Server Management Studio to back up a database. You can also use it to generate transact SQL scripts for almost all of the functionality that SQL Server Management Studio provides. This gives the database administrator the ability to schedule and automate many common tasks. It's important to note that SQL is a standard language for storing, manipulating, and retrieving data in databases. Microsoft Transact SQL is a set of programming extensions from Microsoft that adds several features to the structure query language, including transaction control, exception and error handling, row processing, and declared variables. Azure SQL Database provides database services in Microsoft Azure. It's similar to SQL Server, except that it runs in the cloud. You can manage Azure SQL Database using the Azure portal. Typical configuration tasks, such as increasing the database size, creating a new database, and deleting an existing database, can be done using the Azure portal. You can use the Azure portal to dynamically manage and adjust resources such as the data storage size and the number of cores available for the database processing. These tasks would require the support of a system administrator if you were running a database on premises. Data engineers are tasked with managing and organizing data while also monitoring for trends or inconsistencies that would impact business goals. It's a highly technical position requiring experience and skills in areas like programming, mathematics, and computer science. But data engineers also need soft skills to communicate data trends to others in the organization and to help the business make use of the data it collects. Some of the most common roles and responsibilities of a data engineer include developing, constructing, testing, and maintaining databases and data structures, aligning the data architecture with business requirements, data acquisition, developing processes for creating and retrieving information from data sets, using programming languages and tools to examine the data, identifying ways to improve data reliability, efficiency, and quality, conducting research for industry and business questions, deploying sophisticated analytics programs, machine learning and statistical methods, preparing data for predictive and prescriptive modeling, and using data to discover tasks that can be automated. To master data engineering, you'll need to be familiar with a range of tools that enable you to create well-designed databases, optimized for the business processes that will be run. You must have a thorough understanding of the architecture of the database management system, the platform on which the system runs, and the business requirements for the data being stored in the database. If you're using a relational database management system, you'll need to be fluent in SQL. You must be able to use SQL to create databases, tables, indexes, views, and the other objects required by the database. Many database management systems provide tools that enable you to create and run SQL scripts. For example, SQL Server Management Studio, described earlier, lets you create and query tables visually, but you can also create your own SQL scripts manually. In some cases, you may need to interact with the database from the command line. Many database management systems provide a command line interface that supports these operations. For example, you can use the SQL command utility to connect to Microsoft SQL Server and Azure SQL Database and run ad hoc queries and commands. As a SQL Server professional, your primary data manipulation tool might be Transact SQL. As a data engineer, you might use additional technologies, such as Azure Databricks and Azure HD Insight, to generate and test predictive models. If you're working in the non-relational field, you might use Azure Cosmos DB as your primary data store. To manipulate and query the data, you might use languages such as HiveQL, R, or Python. Data analysts are responsible for understanding what data actually means. A skilled data analyst will explore the data and use it to determine trends, issues, and gain other insights that might be of benefit to the company. A large part of the data analyst role is concerned with communication and visualization. Data visualization is key to presenting large amounts of information in ways that are universally understandable, are easy to interpret, and spot patterns, trends, and correlations. These representations include charts, graphs, infographics, and other pictorial diagrams. Data visualization analysts use visualization tools and software to communicate information in these ways for clients or for their own company. A good data analyst requires experience and skills in reporting tools such as Microsoft Power BI and SQL Server reporting services. The primary functions of a data analyst usually include the following: making large or complex data more accessible, understandable, and usable, creating charts and graphs, histograms, geographical maps, and other visual models that help to explain the meaning of large volumes of data and isolate areas of interest, transforming, improving, and integrating data from many sources, depending on the business requirements, combining the data result sets across multiple sources. For example, combining sales data and weather data provides a useful insight into how weather influenced sales of certain products such as ice creams. Finding hidden patterns using data and delivering information in a useful and appealing way to users by creating rich graphical dashboards and reports. Traditionally, many data analysts used Microsoft Office apps, such as Microsoft Excel, for creating rich visual reports. Many analysts now use Microsoft Power BI, a powerful visualization platform, to create rich graphical dashboards and reports over data that can vary dynamically. Power BI is a collection of software services, apps, and connectors that work together to turn your unrelated sources of data into coherent, visually immersive, and interactive insights. Your data might be held somewhere local, such as an Excel spreadsheet, or in a collection of cloud-based and on-premises databases, or some other set of data sources. Power BI lets you easily connect to your data sources, discover what's important in that data, and share your findings with others in the organization. An analyst can create a dashboard using Power BI to examine retail sales data for items sold across multiple stores and districts. The metrics compare this year's performance to last year's for sales, units, gross margin, and variance, as well as new store analysis. Managing and working with data is a specialist skill. Most organizations define job roles for the various tasks responsible for managing data. In this lesson, you have learned some of the common job roles for handling data, the tasks typically performed by these job roles, and the types of tools that they use.
Hello and welcome to Azure Fundamentals. In this lesson, you'll take an entry-level, end-to-end look at Azure and its capabilities. You'll gain a solid foundation on Azure fundamentals that you will rely on throughout the rest of this course. In this lesson, you will be introduced to the basics of cloud computing. You will get a big picture view of the available services and features in Azure and determine whether Azure is the right solution for your needs. And if you're new to Azure, you can sign up for a free account on the Azure website to start exploring. At this point, you may have some questions, like what is Azure and what can it do for your business? When you've completed this lesson, you'll have the answers to these questions. Microsoft Azure is a cloud computing platform with an ever-expanding set of services. Azure gives you the freedom to build, manage, and deploy applications on a massive global network using your favorite tools and frameworks. The Azure Cloud Platform has more than 200 products and cloud services that you can use to build, run, and manage applications across multiple clouds, on-premises, and at the edge. It delivers computing services over the internet, including servers, storage, databases, networking, software, analytics, and intelligence. Azure Cloud Computing offers faster innovation, flexible resources, and economies of scale. The cloud helps you move faster and innovate in ways that were once nearly impossible. But critically, it does this while lowering your costs. Cloud computing provides computing services over the internet using a pay-as-you-go pricing model. Typically, you only pay for the cloud services you use, which helps you lower your operating costs, run your infrastructure more efficiently, and scale as your business needs change. To put it another way, cloud computing is a way to rent compute power and storage from someone else's data center. When you're done using them, you give them back. You're billed only for what you use. Instead of maintaining CPUs and storage in your data center, you rent them for the time that you need them. The cloud provider takes care of maintaining the underlying infrastructure for you. The cloud enables you to quickly solve your toughest business challenges and bring cutting-edge solutions to your users. In our ever-changing digital world, two trends emerge. Teams deliver new features to their users at record speeds, and users expect an increasingly rich and immersive experience with their devices and with software. To power your services and deliver innovative and novel user experiences more quickly, the cloud provides on-demand access to a nearly limitless pool of raw compute, storage, and networking components. Speech recognition and other cognitive services that help make your applications stand out from the crowd. Analytics services that deliver telemetry data from your software and devices. You were briefly introduced to Azure at the beginning of this lesson. By the end of this video, you should be able to determine whether Azure is the right solution for your business needs. Azure runs business applications by providing global scale, consistency, and seamless integration with on-premises environments. With help from Azure, businesses have everything they need to build the next great solution. Let's explore several benefits that Azure offers. Azure offers businesses the option to be ready for the future. Continuous innovation from Microsoft supports development today and product visions for tomorrow. Build on your terms. You have choices. With a commitment to open source and support for all languages and frameworks, businesses can build how they want and deploy where they want to. Operate hybrid seamlessly. They can integrate and manage their environments with tools and services designed for a hybrid cloud solution. Trust your cloud. Get security from the ground up, backed by a team of experts, and proactive compliance trusted by enterprises, governments, and startups. Now that you have an overview of some of the benefits Azure offers, let's take a look at what you can do with Azure. Many teams start exploring the cloud by moving their existing applications to virtual machines that run in Azure. Migrating your existing apps to virtual machines is a good start. But the cloud is much more than a different place to run your virtual machine. Imagine communicating naturally with your users through vision, hearing, and speech using AI and machine learning services. With Azure, you can explore everything from running existing applications on virtual machines to using new software paradigms such as intelligence bots and mixed reality. Azure also provides storage solutions that dynamically grow to accommodate massive amounts of data. You may be wondering how Azure can help you to manage your cloud resources. Imagine an integrated, easy-to-use console built just for you. The Azure portal is exactly that, a web-based unified console that provides an alternative to command line tools. You can organize the Azure portal to custom fit your workflow, projects, and style. With the Azure portal, you can manage your Azure subscription by using a graphical user interface. You can build, manage, and monitor everything from simple web apps to complex cloud deployments. Create custom dashboards for an organized view of resources, and configure accessibility options for an optimal experience. The Azure portal is designed for resiliency and continuous availability. It maintains a presence in every Azure data center. The Azure portal updates continuously and requires no downtime for maintenance activities. This configuration makes the Azure portal resilient to individual data center failures and avoids network slowdowns by being close to users. Azure Marketplace helps connect users with Microsoft partners, independent software vendors, and startups that are offering their solutions and services, which are optimized to run on Azure. Azure Marketplace customers can find, try, purchase, and provision applications and services from hundreds of leading service providers. All solutions and services are certified to run on Azure. The solution catalog spans several industry categories. These include virtual machine images, databases, application build and deployment software, development tools, threat detection, and blockchain. Azure Marketplace is designed for IT pros and cloud developers interested in commercial and IT software. Microsoft partners also use it as a launch point for all joint go-to-market activities. Using Azure Marketplace, you can provision end-to-end solutions quickly and reliably, hosted in your own Azure environment. To explore the Azure Marketplace online, you can access the link in the resource section at the end of this lesson. Throughout the Azure Fundamentals learning paths, we'll work with Tailwind Traders, a fictitious home improvement retailer. It operates retail hardware stores across the globe and online. Tailwind Traders currently manages an on-premises data center that hosts the company's retail website. The data center also stores all of the data and streaming video for its applications. Let's suppose that you work as an IT specialist in Tailwind Traders' IT department. Your IT team buys new hardware, installs and configures software, and deploys everything throughout the data center. These management responsibilities create some obstacles for delivering your applications to your users in a timely fashion. As an IT professional, you realize it will be advantageous to have servers, storage, databases, and other services immediately available when you develop and deploy applications. You want to be able to easily start a new server or add services to your solutions. Throughout this course, you'll learn about some of the cloud-based services that Tailwind Traders can use to address its technology challenges. With that in mind, the services that are available through Azure can help Tailwind Traders conduct its business more efficiently. As you complete the various modules in the Azure Fundamentals learning paths, we'll analyze the challenges that Tailwind Traders is facing. You'll see how you can use Azure services to address each of the issues as they arise. After you've completed each of the modules, the knowledge that you gained from resolving the hypothetical challenges that the fictional Tailwind Traders company encountered should benefit you in your real-world environments. Hello and welcome to Azure Fundamental Concepts and Architectural Components. In this module, you'll learn about the main concepts of cloud computing and how Azure implements these concepts. We will also see in our case study how Tailwind Traders can benefit from migrating to a cloud computing environment. More specifically, after completing this lesson, you will identify benefits and considerations of using cloud services. You will describe the differences between categories of cloud services, and you will describe the differences between types of cloud computing. So let's dive right into our case study. You work in the IT department for Tailwind Traders, which has decided to migrate its applications and data to Microsoft Azure. You're aware that cloud computing will save your company time and money by migrating from your existing on-premises physical hardware to a cloud solution. With this new solution, you'll only need to pay for the resources and computing time that you use. However, some of the cloud computing concepts are new to many members of your IT staff. They've been asking some specific questions about what cloud computing can do for them. For example, the team that manages Tailwind Trader's website wants to know how Azure improves the site's availability and scalability. The team that handles the deployment of new hardware is curious to see how cloud computing can make their deployment processes faster. In addition, your developer team wants to learn about the different options available to them as they are designing new applications. For example, is there a way to run their applications in a hybrid configuration, where part of their application runs on-premises and the rest of the application runs in the cloud? There are several benefits that a cloud environment has over a physical environment. For example, cloud-based applications employ a myriad of related strategies. High availability. Depending on the service level agreement that you choose, your cloud-based applications can provide a continuous user experience with no apparent downtime, even when things go wrong. Scalability. Applications in the cloud can be scaled in two ways. Vertically, computing capacity can be increased by adding RAM or CPUs to a virtual machine. Horizontally, computing capacity can be increased by adding instances of a resource, such as adding more virtual machines to your configuration. Elasticity. Cloud-based applications can be configured to take advantage of auto-scaling, so your applications will always have the resources they need. Agility. Cloud-based resources can be deployed and configured quickly as your application requirements change. Geo-distribution. Applications and data can be deployed to regional data centers around the globe, so your customers always have the best performance in their region. And disaster recovery. By taking advantage of cloud-based backup services, data replication, and geo-distribution, you can deploy your applications with the confidence that comes from knowing that your data is safe in the event that disaster should occur. Cloud service providers operate on a consumption-based model, which means that end users only pay for the resources that they use. Whatever they use is what they pay for. A consumption-based model has many benefits, including no upfront costs, no need to purchase and manage costly infrastructure that users might not use to its fullest, the ability to pay for additional resources when they are needed, the ability to stop paying for resources that are no longer needed. When analysing the benefits of cloud computing, there are two different types of expenses that you should consider. Capital expenditure, or CapEx, operational expenditure, or OpEx. Capital expenditure, or CapEx, is the upfront spending of money on physical infrastructure, and then deducting that upfront expense over time. The upfront cost from CapEx has a value that reduces over time. Operational expenditure, or OpEx, is where you spend money on products or services and are billed for them at the moment of use. You can think of these as the day-to-day expenses that are paid for immediately. In other words, when Tailwind Traders owns its infrastructure, it buys equipment that goes onto its balance sheets as assets. Because a capital investment was made, accountants categorize this transaction as a CapEx. Over time, to account for the asset's limited useful lifespan, assets are depreciated or amortized. Cloud services, on the other hand, are categorized as an OpEx because of their consumption model. There's no asset for Tailwind Traders to amortize, and its cloud service provider, Azure, manages the costs that are associated with the purchase and lifespan of the physical equipment. As a result, OpEx has a direct impact on net profit, taxable income, and the associated expenses on the balance sheet. To summarize, CapEx requires significant upfront financial costs as well as ongoing maintenance and support expenditures. By contrast, OpEx is a consumption-based model, so Tailwind Traders is only responsible for the cost of the computing resources that it uses. If you've been around cloud computing for a while, you've probably seen the terms infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS, for the different cloud service models. These models define the different level of shared responsibility that a cloud provider and cloud tenant are responsible for. IaaS is the most flexible category of cloud services. It aims to give you complete control over the hardware that runs your application. Instead of buying hardware, with IaaS, you rent it. PaaS provides the same benefits and considerations as IaaS, but there are some additional benefits. SaaS is software that's centrally hosted and managed for you and your users or customers. Usually one version of the application is used for all customers, and it's licensed through a monthly or annual subscription. SaaS provides the same benefits as IaaS, but again, there are some additional benefits. You can see how when you move from IaaS to PaaS to SaaS, the shared responsibilities reduces for the client and increases for the provider. This chart illustrates the various levels of responsibility between a cloud provider and a cloud tenant. As you move from on-premises through IaaS and PaaS to SaaS, the responsibility for maintaining infrastructure, platform, and software responsibilities progressively transfer to the provider from the tenant. Like PaaS, serverless computing enables developers to build applications faster by eliminating the need for them to manage infrastructure. With serverless applications, the cloud service provider automatically provisions, scales, and manages the infrastructure required to run the code. Serverless architectures are highly scalable and event-driven, only using resources when a specific function or trigger occurs. It's important to note that servers are still running the code. The serverless name comes from the fact that the tasks associated with infrastructure provisioning and management are invisible to the developer. This approach enables developers to increase their focus on the business logic and deliver more value to the core of the business. Serverless computing helps teams increase their productivity and bring products to market faster. And it allows organizations to better optimize resources and stay focused on innovation. There are 3 deployment models for cloud computing: public cloud, private cloud, and hybrid cloud. Each deployment model has different aspects that you should consider as you migrate to the cloud. In a public cloud, services are offered over the public internet and available to anyone who wants to purchase them. Cloud resources such as servers and storage are owned and operated by a third-party cloud service provider and delivered over the internet. A private cloud consists of computing resources used exclusively by users from one business or organization. A private cloud can be physically located at your organization's on-site or on-premises data center. It can also be hosted by a third-party service provider. In the third model, hybrid cloud computing environments combine a public cloud and a private cloud by allowing data and applications to be shared between them. This image illustrates several of the cloud computing concepts that are presented in this unit. In this example, several factors are demonstrated when you are considering where to deploy a database server in a hybrid cloud environment. As your resources move from on-premises to off-premises, your costs are reduced and your administration requirements decrease.
Hello, and welcome to this module where you will explore the concepts of relational and non-relational data. In this lesson, you'll learn about the key characteristics of relational data and explore relational data structures. In the early years of databases, every application stored data in its own unique structure. When developers wanted to build applications to use that data, they had to know a lot about the particular data structure to find the data they needed. These data structures were inefficient, hard to maintain, and hard to optimize for delivering good application performance. The relational database model was designed to solve the problem of multiple arbitrary data structures. The relational model provided a standard way of representing and querying data that could be used by any application. From the beginning, developers recognized that the chief strength of the relational database model was in its use of tables, which were an intuitive, efficient, and a flexible way to store and access structured information. The simple yet powerful relational model is used by organizations of all types and sizes for a broad variety of information management needs. Relational databases are used to track inventories, process e-commerce transactions, manage huge amounts of mission-critical customer information, and much more. A relational database is useful for storing any information containing related data elements that must be organized in a rules-based, consistent way. In this part, you will explore the characteristics of relational data, define tables, indexes, and views, and explore relational data workload offerings in Microsoft Azure. One of the main benefits of computer databases is that they make it easy to store information so it's quick and easy to find. For example, an e-commerce system might use a database to record information about the products an organization sells and the details of customers and the orders they've placed. A relational database provides a model for storing the data and a query capability that enables you to retrieve data quickly. In this video, you'll learn more about the characteristics of relational data and how you can store this information and query it in a relational database. In a relational database, you model collections of entities from the real world as tables. An entity is described as a thing about which information needs to be known or held. In the e-commerce example, you might create tables for customers, products, and orders. A table contains rows, and each row represents a single instance of an entity. In the e-commerce scenario, each row in the customer's table contains the data for a single customer. Each row in the products table defines a single product, and each row in the orders table represents an order made by a customer. When it comes to naming conventions for databases, it's best practice to always name your objects, such as entities and fields, using only one word. Try to avoid using spaces between words. Common best practices include the use of either camel case, Pascal case, or underscores. The examples shown in this lesson are all demonstrated with camel case, where the two words are joined together but each word starts with a capital letter. The rows in a table have one or more columns that define the properties of the entity, such as the customer name or product ID. All rows in the same table have the same columns. It's best practice to always name your entities and their fields using only one word, so avoid using spaces between words. In this example, you can see that the field names are all one word. For example, customer ID and customer name. Some columns are used to maintain relationships between tables. This is where the relational model gets its name from. In an example, you could have an orders table containing both a customer ID and a product ID. The customer ID relates to the customer's table to identify the customer that placed the order, and the product ID relates to the products table to indicate what product was purchased. You design a relational database by creating a data model. This model shows the structure of the entities from the previous example. Columns that are marked PK are the primary keys for the tables. The primary key indicates the column or combination of columns that uniquely identify each row. Every table should have a primary key. A data model diagram shows the relationships between the tables. The lines connecting the tables indicate the type of relationship. In this case, the relationship from customers to orders is one-to-many, as one customer can place many orders, but each order is for a single customer. Similarly, the relationship between orders and products is many-to-one, as several orders might be for the same product. The columns marked FK are foreign key columns. They reference or link to the primary key of another table and are used to maintain the relationships between tables. A foreign key also helps to identify and prevent anomalies, such as orders for customers that don't exist in the customer's table. The foreign keys for customer ID and product ID in the orders table link to the customer that placed the order and the product that was ordered. The main characteristics of a relational database can be described by the following. All data is tabular. Entities are modeled as tables. Each instance of an entity is a row in the table, and each property is defined as a column. All rows in the same table have the same set of columns. A table can contain any number of rows. A primary key uniquely identifies each row in a table. No two rows can share the same primary key. And lastly, a foreign key references rows in another related table. For each value in the foreign key column, there should be a row with the same value in the corresponding primary key column in the other table. Now for a word of note. Creating a relational database model for a large organization is not a trivial task. It can take several iterations to define tables to match the characteristics described earlier. Sometimes you have to split an entity into more than one table. This process is called normalization. So far, you have learned that a relational database comprises a set of tables. A table can have 0 if the table is empty, or more rows. Each table has a fixed set of columns. You can define relationships between tables using primary and foreign keys, and you can access the data in tables using SQL. Apart from tables, a typical relational database contains other structures that help to optimize data organization and improve the speed of access. In this lesson, you'll look at 2 of these structures in more detail: indexes and views. An index helps you search for data in a table. Think of an index over a table like an index at the back of a book. A book index contains a sorted set of references, with the pages on which each reference occurs. When you want to find a reference to an item in the book, you look it up through the index. You can use the page numbers in the index to go directly to the correct pages in the book. Without an index, you might have to read through the entire book to find the references you're looking for. When you create an index in a database, you specify a column from the table, and the index contains a copy of this data in a sorted order, with pointers to the corresponding rows in the table. When the user runs a query that specifies this column in the where clause, the database management system can use this index to fetch the data more quickly than if it had to scan through the entire table row by row. In this example, the query retrieves all orders for customer C1. The orders table has an index on the customer ID column. The database management system can then consult the index to quickly find all matching rows in the orders table. You can create many indexes on a table. So, if you also wanted to find all orders for a specific product, then creating another index on the product ID column in the orders table would be useful. However, indexes aren't free. They will inevitably come with some sort of trade-off. For example, an index might consume additional storage space, and each time you insert, update, or delete data in a table, the indexes for that table must be maintained. This additional work can slow down insert, update, and delete operations and incur additional processing charges. Therefore, when deciding which indexes to create, you must strike a balance between having indexes that speed up your queries versus the cost of performing other operations. In a table that is read-only, or that contains data that is modified infrequently, more indexes may improve query performance. If a table is subject to a large number of inserts, updates, and deletes, such as a table involved in OLTP, then creating too many indexes on that table can slow your system down. Some relational database management systems also support clustered indexes. A clustered index physically reorganizes a table by the index key. This arrangement can improve the performance of queries still further, because the relational database management system doesn't have to follow references from the index to find the corresponding data in the underlying table. You can have an orders table with a clustered index on the customer ID column. The customer ID column is ordered in ascending order from C1 to C3. It's worth noting that in database management systems that support them, a table can only have a single clustered index. Let's talk about views now. A view is a virtual table based on the result set of a query. In the simplest case, you can think of a view as a window on specified rows in an underlying table. For example, you could create a view called P1 Orders on the orders table that lists the orders for a specific product, in this case, product P1. You can query the view and filter the data in much the same way as a table. The following query finds the orders for customer C1 using the view. This select query will only return orders for product P1 made by the customer. A view can also display data from tables joined together. For example, this would be useful if you regularly needed to find the details of customers and the products that they have ordered. In this case, we have used createView statement to create a view based on the join query example that we covered earlier. Now that we have created the customer's products view, we can query it to find the customer name and product names of all orders placed by customer C2. To summarize, you can think of a view as a stored query. The user does not need to know where the data is stored or the complexity of the query. They have immediate access to the relevant data. Cloud computing has grown in popularity, promising flexibility for enterprises, opportunities for saving time and money, and improving agility and scalability. On the other hand, on-premises software installed on a company's own servers and behind its firewall still has its appeal. On-premises applications are reliable, secure, and allow enterprises to maintain close control. Relational Database Management Systems, or RDBMS, are one example of where the cloud has enabled organizations to take advantage of improved scalability. However, this scalability has to be balanced against the need for close control over the data. Data is arguably one of the most valuable assets that an organization has, and some companies aren't willing or able to hand over responsibility for protecting this data to a third party. In this lesson, you'll look at some of the advantages and disadvantages of running a database management system in the cloud. Whether a company places its relational workload in the cloud or whether it decides to keep it on-premises, data security will always be paramount. But for those businesses in highly regulated industries, the decision might already be made for them as to whether to host their applications on-premises. Knowing that your data is located within your in-house servers and IT infrastructure might also provide more peace of mind. Hosting a relational database on-premises requires that an enterprise not only purchases the database software, but also maintains the necessary hardware on which to run the database. The organization is responsible for maintaining the hardware and software, applying patches, backing up databases, restoring them when necessary, and generally performing all day-to-day management required to keep the platform operational. Scalability is also a concern. If you need to scale your system, you will need to upgrade or add more servers. You then need to expand your database onto these servers. This can be a formidable task that requires you to take a database offline while the operation is performed. In the cloud, many of these operations can be handled for you by the data center staff, in many cases with no or minimal downtime. You're free to focus on the data itself and leave the management concerns to others. This is what you pay your Microsoft Azure fees for, after all. A cloud-based approach uses virtual technology to host a company's applications off-site. There are no capital expenses. Data can be backed up regularly, and companies only have to pay for the resources they use. For those organizations that plan aggressive expansion on a global basis, the cloud has even greater appeal because it allows you to connect with customers, partners, and other businesses anywhere with minimal effort. Additionally, cloud computing gives you nearly instant provisioning because everything is already configured. Therefore, any new software that is integrated into your environment is ready to use immediately once a company has subscribed. With instant provisioning, any time spent on installation and configuration is eliminated and users can access the application right away. This diagram illustrates the operations available when comparing on-premises operations to the cloud. With on-premises, you have personal control of data security and low operational expenditure. In contrast, cloud-based operations are more scalable, offer hardware and software maintenance, and low capital expenditure. If you decide that you are indeed moving your operations to the cloud, You generally have two options. You can select either an IaaS approach or a PaaS approach. IaaS is an acronym for Infrastructure as a Service. Using the IaaS approach, Microsoft Azure enables you to create a virtual infrastructure in the cloud that mirrors the way an on-premises data center might work. You can create a set of virtual machines, connect them together using a virtual network, and add a range of virtual devices. In many ways, this approach is similar to the way in which you run your systems inside an organization, except that you don't have to concern yourself with buying or maintaining the hardware. However, you're still responsible for many of the day-to-day operations, such as installing and configuring the software, patching, taking backups, and restoring data when needed. You can think of IaaS as a halfway house to fully manage operations in the cloud. You don't have to worry about the hardware, but running and managing the software is still very much your responsibility. You can run any software for which you have the appropriate licenses using this approach. You're not restricted to any specific database management system. The IaaS approach is best for migrations and applications requiring operating system level access. SQL virtual machines are lift and shift. That is, you can copy your on-premises solution directly onto a virtual machine in the cloud. The system should work more or less exactly as before in its new location, except for some small configuration changes. For example, changes in network addresses to take account of the change in environment. PaaS is an acronym for Platform as a Service. Rather than creating a virtual infrastructure and installing and managing the database software yourself, a PaaS solution does this for you. You specify the resources that you require based on how large you think your databases will be, the number of users, and the performance you require. And Microsoft Azure automatically creates the necessary virtual machines, networks, and other devices for you. You can usually scale up or down, that is, increase or decrease the size and number of resources quickly as the volume of data and the amount of work being done varies. Microsoft Azure handles this scaling for you, and you don't have to manually add or remove virtual machines or perform any other form of configuration. Microsoft Azure currently offers several PaaS solutions for relational databases. Some of these include Azure SQL Database, Azure Database for PostgreSQL, Azure Database for MySQL, and Azure Database for MariaDB. These services run managed versions of the database management systems on your behalf. You just connect to them, create your databases, and upload your data. However, you may find that there are some functional restrictions in place, and not every feature of your selected database management system may be available. These restrictions are often due to security issues. For example, they might not expose the underlying operating system and hardware to your applications. In these cases, you may need to rework your applications to remove any dependencies on these features. There are benefits and trade-offs when running database management systems with SQL Server. The administrative effort and capital expenditure and day-to-day control increase as you move from PaaS to IaaS to on-premises approaches. The physical on-premises solution requires higher capital expenditure, but the greatest level of physical control. This is compared to using virtual machines in Microsoft Azure, the IaaS approach, or Azure SQL Database, the PaaS approach. The PaaS solution requires the lowest administrative effort and capital expenditure. The same generalized considerations are true for other database management systems. Relational databases are widely used for building real-world applications. Understanding the characteristics of relational data is important. A relational database is based on tables. You can run many database management systems on premises and in the cloud. In this lesson, you have learned the characteristics of relational data, what are tables, indexes, and views, and the various relational data workload offerings available in Microsoft Azure. Hello and welcome to this lesson where you will explore the concepts of non-relational data. Data comes in all shapes and sizes and can be used for many purposes. Many organizations use relational databases to store this data. However, the relational model might not be the most appropriate structure. The format of the data might be too varied to easily model as a set of relational tables. For example, the data might contain items such as video, audio, images, temporal information, large volumes of free text, or other types of data that aren't inherently relational. Additionally, the data processing requirements might not be best suited by attempting to convert this data into the relational format. In these situations, it may be better to use non-relational repositories that can store data in its original format, but that allow fast storage and retrieval access to this data. Suppose you're a data engineer working at Contoso, an organization with a large manufacturing operation. The organization has to gather and store information from a range of sources, such as real-time data monitoring of the status of production line machinery, product quality control data, historical production logs, product volumes in stock, and raw materials inventory data. This information is critical to the operation of the organization. You have been asked to determine how best to store this information so that it can be stored quickly and queried easily. In this lesson, you will explore the characteristics of non-relational data, define types of non-relational data, and describe NoSQL and the types of non-relational databases. Relational databases are an excellent tool for storing and retrieving data that has a well-known structure, containing fields that you can define in advance. In some situations, you might not have the required knowledge of the structure of your data in advance of it arriving in your database to record it as a neat set of rows and columns in a tabular format. This is a common scenario in systems that consume data from a wide variety of sources, such as data ingestion pipelines. In these situations, a non-relational database can prove extremely useful. Now, you look in more detail at the common characteristics of non-relational databases. You learn how they enable you to capture data quickly and model data that can vary in structure. You use a database to model some aspect of the real world. Entities in the real world often have highly variable structures. For example, in an e-commerce database that stores information about customers, how many telephone numbers does a customer have? A customer might have a landline and a mobile number, but some customers might have a business number, an additional home number, and maybe several mobile numbers. Similarly, the addresses of customers might not always follow the same format. Addresses for customers in different states and regions might contain different elements, such as zip codes or postal codes. In another scenario, if you are ingesting data rapidly, you want to capture the data and save it very quickly. Processing the data and manipulating it into a set of rows in different tables in a relational database might not be appropriate at this point. You can perform these tasks at a later date. At the time of ingestion, you simply need to store the data in its original state and format. The data can be processed and sorted at a later date. A key aspect of non-relational databases is that they enable you to store data in a very flexible manner. Non-relational databases don't impose a schema on data. Instead, they focus on the data itself rather than how to structure it. This approach means that you can store information in a natural format that mirrors the way in which you would consume, query, and use it. In a non-relational system, you store the information for entities in collections or containers rather than relational tables. Two entities in the same collection can have a different set of fields rather than a regular set of columns found in a relational table. The lack of a fixed schema means that each entity must be self-describing. Often this is achieved by labeling each field with the name of the data that it represents. For example, fields are prefixed with a name, such as ID, name, telephone, and address. Fields might also have multiple subfields, also with names. Multiple subfields are denoted by enclosing them between square brackets. Adding a new customer is a matter of inserting an entity with its fields labelled in a meaningful way. An application that queries this data must be prepared to parse the information in the entity that it retrieves. The data retrieval capabilities of a non-relational database can vary. Each entity should have a unique key value. The entities in a collection are usually stored in key value order. Going back to our example customer's code, the unique key is the ID field. The simplest type of non-relational database enables an application to either specify the unique key or a range of keys as query criteria. A query can fetch the details of a customer by the ID. By referencing the ID, the query can quickly identify which entity to retrieve. Contrast this to a query that attempts to find all customers with a UK address. This query would have to iterate through every entity, and for each entity, examine each field in turn, and then apply any query criteria to find any matches. If the database contains many millions of entities, this query could take a considerable time to run. More advanced non-relational systems support indexing, in a similar manner to an index in a relational database. Queries can then use the index to identify and fetch data based on non-key fields. Non-relational systems such as Azure Cosmos DB, a non-relational database management system available in Microsoft Azure, support indexing even when the structure of the indexed data can vary from record to record. When you design a non-relational database, it's important to understand the capabilities of the database management system and the types of query it will have to support. For more information, read Indexing in Azure Cosmos DB Overview. It's important to note that non-relational databases often provide their own proprietary language for managing and querying data. This language may be procedural, follow a set of commands in order, or it may be similar to SQL. It depends on how the database is implemented by the database management system. Non-relational databases are highly suitable for some business scenarios. These include the Internet of Things, or IoT, and telematics, retail and marketing, gaming, and finally, web and mobile applications. Let's take a look at each of these in a little more detail now. Starting with IoT and telematics. These systems typically ingest large amounts of data in frequent bursts of activity. Non-relational databases can store this information very quickly. The data can then be used by analytic services such as Azure Machine Learning, Azure HD Insight, and Microsoft Power BI. Additionally, you can process the data in real time using Azure functions that are triggered as data arrives in the database. Now let's take a look at retail and marketing. Microsoft uses Cosmos DB for its own e-commerce platforms that run as part of Windows Store and Xbox Live. It's also used in the retail industry for storing catalog data and for event sourcing in order processing pipelines. For gaming, the database tier is a crucial component of gaming applications. Modern games perform graphical processing on mobile console clients, but rely on the cloud to deliver customized and personalized content, like in-game stats, social media integration, and high-score leaderboards. Games often require single-millisecond latencies for reads and writes to provide an engaging in-game experience. Finally, a game database needs to be fast and be able to handle massive spikes in request rates during new game launches and feature updates. The last scenario is web and mobile applications. A non-relational database such as Azure Cosmos DB is commonly used within web and mobile applications and is well suited for modeling social interactions, integrating with third-party services, and for building rich, personalized experiences. The Cosmos DB SDKs, or software development kits, can be used to build rich iOS and Android applications using the popular Xamarin framework. A relational database restructures the data into a fixed format that is designed to answer specific queries. When data needs to be ingested very quickly, or the query is unknown and unconstrained, a relational database can be less suitable than a non-relational database. Non-relational data generally falls into two categories: semi-structured and non-structured. Now you learn about what these terms mean and see some examples. Semi-structured data is data that contains fields. The fields don't have to be the same in every entity. You only define the fields that you need on a per entity basis. The customer entities shown in the previous video are examples of semi-structured data. The data must be formatted in such a way that an application can parse and process it. One common way of doing this is to store the data for each entity as a JSON document. The term JSON stands for JavaScript Object Notation. It's the format used by JavaScript applications to store data in memory, but can also be used to read and write documents to and from files. A JSON document is enclosed in curly brackets. Each field has a name, a label, followed by a colon, and then the value of the field. Fields can contain simple values or sub-documents, each starting and ending with curly brackets. Fields can also have multiple values, held as arrays and surrounded with square brackets. Literals, or fixed values, in a field are enclosed in quotes, and fields are separated with commas. Fields might also have multiple subfields, also with names. In the example, multiple subfields are denoted by enclosing them between square brackets. The customer data that we worked with earlier is formatted as JSON documents. There is an extra field called title for the customer with the ID of 2. You can learn more about JSON on the Microsoft website from the JSON Data in SQL Server page. You're free to define whatever fields you like. The important point is that the data follows the JSON grammar or syntax. When an application reads a document, it can use a JSON parser to break up the document into its component fields and extract the individual pieces of data. Other formats you might see include Avro, ORC, and Parquet. Let's take a brief look at each now. Avro is a row-based format. It was created by Apache. Each record contains a header that describes the structure of the data in the record. The header is stored as JSON. The data is stored as binary information. An application uses the information in the header to parse the binary data and extract the fields it contains. Avro is a very good format for compressing data and minimizing storage and network bandwidth. ORC, or Optimized Row Columnar format, organizes data into columns rather than rows. It was developed by Hortonworks for optimizing read and write operations in Apache Hive. Hive is a data warehouse system that supports fast data summarization and querying over very large datasets. Hive supports SQL-like queries over unstructured data. An ORC file contains stripes of data. Each stripe holds the data for a column or set of columns. A stripe contains an index into the rows in the stripe, the data for each row, and a footer that holds statistical information, count, sum, max, min, and so on, for each column. Parquet is another columnar data format. It was created by Cloudera and Twitter. A Parquet file contains row groups. Data for each column is stored together in the same row group. Each row group contains one or more chunks of data. A Parquet file includes metadata that describes the set of rows found in each chunk. An application can use this metadata to quickly locate the correct chunk for a given set of rows and retrieve the data in the specified columns for these rows. Parquet specializes in storing and processing nested data types efficiently. It supports very efficient compression and encoding schemes. Unstructured data is data that doesn't naturally contain fields. Examples of unstructured data include audio, video, and other media streams. Each item is an amorphous blob of binary data. You can't search for specific elements in this data. You might choose to store data such as this in storage that is specifically designed for the purpose. In Microsoft Azure, you would probably store video and audio data as block blobs in an Azure storage account. The term blob stands for binary large object. A block blob only supports basic read and write operations. You could also consider files as a form of unstructured data, although in some cases a file might include metadata that indicates what type of file it is, for example, a photograph, Word document, Excel spreadsheet, and so on. The file might also contain metadata, such as owner and other elements that could be stored as fields. However, the main content of the file is unstructured. Non-relational data is an all-encompassing term that means anything not structured as a set of tables. There are many different types of non-structured data, and the information is used for a wide variety of purposes. Consequently, there are many different types of non-relational database management systems, each oriented towards a specific set of scenarios. Now, you learn about some of the most common types of non-relational databases. You might see the term NoSQL when reading about non-relational databases. NoSQL is a rather loose term that simply means non-relational. There's some debate about whether it's intended to imply not SQL or not only SQL. Some non-relational databases support a version of SQL adapted for documents rather than tables. Examples include Azure Cosmos DB. NoSQL non-relational databases generally fall into 4 categories: key-value stores, document databases, column family databases, and graph databases. Next, you will explore some common types of NoSQL databases. A key-value store is the simplest and often quickest type of NoSQL database for inserting and querying data. Each data item in a key-value store has 2 elements, a key and a value. The key uniquely identifies the item, and the value holds the data for the item. The value is opaque to the database management system. Items are stored in key order. It's important to note the term opaque means that the database management system just sees the value as an unstructured block. Only the application understands how the data in the value is structured and what fields it contains. The opposite of opaque is transparent. If the data is transparent, the database management system understands how the fields in the data are organized. A relational table is an example of a transparent structure. A query specifies the keys to identify the items to be retrieved. You can't search on values. An application that retrieves data from a key-value store is responsible for parsing the contents of the values returned. Write operations are restricted to inserts and deletes. If you need to update an item, you must retrieve the item, modify it in memory, in the application, and then write it back to the database, overwriting the original, effectively a delete and an insert. The focus of a key-value store is the ability to read and write data very quickly. Search capabilities are secondary. A key-value store is an excellent choice for data ingestion. When a large volume of data arrives as a continual stream and must be stored immediately. Azure Table Storage is an example of a key-value store. Cosmos DB also implements a key-value store using the Table API. A document database represents the opposite end of the NoSQL spectrum from a key-value store. In a document database, each document has a unique ID, but the fields in the documents are transparent to the database management system. Document databases typically store data in JSON format, as described in the previous lesson, or they could store data in common formats such as XML, YAML, and BSON. Documents could even be stored as plain text. The fields in documents are exposed to the storage management system, enabling an application to query and filter data by using the values in these fields. Typically, a document contains the entire data for an entity. What items constitute an entity are application specific. For example, an entity could contain the details of a customer, an order, or a combination of both. A single document may contain information that would generally be spread across several relational tables in a relational database management system. A document store does not require that all documents have the same structure. This free-form approach provides a great deal of flexibility. Applications can store different data in documents as business requirements change. An application can retrieve documents by using the document key. The key is a unique identifier for the document. Some document databases create the document key automatically. Others enable you to specify an attribute of the document to use as the key. The application can also query documents based on the value of one or more fields. Some document databases support indexing to facilitate fast lookup of documents based on one or more indexed fields. Some document database management systems support in-place updates, enabling an application to modify the values of specific fields in a document without rewriting the entire document. Other document database management systems, such as Cosmos DB, can only read and write entire documents. In these cases, an update replaces the entire document with a new version. This approach helps to reduce fragmentation in the database, which can, in turn, improve performance. Most document databases will ingest large volumes of data more rapidly than a relational database, but aren't as optimal as a key value store for this type of processing. The focus of a document database is its query capabilities. Azure Cosmos DB implements a document database approach in its core SQL API. A column family database organizes data into rows and columns. Examples of this structure include ORC and Parquet files described previously. In its simplest form, a column family database can appear very similar to a relational database, at least conceptually. The real power of a column family database lies in its denormalized approach to structuring sparse data. For example, if you need to store information about customers and their addresses in a relational database, ignoring the need to maintain historical data as described in the previous section, you might design a schema similar to the example diagram on screen. The customers and address schema and their corresponding tables are populated with some sample data. Customer 1 and Customer 2 share the same address, and the schema ensures that this address information is not duplicated. This is a standard way of implementing a one-to-many relationship. The relational model supports a very generalized approach to implementing this type of relationship. But to find the address of any given customer, an application needs to run a query that joins two tables. If this is the most common query performed by the application, then the overhead associated with performing this join operation can quickly become significant if there are a large number of requests and the tables themselves are large. The purpose of a column family database is to efficiently handle situations like this. You can think of a column family database as holding tabular data comprising rows and columns, but you can divide the columns into groups known as column families. Each column family holds a set of columns that are logically related together. The customer's example shows one way of structuring the same information as the previous customer's example. By using a column family database, the data is grouped into two column families holding the customer information and address information. Other ways of organizing columns are possible, but you should implement your column families to optimize the most common queries that your application performs. In this case, queries that retrieve the addresses of customers can fetch the data with fewer reads than would be required in the corresponding relational database. These queries can fetch the data directly from the address info column family. Each row in a column family database contains a key, and you can fetch the data for a row by using this key. It's worth noting that this example is conceptual rather than physical and is intended to show the logical structure of the data rather than how it might be physically organized. In most column family databases, the column families are stored separately. In the previous example, the customer info column family might be held in one area of physical storage and the address info column family in another, in a simple form of vertical partitioning. You should really think of the structure in terms of column families rather than rows. The data for a single entity that spans multiple column families will have the same row key in each column family. As an alternative to the conceptual layout explained previously, the data can be visualized as the following pair of physical structures. In the case that we have two structures, customer info and address info, each column structure can be joined by a row key. The most widely used column family database management system is Apache Cassandra. Azure Cosmos DB supports the column family approach through the Cassandra API. Graph databases enable you to store entities, but the main focus is on the relationships that these entities have with each other. A graph database stores two types of information: nodes, that you can think of as instances of entities, and edges, which specify the relationships between nodes. Nodes and edges can both have properties that provide information about that node or edge, like columns in a table. Additionally, edges can have a direction indicating the nature of the relationship. The purpose of a graph database is to enable an application to efficiently perform queries that traverse the network of nodes and edges and to analyze the relationships between entities. An organization's personnel database can be structured as a graph. The entities are the employees and the departments in the organization, and the edges indicate reporting lines and the department in which employees work. In a graph, the arrows on the edges show the direction of the relationships. For large graphs with lots of entities and relationships, you can perform very complex analysis very quickly, and many graph databases provide a query language that you can use to traverse a network of relationships efficiently. You can often store the same information in a relational database, but the SQL required to query this information might require many expensive recursive join operations and nested subqueries. Azure Cosmos DB supports graph databases using the Gremlin API. The Gremlin API is a standard language for creating and querying graphs. Microsoft Azure provides a variety of technologies for storing non-relational data. Each technology has its own strengths and is suited to specific scenarios. In this module, you have learned the characteristics of non-relational data, different types of non-relational data, NoSQL, and the types of non-relational databases. Hello and welcome to this lesson where you will explore concepts of data analytics. Successful companies make informed decisions to find new opportunities, identify weaknesses, increase efficiency, and improve customer satisfaction. Data analytics is the process of examining raw data to uncover trends and discover information used to ask and answer questions related to organizational performance. For example, resorts and casinos might combine data from previous customer visits to determine the best time to run specific activities and games. A data analyst might take data such as customer spend and look for correlations with other factors such as the weather, regional events, and even the presence or absence of incentives such as food and drink. Another example is the healthcare industry. There's an abundance of data in the healthcare industry, including patient records and insurance information. Because there's so much data, it can be difficult to manage. Data analytics allows for a thorough look at the data and can lead to a faster diagnosis or treatment plan. In this lesson, you'll explore the key elements involved in data analysis. You'll look at collecting data, processing data to generate information, and visualizing results to spot trends. In this lesson, you will learn about data ingestion and processing, explore data visualization, and explore data analytics. Data analytics is concerned with taking data and finding meaningful information and inferences from it. This could be as wide-ranging as selecting the ideal range of products for a retailer or selecting the best vaccine candidates for a biotechnology company. For example, in a company, data analytics could be concerned with taking the data that your organization produces and using it to establish a picture of how your organization is performing and what you can do to maintain business performance. Data analytics could help you to identify strengths and weaknesses in your organization and enable you to make appropriate business decisions. The data a company uses can come from many sources. There could be a mass of historical data to comb through, and fresh data continuing to arrive all the time. This data could be the result of customer purchases, bank transactions, stock price movements, real-time weather data, monitoring devices, or even cameras. In a data analytics solution, you combine this data and construct a data warehouse that you can use to ask and answer questions about your business operations. Building a data warehouse requires that you can capture the data that you need and wrangle it into an appropriate format. You can then use analysis tools and visualizations to examine the information and identify trends and their causes. It's important to note The term wrangling is the process by which you transform and map raw data into a more useful format for analysis. It can involve writing code to capture, filter, clean, combine, and aggregate data from many sources. Let's examine two important stages in data analytics: data ingestion and data processing. Let's explore how the two stages fit together. Firstly, the data ingestion stage, where raw data is ingested from many sources such as critical data, financial transactions, and point-of-sale data. This raw data is then stored where it can be processed. The data processing stage cleans and transforms the data. This data can then be stored in a variety of formats, where it can be made available for data exploration such as queries and visualizations. Data ingestion is the process of obtaining and importing data for immediate use or storage in a database. The data can arrive as a continuous stream, or it may come in batches, depending on the source. The purpose of the ingestion process is to capture this data and store it. This raw data can be held in a repository, such as a database management system, a set of files, or some other type of fast, easily accessible storage. The ingestion process might also perform filtering. For example, ingestion might reject suspicious, corrupt, or duplicated data. Suspicious data might be data arriving from an unexpected source. Corrupt or duplicated data could be due to a device error, transmission failure, or tampering. It may also be possible to perform some transformations at this stage, converting data into a standard form for later processing. For example, you might want to reformat all date and time data to use the same date and time representations and convert all measurement data to use the same units. However, these transformations must be quick to perform. Don't attempt to run any complex calculations or aggregations on the data at this stage. The data processing stage occurs after the data has been ingested and collected. Data processing takes the data in its raw form, cleans it, and converts it into a more meaningful format such as tables, graphs, documents, and so on. The result is a database of data that you can use to perform queries and generate visualizations, giving it the form and context necessary to be interpreted by computers and used by employees throughout an organization. This is an example of the data processing stage. The raw data can be processed by tools such as Azure Functions, Azure Databricks, Azure Cognitive Services, or other tools. This cleaned data can then be stored in various formats such as JSON in a data warehouse or as tabular data. But it's worth noting that data cleaning is a generalized term that encompasses a range of actions such as removing anomalies and applying filters and transformations that would be too time-consuming to run during the ingestion stage. The aim of data processing is to convert the raw data into one or more business models. A business model describes the data in terms of meaningful business entities and may aggregate items together and summarize information. The data processing stage could also generate predictive or other analytical models from the data. Data processing can be complex and may involve automated scripts and tools such as Azure Databricks, Azure Functions, and Azure Cognitive Services to examine and reformat the data and generate models. A data analyst could use machine learning to help determine future trends based on these models. The data processing mechanism can take two approaches to retrieving the ingested data: processing this data to transform it and generate models, and then saving the transformed data and models. These approaches are known as ETL and ELT. ETL stands for Extract, Transform, and Load. The raw data is retrieved and transformed before being saved. The extract, transform, and load steps can be performed as a continuous pipeline of operations. It is suitable for systems that only require simple models, with little dependency between items. For example, this type of process is often used for basic data cleaning tasks, deduplicating data and reformatting the contents of individual fields. An alternative approach to ETL is ELT. ELT is an abbreviation of Extract, Load, and Transform. The process differs from ETL in that the data is stored before being transformed. The data processing engine can take an iterative approach, retrieving and processing the data from storage before writing the transformed data and models back to storage. ELT is more suitable for constructing complex models that depend on multiple items in the database, often using periodic batch processing. ELT is a scalable approach that is suitable for the cloud because it can make use of the extensive processing power available. The more stream-oriented approach of ETL places more emphasis on throughput. However, ETL can filter data before it's stored. In this way, ETL can help with data privacy and compliance, removing sensitive data before it arrives in your analytical data models. Microsoft Azure provides several options that you can use to implement the ELT and ETL approaches. For example, if you are storing data in Azure SQL Database, you can use SQL Server Integration Services. Integration services can extract and transform data from a wide variety of sources such as XML data files, flat files, and relational data sources, and then load the data into one or more destinations. There are advantages of both ETL and ELT. ETL offers improved data privacy and compliance, while also not requiring specialist skills. On the other hand, ELT provides data lake support and is ideal for large volumes of data. Another more generalized approach is to use Azure Data Factory. Azure Data Factory is a cloud-based data integration service that allows you to create data-driven workflows for orchestrating data movement and transforming data at scale. Using Azure Data Factory, you can create and schedule data-driven workflows, called pipelines, that can ingest data from disparate data stores. You can build complex ETL processes that transform data visually with data flows, or by using compute services such as Azure HD Insight Hadoop, Azure Databricks, and Azure SQL Database. A business model can contain an enormous amount of information. The purpose of producing a model such as this is to help you reason over the information it contains, ask questions, and hopefully obtain answers that can help you drive your business forward. This video discusses some of the techniques you can use to analyze and understand the information in your models. Reporting is the process of organizing data into informational summaries to monitor how different areas of an organization are performing. Reporting helps companies monitor their online business and know when data falls outside of expected ranges. Good reporting should raise questions about the business from its end users. Reporting shows you what has happened, while analysis focuses on explaining why it happened and what you can do about it. The term business intelligence, BI, refers to technologies, applications, and practices for the collection, integration, analysis, and presentation of business information. The purpose of business intelligence is to support better decision-making. Business intelligence systems provide historical, current, and predictive views of business operations, most often using data that has been gathered into a data warehouse, and occasionally working from live operational data. Software elements support reporting, interactive slice and dice pivot table analysis, visualization, and statistical data mining. Applications tackle sales, production, financial, and many other sources of business data for purposes that include business performance management. Information is often gathered about other companies in the same industry for comparison. This process of comparison with other companies in the same industries is known as benchmarking. Data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to spot and understand trends, outliers, and patterns in data. If you are using Azure, the most popular data visualization tool is Power BI. Using Power BI, you can connect to multiple different sources of data and combine them into a data model. This data model lets you build visuals and collections of visuals you can share as reports with other people inside your organization. Data visualization helps you to focus on the meaning of data rather than looking at the data itself. A good data visualization enables you to quickly spot trends, anomalies, and potential issues. The most common forms of visualizations are bar and column, line, matrix, key influencers, tree maps, scatter, dot plot, and filled map. Let's explore these in a little more detail now. Bar and column charts enable you to see how a set of variables changes across different categories. Data is usually displayed as rectangular bars. The longer the bar, the larger the value. For example, a bar chart can show how sales for a pair of fictitious retailers vary between two store sites, Retailer A and Retailer B. Retailer A has more sales across both town centre stores and out-of-town stores. A bar chart can show how sales vary by month using vertical bars. For example, it can show the volume of sales for each month from January to July. February has the most sales with over 1,000. Next, we have line charts. They emphasize the overall shape of an entire series of values, usually over time. The data is depicted as lines, and lines are differentiated by colour, as they can overlap. In this example, we can see the volume of sales by month from January to July. The blue line represents this year, while the red line represents last year. There is an overlap in data values at February, May, June and July. A matrix visual is a tabular structure that summarises data. Often, report designers include matrices in reports and dashboards to allow users to select one or more elements, rows, column cells in the matrix to cross-highlight other visuals on a report page. A matrix table can analyse business quarters, Q1 and Q2, from 2015 to 2019. It's possible to visualize and cross-reference values for Q1 and Q2 revenues along with their corresponding year-to-date or YTD revenue. Next, let's look at key influencers. A key influencer chart displays the major contributors to a selected result or value. Key influencers are a great choice to help you understand the factors that influence a key metric. This example demonstrates what influences customers to place a second order, or why sales were so high last June. Tree maps are charts of coloured rectangles, with size representing the relative value of each item. They can be hierarchical, with rectangles nested within the main rectangles. A scatter chart shows the relationship between two numerical values. A bubble chart is a scatter chart that replaces data points with bubbles, with the bubble size representing an additional third data dimension. Likewise, a dot plot chart is similar to a bubble chart and scatter chart, but can plot categorical data along the x-axis. Lastly, we have a filled map. If you have geographical data, you can use a filled map to display how a value differs in proportion across a geography or region. You can see relative differences with shading that ranges from light, less frequent or lower, to dark, more frequent or more. Data analytics is concerned with examining, transforming and arranging data so that you can study it and extract useful information. Data analytics is a discipline that covers the entire range of data management tasks. These tasks not only include analysis, but also data collection, organization, storage, and all the tools and techniques used. The term data analytics is a catch-all that covers a range of activities, each with its own focus and goals. You can categorize these activities as descriptive, diagnostic, predictive, prescriptive, and cognitive analytics. Descriptive analytics helps answer questions about what has happened, based on historical data. Descriptive analytics techniques summarize large datasets to describe outcomes to stakeholders. By developing KPIs, or key performance indicators, these strategies can help track the success or failure of key objectives. Metrics such as return on investment or ROI are used in many industries. Specialized metrics are developed to track performance in specific industries. Examples of descriptive analytics include generating reports to provide a view of an organization's sales and financial data. Diagnostic analytics helps answer questions about why things happened. Diagnostic analytics techniques supplement more basic descriptive analytics. They take the findings from descriptive analytics and dig deeper to find the cause. The performance indicators are further investigated to discover why they got better or worse. This generally occurs in 3 steps. Identify anomalies in the data. These may be unexpected changes in a metric or a particular market. Collect data that's related to these anomalies, and use statistical techniques to discover relationships and trends that explain these anomalies. Predictive analytics helps answer questions about what will happen in the future. Predictive analytics techniques use historical data to identify trends and determine if they're likely to recur. Predictive analytical tools provide valuable insight into what may happen in the future. Techniques include a variety of statistical and machine learning techniques such as neural networks, decision trees, and regression. Prescriptive analytics helps answer questions about what actions should be taken to achieve a goal or target. By using insights from predictive analytics, data-driven decisions can be made. This technique allows businesses to make informed decisions in the face of uncertainty. Prescriptive analytics techniques rely on machine learning strategies to find patterns in large datasets. By analysing past decisions and events, the likelihood of different outcomes can be estimated. Cognitive analytics attempts to draw inferences from existing data and patterns, derive conclusions based on existing knowledge bases, and then add these findings back into the knowledge base for future inferences, a self-learning feedback loop. Cognitive analytics helps you to learn what might happen if circumstances change, and how you might handle these situations. Inferences aren't structured queries based on a rules database. Rather, they're unstructured hypotheses gathered from a number of sources and expressed with varying degrees of confidence. Effective cognitive analytics depends on machine learning algorithms. It uses several NLP or natural language processing concepts to make sense of previously untapped data sources, such as call center conversation logs and product reviews. Theoretically, by tapping the benefits of massive parallel and distributed computing and the falling costs of data storage and computing power, there's no limit to the cognitive development that these systems can achieve. Organizations have enormous amounts of data. The purpose of data analysis is to discover important insights that can help you drive your business forward. In this part, you have learned data ingestion and processing, data visualization, and data analytics.
Hello and welcome. In this course, you will explore relational data in Microsoft Azure. To begin with, you will identify relational Microsoft Azure data services and explore the considerations in choosing a relational data service. Such topics include Azure SQL Database, Azure SQL Managed Instance, and SQL Server on Azure Virtual Machine. You will also learn how to provision and configure relational data services while exploring basic connectivity and some data security features. You will explore relational data offerings, provisioning, and deploying relational databases through cloud data solutions with Microsoft Azure. You will identify the various methods for deployment, such as the Microsoft Azure Portal, Azure Resource Manager templates, Azure PowerShell, and the Azure Command Line Interface, or CLI. Finally, you will compare data definition language, DDL, versus data manipulation language, DML, while also querying relational data in Azure SQL Database, Azure Database for PostgreSQL, and Azure Database for MySQL. Hello and welcome. In this course, you will explore relational data in Microsoft Azure. A database is a collection of data. A database can be as simple as a traditional spreadsheet or as complex as a global system holding petabytes of highly structured information. The data can be structured in many different ways. A common approach is to store data in a tabular format made up of rows and columns. You can define relationships by using common fields between the tables. These databases are called relational databases. Databases can also be semi-structured or unstructured, comprising of semi-processed or unprocessed data. These databases are typically referred to as non-relational. Databases are managed using a database management system, or a DBMS for short. The DBMS handles the physical aspects of a database, such as where and how it's stored, who can access it, and how to ensure that it's available when required. Many organizations depend on the information stored in their databases to help make critical business decisions. In the past, these organizations ran their DBMSs on premises. However, this approach requires the organization to maintain its own hardware infrastructure. Therefore, an increasing number of businesses are migrating their databases to the cloud, where the costs of configuring and maintaining the infrastructure are highly reduced. Suppose you're a database administrator at Wide World Importers. You're responsible for database design and maintenance, as well as providing information for management and creating customer lists for the marketing department. You have an existing SQL Server database that relies heavily on stored procedures and other advanced database features, such as linked servers. The database is situated on your internal network. You've been asked to make it globally available to your partners worldwide. It's important to note that a stored procedure is a block of code that runs inside your database. Applications often use stored procedures because they are optimized to run in the database environment and can access data very quickly. A linked server is a connection from one database server to another. SQL Server can use linked servers to run queries on one server that can include data retrieved from another server as part of its result set. These are known as distributed queries. In this lesson, you'll explore the options available when choosing a relational data platform for hosting a database in Microsoft Azure. You will identify relational Microsoft Azure data services and explore considerations in choosing a relational data service. Microsoft Azure offers a range of options for running a database management system in the cloud. For example, you can migrate your on-premises system to a collection of Azure virtual machines. This approach still requires that you manage your DBMS carefully. Alternatively, you can take advantage of the various Azure relational data services available. These data services manage the DBMS for you, leaving you free to concentrate on the data they contain and the applications that use them. Let's take a quick look at what exactly is an Azure Virtual Network. An Azure Virtual Network is a representation of your own network in the cloud. A virtual network enables you to connect virtual machines and Azure services together, in much the same way that you might use a physical network on premises. Azure ensures that each virtual network is isolated from other virtual networks created by other users and from the internet. Azure enables you to specify which machines, real and virtual, and services are allowed to access resources on the virtual network and which ports they can use. Before delving into Azure Data Services, you need to understand some common terms used to describe the different ways in which you can host a database in Azure. These include the common terms IaaS, PaaS, and SaaS. IaaS is an acronym for Infrastructure as a Service. Azure enables you to create a virtual infrastructure in the cloud that mirrors the way an on-premises data center might work. You can create a set of virtual machines, connect them together using a virtual network, and add a range of virtual devices. You take responsibility for installing, configuring, and maintaining the software, such as the DBMS, on these virtual machines. In many ways, this approach is similar to the way in which you run your systems inside an organization, except that you don't have to concern yourself with buying or maintaining the hardware. PaaS stands for a Platform as a Service. Rather than creating a virtual infrastructure and installing and managing the database software yourself, a PaaS solution does this for you. You specify the resources that you require based on how large you think your databases will be, the number of users, and the performance you require, and Azure automatically creates and manages the necessary virtual machines, networks, and other devices for you. You can usually scale up or down, increase or decrease the size and number of resources quickly, as the volume of data and the amount of work being done varies. Azure handles this scaling for you, and you don't have to manually add or remove virtual machines or perform any other form of configuration. SaaS is short for Software as a Service. SaaS services are typically specific software packages that are installed and run on virtual hardware in the cloud. SaaS packages are typically hosted applications rather than more generalized software such as a DBMS. Common SaaS packages available on Azure include Microsoft 365, formerly Office 365. IaaS is the most flexible category of cloud services. It aims to give you complete control over the hardware that runs your application. Instead of buying hardware, with IaaS, you rent it. PaaS provides the same benefits and considerations as IaaS, but there are some additional benefits such as database management and operating systems. SaaS is software that's centrally hosted and managed for you and your users and customers. Usually one version of the application is used for all customers and it's licensed through a monthly or annual subscription. SaaS provides the same benefits as IaaS, But again, there are some additional benefits such as apps. You can see how when you move from IaaS to PaaS to SaaS, the shared responsibilities reduces for the client and increases for the provider. Azure Data Services fall into the PaaS category. These services are a series of DBMSs managed by Microsoft in the cloud. Each data service takes care of the configuration, day-to-day management, software updates, and security of the databases that it hosts. All you do is create your databases under the control of the data service. Azure Data Services are available for several common relational database management systems. The most well-known service is Azure SQL Database. The others currently available are Azure Database for MySQL servers, Azure Database for MariaDB servers, and Azure Database for PostgreSQL servers. The remaining lessons in this section will describe the features provided by these services. It's important to note that Microsoft also provides data services for non-relational database management systems, such as Cosmos DB. Using Azure Data Services reduces the amount of time that you need to invest to administer a DBMS. However, these services can also limit the range of custom administration tasks that you can perform, because manually performing some tasks might risk compromising the way in which the service runs. For example, some DBMSs enable you to install custom software into a database or run scripts as part of a database operation. This software might not be supported by the data service, and allowing an application to run a script from a database could affect the security of the service. You must be prepared to work with these restrictions in mind. Apart from reducing the administrative workload, Azure Data Services ensure that your databases are available for at least 99.99% of the time. It's important to note that there are costs associated with running a database in Azure Data Services. The base price of each service covers underlying infrastructure and licensing, together with the administration charges. Additionally, these services are designed to be always on. This means that you cannot shut down a database and restart it later. Not all features of a database management system are available in Azure Data Services. This is because Azure Data Services takes on the task of managing the system and keeping it running using hardware situated in an Azure data center. Exposing some administrative functions might make the underlying platform vulnerable to misuse and even open up some security concerns. Therefore, you have no direct control over the platform on which the service is run. If you need more control than Azure Data Services allow, you can install your database management system on a virtual machine that runs in Azure using IaaS. Later, you will examine this approach in more detail for SQL Server, although the same concerns apply for the other database management systems supported by Azure Data Services. There are benefits and trade-offs when running a database management system with SQL Server. For example, administrative efforts against capital expenditure and day-to-day control for on-premises IaaS and PaaS approaches. The physical on-premises solution requires higher capital expenditure, but the greatest level of physical control. This is compared to using virtual machines in Azure, IaaS approach, or Azure SQL Database, PaaS approach. The PaaS solution requires the lowest administrative effort and capital expenditure. The same generalized considerations are true for other database management systems. Microsoft SQL Server is a popular relational DBMS. It has a long history and has features that provide database management to organizations of all sizes. In the past, organizations have run SQL Server on-premises. However, many organizations are now looking to shift operations online to take advantage of services available in the cloud. SQL Server offers several ways to run a database in Azure. In this lesson, you'll look at moving SQL Server to an Azure virtual machine. SQL Server on virtual machines enables you to use full versions of SQL Server in the cloud without having to manage any on-premises hardware. This is an example of the IaaS approach. SQL Server running on an Azure virtual machine effectively replicates the database running on real on-premises hardware. Migrating from the system running on-premises to an Azure virtual machine is no different than moving the databases from one on-premises server to another. In the example scenario described earlier, the database runs stored procedures and scripts as part of the database workload. If these stored procedures and scripts depend on features that are restricted by following a PaaS approach, then running SQL Server on your own virtual machines might be a good option. However, you remain responsible for maintaining the SQL Server software and performing the various administrative tasks to keep the database running from day to day. This approach is suitable for migrations and applications requiring access to operating system features that might be unsupported at the PaaS level. SQL virtual machines are lift and shift ready for existing applications that require fast migration to the cloud with minimal changes. It's important to note that the term lift and shift refers to the way in which you can move a database directly from an on-premises server to an Azure virtual machine without requiring that you make any changes to it. Applications that previously connected to the on-premises database can be quickly reconfigured to connect to the database running on the virtual machine, but should otherwise remain unchanged. This approach is optimized for migrating existing applications to Microsoft Azure or extending existing on-premises applications to the cloud in hybrid deployments. A hybrid deployment is a system where part of the operation runs on-premises and part in the cloud. Your database might be part of a larger system that runs on-premises, although the database elements might be hosted in the cloud. For example, a client machine running an app connecting to SQL Server in the cloud and other resources on-premises. You can use SQL Server in a virtual machine to develop and test traditional SQL Server applications. With a virtual machine, you have full control of and administrative rights over the DBMS and operating system. It's a perfect choice when your organization already has IT resources available to maintain the virtual machines. These capabilities enable you to create rapid development and test scenarios when you do not want to buy on-premises non-production SQL Server hardware. Become lift and shift ready for existing applications that require fast migration to the cloud with minimal changes or no changes. Scale up the platform on which SQL Server is running by allocating more memory, CPU power, and disk space to the virtual machine. You can quickly resize an Azure virtual machine without the requirements that you reinstall the software that is running on it. Running SQL Server on virtual machines allows you to meet unique and diverse business needs through a combination of on-premises and cloud-hosted deployments, while using the same set of server products, development tools, and expertise across these environments. However, it's not always easy for businesses to switch their DBMS to a fully managed service. There may be specific requirements that must be satisfied in order to migrate to a managed service that requires making changes to the database and the applications that use it. For this reason, using virtual machines can offer a solution, but using them does not eliminate the need to administer your DBMS as carefully as you would on premises. If you don't want to incur the management overhead associated with running SQL Server on a virtual machine, you can use Azure SQL Database. Azure SQL Database is a PaaS offering for Microsoft. You create a managed database server in the cloud and then deploy your databases on this server. A SQL database server is a logical construct that acts as a central administrative point for multiple single or pooled databases, logins, firewall rules, auditing rules, threat detection policies, and failover groups. Azure SQL Database is available with several options: single database, elastic pool, and managed instance. The following sections describe single database and elastic pool. Managed instance is the subject of the next lesson. Let's start with single database. This option enables you to quickly set up and run a single SQL Server database. You create and run a database server in the cloud, and you access your database through this server. Microsoft manages the server, so all you have to do is configure the database, create your tables, and populate them with your data. You can scale the database if you need additional storage space, memory, or processing power. By default, resources are pre-allocated and you're charged per hour for the resources you've requested. You can also specify a serverless configuration. In this configuration, Microsoft creates its own server, which might be shared with a number of databases belonging to other Azure subscribers. Microsoft ensures the privacy of your database. Your database automatically scales and resources are allocated or deallocated as required. For more information, read "What is a single database in Azure SQL Database?" There is a link to this document from the additional readings at the end of this lesson. This is an example of an Azure SQL Database single database deployment. The Azure resources are managed by the server, such as disks, memory, and processors. Let's take a look at the elastic pool model now. The Elastic Pool option is similar to single database, except that by default, multiple databases can share the same resources, such as memory, data storage space, and processing power. The resources are referred to as a pool. You create the pool, and only your databases can use the pool. This model is useful if you have databases with resource requirements that vary over time and can help you to reduce costs. For example, your payroll database might require plenty of CPU power at the end of each month as you handle payroll processing, but at other times the database might become much less active. You might have another database that is used for running reports. This database might become active for several days in the middle of the month as management reports are generated, but with a lighter load at other times. Or you can have an Azure SQL Database Elastic Pool deployment. The pooled resources are shared by all databases. Elastic Pool enables you to use the resources available in the pool and then release the resources once processing has completed. Azure SQL Database gives you the best option for low cost with minimal administration. It is not fully compatible with on-premises SQL Server installations. It's often used in new cloud projects where the application design can accommodate any required changes to your applications. You can use the Data Migration Assistant to detect compatibility issues with your databases that can impact database functionality in Azure SQL Database. For more information, see Overview of Data Migration Assistant. There is a link to this document from the additional readings at the end of this lesson. Azure SQL Database is often used for modern cloud applications that need to use the latest stable SQL Server features, applications that require high availability, and systems with a variable load that need the database server to scale up and down quickly. Let's now take a look at some of the business benefits associated with Azure SQL Database. These include automatic software patches and updates. Azure SQL Database automatically updates and patches the SQL Server software to ensure that you are always running the latest and most secure version of the service. Scale when needed. The scalability feature of Azure SQL Database ensures that you can increase the resources available to store and process data without having to perform a costly manual upgrade. High availability guarantees. The service provides high availability guarantees to ensure that your database are available at least 99.99% of the time. Azure SQL Database supports point-in-time restore, enabling you to recover a database to the state it was in at any point in the past. Databases can be replicated to different regions to provide additional assurance and disaster recovery. Advanced threat protection. Advanced threat protection provides advanced security capabilities, such as vulnerability assessments, to help detect and remediate potential security problems with your databases. Threat protection also detects anomalous activities that indicate unusual and potentially harmful attempts to access or exploit your database. It continuously monitors your database for suspicious activities and provides immediate security alerts on potential vulnerabilities, SQL injection attacks, and anomalous database access patterns. Threat detection alerts provide details of the suspicious activity and recommend action on how to investigate and mitigate the threat. Tracking for auditing and compliance. Auditing tracks database events and writes them to an audit log in your Azure Storage account. Auditing can help you maintain regulatory compliance, understand database activity, and gain insight into discrepancies and anomalies that might indicate business concerns or suspected security violations. Security with encryption. SQL Database helps secure your data by providing encryption. For data in transit, it uses transport layer security. For data at rest, it uses transparent data encryption. For data in use, it uses always encrypted. For more information on transport layer security, transparent data encryption, and always encrypted, see the link at the end of this lesson. In the wide world importer scenario, linked servers are used to perform distributed queries. However, neither single database nor Elastic Pool support linked servers. If you want to use single database or Elastic Pool, you may need to modify the queries that use linked servers and rework the operations that depend on these features. A business may want to eliminate as much management overhead as possible from administrating databases and servers, but the limitation of the single database and Elastic Pool options may mean that those options aren't suitable. In these situations, Azure SQL Database Managed Instance may be a good choice to consider. The single database and elastic pool options restrict some of the administrative features available to SQL Server. Managed Instance effectively run a fully controllable instance of SQL Server in the cloud. You can install multiple databases on the same instance. You have complete control over this instance, much as you would for an on-premises server. The Managed Instance service automates backups, software patching, database monitoring, and other general tasks, but you have full control over security and resource allocation for your databases. You can find detailed information on what is Azure SQL Database Managed Instance. You can find a link to this document from the additional readings at the end of this lesson. Managed instances depend on other Azure services such as Azure Storage for backups, Azure Event Hubs for telemetry, Azure Active Directory for authentication, Azure Key Vault for transparent data encryption, TDE, and a couple of Azure Platform services that provide security and supportability features. The managed instances make connections to these services. All communications are encrypted and signed using certificates. To check the trustworthiness of communicating parties, managed instances constantly verify certificates through certificate revocation lists. If the certificates are revoked, the managed instance closes the connections to protect the data. Let's summarize the differences between SQL Database Managed Instance, Single Database, and Elastic Pool. Managed Instance is an instance-scoped programming model with high compatibility with SQL Server. It's best for modernization at scale with low cost and low effort. Single Instance is a standalone managed database for predictable and stable workloads. Finally, Elastic Pool is a shared resource model for greater efficiency through multi-tenancy. Consider Azure SQL Database Managed Instance if you want to lift and shift an on-premises SQL Server instance and all its databases to the cloud without incurring the management overhead of running SQL Server on a virtual machine. SQL Database Managed Instance provides features not available with the single database or Elastic Pool options. If your system uses features such as linked servers, Service Broker, which is a message processing system that can be used to distribute work across servers, or Database Mail, which enables your database to send email messages to users, then you should use Managed Instance. To check compatibility with an existing on-premises system, you can install Data Migration Assistant, or DMA. This tool analyzes your databases on SQL Server and reports any issues that could block migration to a managed instance. There is a link to this document from the additional readings at the end of this lesson. SQL Database Managed Instance provides all the management and security benefits available when using single database and Elastic Pool. Managed Instance deployment enables a system administrator to spend less time on administrative tasks because the SQL Database service either performs them for you or greatly simplifies those tasks. Automated tasks include operating system and database management system software installation and patching, dynamic instance resizing and configuration, backups, database replication, including system databases, high availability configuration, and configuration of health and performance monitoring data streams. Managed Instance has nearly 100% compatibility with SQL Server Enterprise Edition running on premises. The SQL Database Managed Instance deployment option supports traditional SQL Server Database Engine logins and logins integrated with Azure Active Directory. Traditional SQL Server Database Engine logins include a username and a password. You must enter your credentials each time you connect to the server. Azure AD logins use the credentials associated with your current computer's sign-in, and you don't need to provide them each time you connect to the server. In the wide world importer scenario, SQL Database Managed Instance may be a more suitable choice than single database or Elastic Pool. SQL Database Managed Instance supports linked servers, although some of the other advanced features required by the database might not be available. If you want a complete match, then running SQL servers on a virtual machine may be your only option, but you need to balance the benefits of complete functionality against the administrative and maintenance overhead required. As well as Azure SQL Database, Azure Data Services are available for other popular SQL-based database solutions. Currently, data services are available for MySQL, MariaDB, and PostgreSQL. The primary reason for these services is to enable organizations running MySQL, MariaDB, and PostgreSQL to move to Azure quickly without making wholesale changes to their applications. MySQL, MariaDB, and PostgreSQL are relational database management systems that are tailored for different specializations. Let's take a closer look at each now. MySQL started life as a simple-to-use open-source database management system. It is the leading open-source relational database for Linux, Apache, MySQL, and PHP LAMP stack apps. It's available in multiple editions: Community, Standard, and Enterprise. The Community Edition is available free of charge and has historically been popular as a database management system for web applications running under Linux. Versions are also available for Windows. Standard Edition offers higher performance and uses a different technology for storing data. Enterprise Edition provides a comprehensive set of tools and features, including enhanced security, availability, and scalability. The Standard and Enterprise Editions are the versions most frequently used by commercial organizations, although these versions of the software aren't free. MariaDB is a newer database management system created by the original developers of MySQL. The database engine has since been rewritten and optimized to improve performance. MariaDB offers compatibility with Oracle Database, another popular commercial database management system. One notable feature of MariaDB is its built-in support for temporal data. A table can hold several versions of data, enabling an application to query the data as it appeared at some point in the past. PostgreSQL is a hybrid relational object database. You can store data in relational tables, but a PostgreSQL database also enables you to store custom data types with their own non-relational properties. The database management system is extensible. You can add code modules to the database, which can be run by queries. Another key feature is the ability to store and manipulate geometric data, such as lines, circles, and polygons. PostgreSQL has its own query language called PGSQL. This language is a variant of the standard relational query language SQL, with features that enable you to write stored procedures that run inside the database. Azure Database for MySQL is a PaaS implementation of MySQL in the Azure cloud, based on the MySQL Community Edition. The Azure Database for MySQL service includes high availability at no additional cost and scalability as required. You only pay for what you use. Automatic backups are provided with point-in-time restore. The server provides connection security to enforce firewall rules and optionally require SSL connections. Many server parameters enable you to configure server settings such as lock modes, maximum number of connections, and timeouts. Azure Database for MySQL provides a global database system that scales up to large databases without the need to manage hardware, network components, virtual servers, software patches, and other underlying components. Certain operations aren't available with Azure Database for MySQL. These functions are primarily concerned with security and administration. Azure manages these aspects of the database server itself. The system uses pay-as-you-go pricing, so you only pay for what you use. Azure Database for MySQL servers provides monitoring functionality to add alerts and to view metrics and logs. Azure Database for MariaDB is an implementation of the MariaDB database management system adapted to run in Azure. It's based on the MariaDB Community Edition. The database is fully managed and controlled by Azure. Once you've provisioned the service and transferred your data, the system requires almost no additional administration. Azure Database for MariaDB delivers built-in high availability with no additional cost, predictable performance using inclusive pay-as-you-go pricing, scaling as needed within seconds, secured protection of sensitive data at rest and in transit, automatic backups and point-in-time restore for up to 35 days, and enterprise-grade security and compliance. If you prefer PostgreSQL, you can choose Azure Database for PostgreSQL to run a PaaS implementation of PostgreSQL in the Azure cloud. This service provides the same availability, performance, scaling, security, and administrative benefits as the MySQL service. Some features of on-premises PostgreSQL databases are not available in Azure Databases for PostgreSQL. These features are mainly concerned with the extensions that users can add to a database to perform specialized tasks, such as writing stored procedures in various programming language other than PG-SQL, which is available, and interacting directly with the operating system. A core set of the most frequently used extensions is supported, and the list of available extensions is under continuous review. Azure Database for PostgreSQL has two deployment options, single server and hyperscale. The single server deployment option for PostgreSQL provides similar benefits as Azure Database for MySQL. You choose from 3 pricing tiers: Basic, General Purpose, and Memory Optimized. Each tier supports different numbers of CPUs, memory, and storage sizes. You select one based on the load you expect to support. Hyperscale Citus is a deployment option that scales queries across multiple server nodes to support large database loads. Your database is split across nodes. Data is split into chunks based on the value of a partition key or a sharding key. Consider using this deployment option for the largest database PostgreSQL deployments in the Azure cloud. Azure Database for PostgreSQL is a highly available service. It contains built-in failure detection and failover mechanisms. Users of PostgreSQL will be familiar with the PG admin tool, which you can use to manage and monitor a PostgreSQL database. You can continue to use this tool to connect to Azure Database for PostgreSQL. However, some server-focused functionality, such as performing server backup and restore, are not available because the server is managed and maintained by Microsoft. Azure Database for PostgreSQL servers record information about the queries run against databases on the server and saves them in a database named Azure_SYS. You query the query_store.qs_view to see this information and use it to monitor the queries that users are running. This information can prove invaluable if you need to fine-tune the queries performed by your applications. If you have existing MySQL, MariaDB, or PostgreSQL databases running on-premises, and you want to move the data to a database running the corresponding data services in Azure, you can use the Azure Database Migration Service, or DMS. The Database Migration Service enables you to restore a backup of your on-premises databases directly to databases running in Azure Data Services. You can also configure replication from an on-premises database so that any changes made to data in the database are copied to the database running in Azure Data Services. This strategy enables you to reconfigure users and applications to connect to the database in the cloud while the on-premises system is still active. You don't have to shut down the on-premises system while you transfer users to the cloud. In this lesson, you've learned about the PaaS and IaaS deployment options for running databases in the cloud. You've seen how Azure Data Services provide a range of PaaS services for running relational databases in Azure. You've learned how the PaaS options provide support for automated management and administration, compared to an IaaS approach. Hello! In this lesson, you will learn how to provision and configure Azure SQL Database, Azure Database for PostgreSQL, and Azure Database for MySQL. Microsoft Azure supports a number of database services, enabling you to run popular database management systems such as SQL Server, PostgreSQL, and MySQL in the cloud. Microsoft Azure database services are fully managed, freeing up valuable time you'd otherwise spend managing your database. Enterprise-grade performance with built-in high availability means you can scale quickly and reach global distribution without worrying about costly downtime. Developers can take advantage of industry-leading innovations such as built-in security with automatic monitoring and threat detection, and automatic tuning for improved performance. On top of all these features, you have guaranteed availability. Suppose you're a data engineer at Contoso and are responsible for creating and managing databases. You've been asked to set up 3 new relational data stores: Azure SQL Database, PostgreSQL, and MySQL. In this lesson, you'll explore the options available for creating and configuring Microsoft Azure Relational Data Services. In this lesson, you will provision relational data services, configure relational data services, explore basic connectivity issues, and explore data security. In this sample scenario, Contoso has decided that the organization will require several different relational stores. As the data engineer, you've been asked to set up data stores using Azure SQL Database, PostgreSQL, and MySQL. In this lesson, you'll learn how to provision these services. Provisioning is the act of running a series of tasks to create, configure, and make available a service, such as Azure SQL Database. Behind the scenes, the service provider will set up various resources, disks, memory, CPUs, networks, and so on, required to run the service. You'll be assigned these resources, and they remain allocated to you and charged to you until you delete the service. How the service provider provisions resources is opaque, and you don't need to be concerned with how this process works. All you do is specify parameters that determine the size of the resources required, how much disk space, memory, computing power, and network bandwidth. These parameters are determined by estimating the size of the workload that you intend to run using the service. In many cases, you can modify these parameters after the service has been created, perhaps increasing the amount of storage space or memory if the workload is greater than you initially anticipated. The act of increasing or decreasing the resources used by a service is called scaling. This example demonstrates the process that Microsoft Azure performs when you provision a service. First, the user specifies the provisioning parameters, such as the type of service, storage, memory, and compute power. The provisioning parameters are then sent to Microsoft Azure to provision the service. Azure allocates the necessary resources to create the service. Finally, the service is then ready for use. Microsoft Azure provides several tools you can use to provision services. These include the Microsoft Azure Portal, Azure Command Line Interface, CLI, Azure PowerShell, and Azure Resource Manager templates. Let's take a brief look at each of these now. The Microsoft Azure Portal is the most convenient way to provision a service for most users. It displays a series of service-specific pages that prompt you for the settings required and validates these settings before actually provisioning the service. The Azure Command Line Interface, or CLI, provides a set of commands that you can run from the operating system command prompt or the Cloud Shell in the Microsoft Azure Portal. You can use these commands to create and manage Microsoft Azure resources. The CLI is suitable if you need to automate service creation. You can store CLI commands in scripts, and you can run these scripts programmatically. The CLI can run on Windows, Mac OS, and Linux computers. For detailed information about the Azure CLI, read What is Azure CLI on the Microsoft website. You can find a link to this document from the additional readings at the end of this lesson. Many administrators are familiar with using Azure PowerShell commands to script and automate administrative tasks. Azure provides a series of commandlets, Azure-specific commands, that you can use in PowerShell to create and manage Azure resources. Like the CLI, PowerShell is available for Windows, Mac OS, and Linux. You can find further information about Azure PowerShell online at Azure PowerShell documentation page. There is a link to this document from the additional readings at the end of this lesson. Let's take a look at Azure Resource Manager templates now. An Azure Resource Manager, or ARM template, describes the service or services that you want to deploy in a text file, in a format known as JSON, which is short for JavaScript Object Notation. Using JSON, you can define the infrastructure and configuration for your project. This example in JSON format shows a template that you can use to provision an instance of Azure SQL Database. The JSON code describes and stores the configuration settings that will be applied. You send the template to Azure using the AZ deployment group create command in the Azure CLI or new-AZ resource group deployment command in Azure PowerShell. For more information about creating and using Azure Resource Manager templates to provision Azure resources, see What are Azure Resource Manager templates? Once again, you will find a link to this document in the additional readings at the end of this lesson. Microsoft Azure Relational Data Services enable you to work with other leading relational database providers, such as PostgreSQL and MySQL. These services are called Azure Database for PostgreSQL and Azure Database for MySQL. Now you'll see how to provision these data stores in Microsoft Azure. As with Azure SQL Database, you can provision a PostgreSQL or MySQL database interactively using the Azure portal. You can find both of these services in the Microsoft Azure Marketplace. The processes for provisioning Azure Database for PostgreSQL and Azure Database for MySQL are very similar. It's important to note, however, that PostgreSQL also gives you the hyperscale option, which supports ultra-high performance workloads. The hyperscale deployment option supports horizontal scaling across multiple machines. This option enables the service to add and remove computers as workloads increase and diminish. Query parallelization across these servers. The service can split resource-intensive queries into pieces which can be run in parallel on different servers. The results from each server are aggregated back together to produce a final result. This mechanism can deliver faster responses on queries over large data sets. Hyperscale also provides support for multi-tenant applications, real-time operational analytics, and high-throughput transactional workloads. This example summarizes the fields and settings required when provisioning a PostgreSQL or a MySQL database service. The Basic tab prompts for the following details, which is grouped in sections. First, you select your Microsoft Azure subscription. Next is Resource Group, where you either pick an existing resource group or select Create New to build a new one. Each MySQL or PostgreSQL database must have a unique name that hasn't been used publicly before. The name must be between 3 and 31 characters long and can only contain lowercase letters, digits, and the dash character. You enter this in the server name field. Select None to create a new server from scratch. You can select Backup if you're creating a server from a geo backup of an existing Azure database for MySQL Server. For location, either select the region that is nearest to you or the region nearest to your users. For version, you choose the version of MySQL or PostgreSQL to deploy. The Compute and Storage setting deals with the compute, storage, and backup configurations for your new server. The Configure Server link enables you to select the resources required to support your database workloads. These resources include the amount of computing power, memory, backups, and redundancy options for high availability. Let's explore this section in a little more detail now. It's also important to note that the term compute refers to the amount of processor power available, but in terms of size and number of CPUs allocated to the service. Let's take a closer look at this section now. You can select between 3 pricing tiers, each of which is designed to support different workloads. The Basic tier is suitable for workloads that require light compute and I/O performance. Examples include servers used for development or testing, or small-scale and frequently used applications. Use the General Purpose Pricing tier for business workloads that require balanced compute and memory with scalable I/O throughput. Examples include servers for hosting web and mobile apps and other enterprise applications. Finally, the Memory Optimized tier supports high-performance database workloads that require in-memory performance for faster transaction processing and higher concurrency. Examples include servers for processing real-time data and high-performance transactional or analytical apps. You can fine-tune the resources available for the selected tier. You can scale these resources up later if necessary. Let's switch back to the final section for provisioning a PostgreSQL or a MySQL database service. In the Administrator Account section, the admin username is the sign-in account to use when you're connecting to the server. It's important to note that the admin sign-in name can't be Azure_superuser, admin, administrator, root, guest, or public. Finally, the password and confirm password fields are where you provide a new password for the server admin account. It's important to note that the password must contain from 8 to 128 characters. And your password must contain characters from 3 of the following categories: English uppercase letters, English lowercase letters, numbers 0 through 9, and non-alphanumeric characters, exclamation point, $, hashtag, percentage, and so on. The last step is to review, and once you've specified the appropriate settings, select the Review and Create button to provision the server. After you've provisioned a resource, you'll often need to configure it to meet the needs of your applications and environment. For example, you might need to set up network access or open a firewall port to enable your applications to connect to the resource. In this part, you'll learn how to enable network access to your resources and how you can prevent accidental exposure of your resources to third parties. You'll see how to use authentication and access control to protect the data managed by your resources. Now let's discuss how you can configure connectivity and firewalls. The default connectivity for Azure Relational Data Services is to disable access to the world. Now we will look at how to configure connectivity to virtual networks and on-premises computers. To enable connectivity, use the Firewalls and Virtual Networks page for a service. From the database page in the Azure portal, select Connection Security and then configure the firewall rules and access to the Azure service. It's important to note that an Azure Virtual Network is a representation of your own network in the cloud. A virtual network enables you to connect virtual machines and Microsoft Azure services together in much the same way that you might use a physical network on premises. Microsoft Azure ensures that each virtual network is isolated from other virtual networks created by other users and from the Internet. Microsoft Azure enables you to specify which machines, real and virtual, and services are allowed to access resources on the virtual network and which ports they can use. In the Virtual Networks section, you can specify which virtual networks are allowed to route traffic to the service. When you create items such as web applications and virtual machines, you can add them to a virtual network. If these applications and virtual machines require access to your resource, add the virtual network containing these items to the list of allowed networks. If you need to connect to the service from an on-premises computer, in the Firewall section, add the IP address of the computer. This setting creates a firewall rule that allows traffic from that address to reach the service. The Exceptions setting allows you to enable access to any other services that cannot be uniquely isolated through virtual network or IP address rules. For example, the Firewalls and Virtual Networks page for an Azure SQL database. MySQL and PostgreSQL have a similar page. Azure SQL Database communicates over port 1433. If you're trying to connect from within a corporate network, outbound traffic over port 1433 might not be allowed by your network's firewall. If so, you can't connect to your Azure SQL Database server unless your IT department opens port 1433. It's important to note that a firewall rule of 0.0.0.0 enables all Azure services to pass through the server-level firewall rule and attempt to connect to a single or pooled database through the server. Azure Private Endpoint is a network interface that connects you privately and securely to a service powered by Azure Private Link. Private Endpoint uses a private IP address from your virtual network, effectively bringing the service into your virtual network. The service could be a Microsoft Azure service, such as Azure App Service, or your own private link service. For detailed information, read What is Azure Private Endpoint? There is a link to this document from the additional readings at the end of this lesson. The Private Endpoint Connections page for a service allows you to specify which private endpoints, if any, are permitted access to your service. You can use the settings on this page together with the Firewalls and Virtual Networks page to completely lock down users and applications from accessing public endpoints to connect to your Azure SQL Database account. Let's talk about how you can configure authentication now. With Azure Active Directory authentication, you can centrally manage the identities of database users and other Microsoft services in one central location. Central ID management provides a single place to manage database users and simplifies permission management. You can use these identities and configure access to your relational data services. For detailed information on using Azure AD with Azure SQL Database, you can visit the page What is Azure Active Directory Authentication for SQL Database on the Microsoft website. You can also authenticate users connecting to Azure Database for PostgreSQL and Azure Database for MySQL with AD. There is a link to these documents from the additional readings at the end of this lesson. Azure AD enables you to specify who or what can access your resources. Access control defines what a user or application can do with your resources once they've been authenticated. Access management for cloud resources is a critical function for any organization that is using the cloud. Azure Role-Based Access Control, Azure RBAC, helps you manage who has access to Microsoft Azure resources and what they can do with those resources. For example, using RBAC, you could allow one user to manage virtual machines in a subscription and another user to manage virtual networks. Allow a database administrator group to manage SQL databases in a subscription. Allow a user to manage all resources in a resource group, such as virtual machines, websites, and subnets. And allow an application to access all resources in a resource group. You control access to resources using Azure RBAC to create role assignments. A role assignment consists of 3 elements: a security principal, a role definition, and a scope. Let's look at these in a little more detail now. A security principal is an object that represents a user, group, service principal, or managed identity that is requesting access to Microsoft Azure resources. A role definition, often abbreviated to role, is a collection of permissions. A role definition lists the operations that can be performed, such as read, write, and delete. Roles can be given high-level names, like owner, or specific names, like virtual machine reader. Finally, a scope lists the set of resources that the access applies to. When you assign a role, you can further limit the actions allowed by defining a scope. This is helpful if, for example, you want to make someone a website contributor, but only for one resource group. Let's explore roles in a little more detail now. Microsoft Azure includes several built-in roles that you can use, including owner, who has full access to all resources, including the right to delegate access to others. Contributor, who can create and manage all types of Microsoft Azure resources, but can't grant access to others. Reader, who can view existing Microsoft Azure resources. And User Access Administrator, which lets you manage user access to Microsoft Azure resources. You can also create your own custom roles. For detailed information, see Create or Update Azure Custom Roles using the Azure portal on the Microsoft website. There is a link to this document from the additional readings at the end of this lesson. You add assignments to a resource in the Microsoft Azure portal using the Access Control IAM page. The Role Assignments tab enables you to associate a role with the security or service principal and define the level of access. For more information, you can check out the page Add or Remove Azure Role Assignments using the Azure portal from the Microsoft website. You can find a link to this document from the additional readings at the end of this lesson. Apart from authentication and authorization, many services provide additional protection through advanced data security. Azure includes several built-in roles that you can use. Advanced Data Security implements threat protection and assessment. Threat protection adds security intelligence to your service. This intelligence monitors the service and detects unusual patterns of activity that could be harmful or compromise the data managed by the service. Assessment identifies potential security vulnerabilities and recommends actions to mitigate them. You can access these from the Advanced Data Security page for SQL database. It's worth noting that the corresponding pages for MySQL and PostgreSQL are similar. This part explores the specific configuration options available to each type of data store within Azure Relational Data Services. The overarching principle for network security of the Azure SQL database offering is to allow only the connection and communication that is necessary to allow the service to operate. All other ports, protocols, and connections are blocked by default. Virtual Local Area Networks, or VLANs, and access control lists, or ACLs, are used to restrict network communications by source and destination networks, protocols, and port numbers. An ACL contains a list of resources and the objects, users, computers, and applications that are allowed to access those resources. When an object attempts to use a resource that is protected by an ACL, if it's not in the list, it won't be given access. Items that implement network-based ACLs include routers and load balancers. You control traffic flow through these items by defining firewall rules. The following steps describe how a connection is established to an Azure SQL database. Clients connect to a gateway that has a public IP address and listens on port 1433. Depending on the effective connection policy, the gateway either redirects traffic to the database cluster or acts as a proxy for the database cluster. Note that Azure SQL Database uses a clustered topology to provide high availability. Each server and database is transparently replicated to ensure that a server is always accessible, even in the event of a database or server failure. Inside the database cluster, traffic is forwarded to the appropriate Azure SQL database. If you're connecting from within another Azure service, such as a web application running under Azure App Service, your connections have a connection policy of redirect by default. For example, the policy of redirect. After your application establishes a connection to the Azure SQL database through the gateway, all following requests from your application will go directly to the database rather than through the gateway. If connectivity to the database subsequently fails, your application will have to reconnect through the gateway, where it might be directed to a different copy of the database running on another server in the cluster. Okay, let's take a look at the connectivity from outside of Azure now. If you're connecting from outside Azure, such as an on-premises application, your connections have a connection policy of proxy by default. A policy of proxy means the connection is established via the gateway, and all subsequent requests flow through the gateway. Each request could potentially be serviced by a different database in the cluster. Denial of service, or DOS attacks, are reduced by a SQL database gateway service called DOSGuard. DOSGuard actively tracks failed logins from IP addresses. If there are multiple failed logins from a specific IP address within a period of time, the IP address is blocked from accessing any resources in the service for a short while. In addition, the Azure SQL Database Gateway performs the following tasks. It validates all connections to the database servers to ensure that they are from genuine clients. It encrypts all communications between a client and the database servers. It inspects each network packet sent over a client connection. The gateway validates the connection information in the packet and forwards it to the appropriate physical server based on the database name that's specified in the connection string. When you create your Azure database for PostgreSQL Server, a default database named Postgres is created. To connect to your database server, you need your full server name and admin sign-in credentials. You can easily find the server name and sign-in information on the server overview page in the portal. This page contains the server name and the server admin sign-in name. Connections to your Azure database for PostgreSQL Server communicate over port 5432. When you try to connect from within a corporate network, outbound traffic over port 5432 might not be allowed by your network's firewall. If so, you can't connect to your server unless your IT department opens up port 5432. A PostgreSQL database server has a number of configuration parameters that you can set. These parameters support fine-tuning of the database and debugging of code in the database. You can modify these parameters using the Server Parameters page in the Microsoft Azure portal. If you're familiar with PostgreSQL, you'll find that not all parameters are supported in Microsoft Azure. The Server Parameters page on the Microsoft website describes the PostgreSQL parameters that are available. There is a link to this document from the additional readings at the end of this lesson. PostgreSQL also provides the ability to extend the functionality of your database using extensions. Extensions bundle multiple related SQL objects together in a single package that can be loaded or removed from your database with a single command. After being loaded in the database, extensions function like built-in features. You install an extension in your database before you can use it. To install a particular extension, run the Create Extension command from the pgsql tool to load the packaged objects into your database. Not all PostgreSQL extensions are supported in Microsoft Azure. For a full list, read PostgreSQL extensions in Azure Database for PostgreSQL single server on the Microsoft website. You can find a link to this document from the additional readings at the end of this lesson. Let's talk about read replicas now for PostgreSQL. You can replicate data from an Azure database for PostgreSQL server to a read-only server. Azure Database for PostgreSQL supports replication from the master server up to 5 replicas. Replicas are updated asynchronously with the PostgreSQL engine native replication technology. Read replicas help to improve the performance and scale of read-intensive workloads. Read workloads can be isolated to the replicas, while write workloads can be directed to the master. A common scenario is to have BI and analytical workloads use read replicas as the data source for reporting. Because replicas are read-only, they don't directly reduce the burden of write operations on the master. This feature isn't targeted at write-intensive workloads. Replicas are new servers that you manage similar to regular Azure Database for PostgreSQL servers. For each read replica, you're billed for the provisioned compute in vCourse and storage in gigabytes per month. You can use the replication page for a PostgreSQL server in the Azure portal to add read replicas to your database. In order to connect to the MySQL database you've provisioned, you'll need to enter the connection information. This information includes fully qualified server name and sign-in credentials. You can find this information on the overview page for your server. Connections to your Azure database for MySQL Server communicate over port 3306. When you try to connect from within a corporate network, outbound traffic over port 3306 might not be allowed by your network's firewall. If so, you cannot connect to your server unless your IT department opens port 3306. By default, SSL connection security is required and enforced on your Azure database for MySQL Server. Let's now take a look at how you can configure server parameters for MySQL. Like PostgreSQL, a MySQL database server has a number of configuration parameters that you can set. You can modify these parameters using the Server Parameters page in the Azure portal. You can find more information about the parameters available for MySQL in Azure on the How to Configure Server Parameters in Azure Database for MySQL by using the Azure portal page on the Microsoft website. There is a link to this document from the additional readings at the end of this lesson. Finally, let's also look at read replicas for MySQL. This feature is also similar to the one that is available for PostgreSQL. You can create up to 5 read replicas for a MySQL database. This feature enables you to geo-replicate data across regions and distribute the overhead associated with read-intensive workloads. Replication is asynchronous from the master server, so there may be some lag between records being written at the master and becoming available across all replicas. Read replication isn't intended to support write-heavy workloads. You can use the replication page for a MySQL server in the Azure portal to add read replicas to your database. It's important to note that the read replica feature is only available for Azure Database for MySQL servers in the general purpose or memory optimized pricing tier. Ensure the source server is one of these pricing tiers. In this lesson, we've learned how to provision and deploy relational databases using different types of data stores. You've seen how you can deploy Azure Data Services through the Azure portal, the Azure CLI, and Azure PowerShell. You've also learned how to configure connectivity to these databases to allow access from on-premises or within an Azure virtual network. You've also seen how to protect your database using tools such as the firewall and by configuring authentication. Hello, and welcome to this lesson where you will explore how to query relational data in Microsoft Azure. Microsoft Azure enables you to create relational databases using a number of technologies. These include Azure SQL Database, Azure Database for PostgreSQL, Azure Database for MySQL, and Azure Database for MariaDB. Imagine that you work as a developer for a large supermarket chain called Contoso. The company has created a data store that will be used to store product inventory. The development team has used an Azure SQL database to store their data. They need to know how to query and manipulate this data using SQL. In this lesson, you'll learn how to use these database services to store and retrieve data. You'll examine how to use some of the common tools available for these database management systems to connect to database services running in Microsoft Azure. This lesson focuses on using Azure SQL Database, Azure Database for PostgreSQL, and Azure Database for MySQL. If you are using Azure Database for MariaDB, the dialect of SQL is very similar to that used by MySQL. In this lesson, you will describe query techniques for data using the SQL language and query relational data. SQL stands for Structured Query Language and is used to communicate with a relational database. It's the standard language for relational database management systems. SQL statements are used to perform tasks such as update data in a database or retrieve data from a database. Some common relational database management systems, or RDBMS, that use SQL include Microsoft SQL Server, MySQL, PostgreSQL, MariaDB, and Oracle. SQL was originally standardized by the American National Standards Institute in 1986 and by the International Organization for Standardization, or ISO, in 1987. Since then, the standard has been extended several times as relational database vendors have added new features to their systems. Additionally, most database vendors include their own proprietary extensions that are not part of the standard, which has resulted in a variety of dialects of SQL. Now you'll learn about SQL. You'll see how it's used to query and maintain data in a database and the different dialects that are available. You can use SQL statements such as select, insert, update, delete, create, and drop to accomplish almost everything that one needs to do with a database. Although these SQL statements are part of the SQL standard, many database management systems also have their own additional proprietary extensions to handle the specifics of that database management system. These extensions provide functionality not covered by the SQL standard and include areas such as security management and programmability. Microsoft SQL Server, for example, uses Transact SQL, which is sometimes referred to as T-SQL. This implementation includes proprietary extensions for writing stored procedures and triggers, application code that can be stored in the database, and managing user accounts. PostgreSQL and MySQL also have their own versions of these features. Some popular dialects of SQL include Transact SQL, T-SQL. This version of SQL is used by Microsoft SQL Server and Azure SQL Database. PGSQL. This is the dialect with extensions implemented in PostgreSQL. PL/SQL. This is the dialect used by Oracle. PL/SQL stands for Procedural Language SQL. Users who plan to work specifically with a single database system should learn the intricacies of their preferred SQL dialect and platform. Let's look at SQL statement types now. SQL statements are grouped into two main logical groups. They are Data Manipulation Language, or DML, and Data Definition Language, or DDL. You use DML statements to manipulate the rows in a relational table. These statements enable you to retrieve or query data, insert new rows, or edit existing rows. You can also delete rows if you don't need them anymore. The four main DML statements are select, which selects or reads rows from a table; update, which edits or updates existing rows; delete, which deletes existing rows in a table; and insert, which inserts new rows into a table. The basic form of an insert statement will insert one row at a time. By default, the select, update, and delete statements are applied to every row in a table. Let's begin with an example of a select statement. This code selects all rows from the table named MyTable, where myColumn2 is equal to the value of Contoso. The function of the from clause is to specify the table to query. You usually apply a where clause with these statements in order to specify criteria. Only rows that match these criteria will be either selected, updated, or deleted. If a query returns many rows, they don't necessarily appear in any specific sequence. If you want to sort the data, you can add an order by clause. The data will be sorted by the specified column. In this example, the order by clause is placed after the from clause in the query. You can also run select statements that retrieve data from multiple tables using a join clause. Joins indicate how the rows in one table are connected with rows in another to determine what data to return. A join condition defines the way two tables are related in a query by specifying the column from each table to be used for the join. A typical join condition specifies a foreign key from one table and its associated primary key in the other table. Specifying a logical operator, for example equal or not equal, to be used in comparing values from the columns. This query shows an example that joins two tables, named Inventory and Customer Order. The query retrieves all rows where the value in the Inventory ID column in the Inventory table matches the value in the Inventory ID column in the Customer Order table. You join two tables together by using the join operator, which is placed after the from clause. SQL also provides aggregate functions to perform computation and aggregation operations. An aggregate function calculates a single result across a set of rows or an entire table. This example uses the min function to find the minimum value in the myColumn1 column across all rows in the myTable table. A number of other aggregate functions are available, including max, which returns the largest value in a column; average, which returns the average value, but only if the column contains numeric data; sum, which returns the sum of all the values in the column, but also only if the column is numeric; and finally count, which counts the number of rows returned by a select statement. This example shows how to update an existing table row using the update statement. First, the update command specifies the table to be updated. Then, using the set command, it modifies the value of the myColumn2 column, but only for rows where myColumn1 is equal to the value of 3. All other rows are left unchanged. The delete statement is used to remove rows by specifying the table to delete from. Then you use a where clause that identifies the rows to be deleted. It's important to note that SQL doesn't provide "are you sure" prompts, so be careful when using delete or update without a where clause because you can lose or modify a lot of data. If you omit the where clause, an update statement will modify every row in the table, and a delete statement will delete all the rows in the table. Finally, let's look at the insert statement. The insert statement takes a slightly different form than the others. You must specify a table and its columns using an into clause, followed by a list of the values to be stored in these columns. This example inserts a new row into the myTable table. Standard SQL only supports inserting one row at a time. Some dialects allow you to specify multiple value clauses to add several rows at a time. We will discuss SQL dialects in more detail later. Okay, let's take a look at DDL statements now. You use DDL statements to create, modify, and remove tables and other objects in a database. These objects can be tables, stored procedures, views, and so on. The four main DML statements are create, which creates a new object in the database, such as a table or a view; alter, which modifies the structure of an object. For instance, altering a table to add a new column. Drop, which removes an object from the database. And rename, which renames an existing object. It's important to note the drop statement is very powerful. When you drop a table, all the rows in that table are lost. Unless you have a backup, you won't be able to retrieve this data. Let's look at an example as to how you could create a new database table using the create table statement. The items to specify the details of each column are placed between the parentheses. These include the column name, the data type such as int for integers or varchar for strings, whether the column must always contain a value, which is written as not null, and whether the data in the column is used to uniquely identify a row, which is written as primary key. Each table should always have a primary key, although SQL doesn't enforce this rule. It's important to note that columns marked as not null are referred to as mandatory columns. If you omit the not null clause, you can create rows that do not contain any value in the column. An empty column in a row is said to have a null value. The data types available for columns in a table will vary between database management systems. However, most database management systems support numeric types such as int, an integer or whole number, and string types such as varchar, which stands for variable length character data. For more information, you should refer to the Microsoft documentation for your selected database management system. In order to query relational data in Azure SQL Database, you run SQL commands from tools and utilities that connect to the appropriate database. The tooling available depends on the database management system you're using. Now we will describe briefly the tools that you can use to connect to Azure SQL Database. You will explore these and other tools further in the readings and exercises at the end of this lesson. You can use any of these tools to query data held in Azure SQL Database. The query editor in the Azure portal, the SQL command utility from the command line or the Azure Cloud Shell, SQL Server Management Studio, Azure Data Studio, and SQL Server Data Tools. In order to use these tools, you first need to establish a connection to the database. To do that, you require the details of the server in order to connect to an Azure SQL Database account. These details typically include the credentials, such as a username and password that has access to the server, and the name of the database to use on the server. You can find the server name for a database using the Azure portal. From the Azure portal, go to the page for your database, and on the overview page, note the fully qualified server name in the server name field. Some tools and applications may also require a connection string that identifies the server, database, account name, and password. Select Show Database Connection Strings to access this information. The database connection string shown in the Azure portal does not include the password for the account. You must contact your database administrator for this information. The following readings in this lesson will walk you through the process of connecting to and querying a database using the most common query tools. The process itself is quite similar for each RDBMS, but you will need to use a specific tool depending on the type of database that you wish to connect to. For example, you can use the Azure portal to connect to an Azure SQL database. You can then select the query editor and create and run your SQL code. Or you could use Azure Data Studio, which is a graphical utility for creating and running SQL queries from your desktop. SQL Server Management Studio is also another tool that you can download and run on your desktop. To connect to a PostgreSQL database and run queries, you can use tools such as the pgadmin graphical user interface and the pSQL command line utility. There are a large number of third-party utilities you can use also. This example demonstrates the use of Azure Data Studio to execute a new query. Finally, there are also many tools available to connect to MySQL that enable you to create and run scripts of SQL commands. You can use the MySQL command line utility, which is also available in the Azure Cloud Shell, or you can use graphical tools from the desktop, such as this example using MySQL Workbench. In this lesson, you've learned how to use SQL to store and retrieve data in Azure SQL Database, Azure Database for PostgreSQL, and Azure Database for MySQL. You've seen how to connect to these database management systems using some of the common tools currently available. And finally, a word on cleanup. The sandbox automatically cleans up your resources when you're finished with this module. When you're working in your own subscription, it's a good idea at the end of a project to identify whether you still need the resources you created. Resources left running can cost you money. You can delete resources individually or delete the resource group to delete the entire set of resources.
Hello and welcome to this course on non-relational data in Microsoft Azure. In this course, you will see a range of technologies that Microsoft Azure provides for storing non-relational data. Each offering has its strengths and works best in specific scenarios. After you decide which services addresses your organization's needs, you can configure them so your applications and users can start using these services. In this course, you will learn about Azure Table Storage, Azure Blob Storage, Azure File Storage, and Azure Cosmos DB, and explore situations for using them. You will explore provisioning and deploying non-relational data services in Microsoft Azure. You will also explore basic connectivity issues and data security components. And finally, in Module 3, you will learn how to manage non-relational data stores in Microsoft Azure. You will learn to identify management tools for non-relational data and have an opportunity to upload data to a Cosmos DB and query this data and upload and download data in an Azure storage account. Hello and welcome. In this lesson, you will explore non-relational data offerings in Microsoft Azure. Data comes in all shapes and sizes and can be used for a wide range of purposes. Many organizations use relational databases to store this data. However, the relational model might not be the most appropriate schema. The structure of the data might be too varied to easily model as a set of relational tables. For example, the data might contain items such as video, audio, images, temporal information, large volumes of free text, encrypted information, or other types of data that aren't inherently relational. Additionally, the data processing requirements might not be best suited by attempting to convert this data into the relational format. In these situations, it may be better to use non-relational repositories that can store data in its original format, but that allow fast storage and retrieval access to this data. Suppose you're a data engineer working at Contoso, an organization with a large manufacturing operation. The organization has to gather and store information from a range of sources, such as real-time data monitoring of the status of production line machinery, product quality control data, historical production logs, product volumes in stock, and raw materials inventory data. This information is critical to the operation of the organization. You've been asked to determine how best to store this information so that it can be stored quickly and queried easily. In this lesson, you will explore use cases and management benefits of using the following Microsoft offerings: Azure Table Storage, Azure Blob Storage, Azure File Storage, Azure Cosmos DB. Azure Table Storage implements the NoSQL key value model. In this model, the data for an item is stored as a set of fields and the item is identified by a unique key. Azure Table Storage is a scalable key value store held in the cloud. You create a table using a Microsoft Azure storage account. In an Azure Table Storage table, items are referred to as rows and fields are known as columns. However, don't let this terminology confuse you by thinking that an Azure Table Storage table is like a table in a relational database. An Azure table enables you to store semi-structured data. All rows in a table must have a key, but apart from that, the columns in each row can vary. Unlike traditional relational databases, Azure Table Storage tables have no concept of relationships, stored procedures, secondary indexes, or foreign keys. Data will usually be denormalized, with each row holding the entire data for a logical entity. For example, a table holding customer information might store the forename, last name, one or more telephone numbers, and one or more addresses for each customer. The number of fields in each row can be different depending on the number of telephone numbers and addresses for each customer, and the details recorded for each address. In a relational database, this information will be split across multiple rows and several tables. In this example, Azure Table Storage provides much faster access to the details of a customer because the data is available in a single row without requiring that you perform joins across relationships. To help ensure fast access, Azure Table Storage splits a table into partitions. Partitioning is a mechanism for grouping related rows based on a common property or partition key. Rows that share the same partition key will be stored together. The key in an Azure Table Storage table comprises two elements: the partition key that identifies the partition containing the row, and a row key that is unique to each row in the same partition. Items in the same partition are stored in row key order. Rows that share the same partition key will be stored together. If an application adds a new row to a table, Microsoft Azure ensures that the row is placed in the correct position in the table. In an Internet of Things scenario, for example, the partition key would be the device and the row key is a date and time value. Partitioning not only helps to organize data, it can also improve scalability and performance. Partitions are independent from each other and can grow or shrink as rows are added to or removed from a partition. A table can contain any number of partitions. When you search for data, you can include the partition key in the search criteria. This helps to narrow down the volume of data to be examined and improves performance by reducing the amount of I/O, reads and writes, needed to locate the data. This scheme enables an application to quickly perform point queries that identify a single row and range queries that fetch a contiguous block of rows in a partition. In a point query, when an application retrieves a single row, the partition key enables Microsoft Azure to quickly hone in on the correct partition, and the row key lets Microsoft Azure identify the row in that partition. You might have hundreds of millions of rows, but if you've defined the partition and row keys carefully when you designed your application, data retrieval can be very quick. The partition key and row key effectively define a clustered index over the data. In a range query, the application searches for a set of rows in a partition, specifying the start and end points of the set as row keys. This type of query is also very quick, as long as you have designed your row keys according to requirements of the queries performed by your application. The columns in a table can hold numeric, string, or binary data, up to 64 kilobytes in size. A table can have up to 250 columns, apart from the partition and row keys. The maximum row size is 1 megabyte. For more information, read Understanding the Table Service Data Model, which is available in the additional readings of this lesson. Azure Table Storage tables are schemaless. It's easy to adapt your data as the needs of your application evolve. You can use tables to hold flexible data sets such as user data for web applications, address books, device information, or other types of metadata your service requires. The important part is to choose the partition and row keys carefully. The primary advantages of using Azure Table Storage tables over other ways of storing data include: it's simpler to scale. It takes the same time to insert data in an empty table or a table with billions of entries. A Microsoft Azure storage account can hold up to 500 terabytes of data. A table can hold semi-structured data. There's no need to map and maintain the complex relationships typically required by a normalized relational database. Row insertion is fast, and data retrieval is fast if you specify the partition and row keys as query criteria. There are disadvantages to storing data this way though, including: consistency needs to be given consideration as transactional updates across multiple entities aren't guaranteed. There's no referential integrity. Any relationships between rows need to be maintained externally to the table. It's difficult to filter and sort on non-key data. Queries that search based on non-key fields could result in full table scans. There are a few examples where Azure Table Storage can serve as an excellent mechanism for efficient data storage. First, storing terabytes of structured data capable of serving web-scale applications. Examples include product catalogs for e-commerce applications and customer information where the data can be quickly identified and ordered by a composite key. In the case of a product catalog, the partition key could be the product category, such as footwear, and the row key identifies the specific product in that category, such as climbing boots. Second, Azure Table Storage is a good mechanism when storing datasets that don't require complex joins, foreign keys, or stored procedures, and that can be denormalized for fast access. In an Internet of Things system, you might use Azure Table Storage to capture device sensor data. Each device could have its own partition, and the data could be ordered by the date and time each measurement was captured. And finally, Azure Table Storage is good for capturing event logging and performance monitoring data. event log, and performance information typically contain data that is structured according to the type of event or performance measure being recorded. The data could be partitioned by event or performance measurement type and ordered by the date and time it was recorded. Alternatively, you could partition data by date if you need to analyze an ordered series of events and performance measures chronologically. If you want to analyze data by type and date or time, then consider storing the data twice, partitioned by type and again by date. Writing data is fast and the data is static once it has been recorded. Azure Table Storage is intended to support very large volumes of data, up to several hundred terabytes in size. As you add rows to a table, Azure Table Storage automatically manages the partitions in a table and allocates storage as necessary. You don't need to take any additional steps yourself. Azure Table Storage provides high availability guarantees in a single region. The data for each table is replicated 3 times within a Microsoft Azure region. For increased availability, but at additional cost, you can create tables in geo-redundant storage. In this case, the data for each table is replicated a further 3 times in another region several hundred miles away. If a replica in the local region becomes unavailable, Microsoft Azure will transparently switch to a working replica while the failed replica is recovered. If an entire region is hit by an outage, your tables are safe in a remote region and you can quickly switch your application to connect to that remote region. Azure Table Storage helps to protect your data. You can configure security and role-based access control to ensure that only the people or applications that need to see your data can actually retrieve it. Many applications need to store large binary data objects such as images and video streams. Microsoft Azure Virtual Machines use blob storage for holding virtual machine disk images. These objects can be several hundreds of gigabytes in size. The term blob is an acronym for a binary large object. Azure Blob Storage is a service that enables you to store massive amounts of unstructured data or blobs in the cloud. Like Azure Table Storage, you create blobs using a Microsoft Azure Storage account. Microsoft Azure currently supports 3 different types of blob. First, there are block blobs. A block blob is handled as a set of blocks. Each block can vary in size up to 100 megabytes. A block blob can contain up to 50,000 blocks, giving a maximum size of over 4.7 terabytes. The amount is the smallest amount of data that can be read or written as an individual unit. Block blobs are best used to store discrete, large binary objects that change infrequently. Then there are page blobs. A page blob is organized as a collection of fixed-size 512-byte pages. A page blob is optimized to support random read and write operations. You can fetch and store data for a single page if necessary. A page blob can hold up to 8 terabytes of data. Microsoft Azure uses page blobs to implement virtual disk storage for virtual machines. Finally, there are append blobs. An append blob is a block blob optimized to support append operations. You can only add blocks to the end of an append blob. Updating or deleting existing blocks isn't supported. Each block can vary in size, up to 4 megabytes. The maximum size of an append blob is just over 195 gigabytes. When you create a storage account, blobs are created within containers. A container provides a convenient way of grouping related blobs together, and you can organize blobs in a hierarchy of folders similar to files in a file system on disk. You control who can read and write blobs inside a container at the container level. Blob storage provides 3 different access tiers, which helps to balance storage costs and latency. The first one, the hot tier, is the default. You use this tier for blobs that are accessed frequently. The blob data is stored on high-performance media. The cool tier has lower performance and incurs reduced storage charges compared to the hot tier. Use the cool tier for data that is accessed infrequently. It's common for newly created blobs to be accessed frequently initially, but less so as time passes. In these situations, you can create the blob in the hot tier, but migrate it to the cool tier later. You can also migrate a blob from the cool tier back to the hot tier. Finally, the archive tier provides the lowest storage cost, but with increased latency. The archive tier is intended for historical data that mustn't be lost, but is required only rarely. Blobs in the archive tier are effectively stored in an offline state. Typical reading latency for the hot and cool tiers is a few milliseconds, but for the archive tier, it can take hours for the data to become available. To retrieve a blob from the archive tier, you must change the access tier to hot or cool. The blob will then be rehydrated. You can read the blob only when the rehydration process is complete. You can create lifecycle management policies for blobs in a storage account. A lifecycle management policy can automatically move a blob from hot to cool and then to the archive tier as it ages and is used less frequently. Policy is based on the number of days since modification. A lifecycle management policy can also be configured to delete outdated blobs. Now you must be thinking how blob storage is used. Common uses of Azure Blob Storage include serving images or documents directly to a browser in the form of a static website. Visit static websites hosted in Microsoft Azure Storage for detailed information. Storing files for distributed access. Streaming video and audio. Storing data for backup and restore, disaster recovery and archiving. And storing data for analysis by an on-premises or Azure hosted service. You should note that Azure Blob Storage is also used as the basis for Azure Data Lake Storage. You can use Azure Data Lake Storage for performing big data analytics. To ensure availability, Azure Blob Storage provides redundancy. Blobs are always replicated 3 times in the region in which you created your account, but you can also select geo-redundancy, which replicates your data in a second region at additional cost. Other features available with Azure Blob Storage include versioning. You can maintain and restore earlier versions of a blob. Soft delete. This feature enables you to recover a blob that has been removed or overwritten by accident or otherwise. Snapshots. A snapshot is a read-only version of a blob at a particular point in time. And change feed. The change feed for a blob provides an ordered read-only record of the updates made to a blob. You can use the change feed to monitor these changes and perform operations such as update a secondary index, synchronize with a cache, search engine, or any other content management scenarios. Extract business, analytics, insights, and metrics based on changes that occur to your objects, either in a streaming manner or batched mode. Store, audit, and analyze changes to your objects over any period of time for security, compliance, or intelligence for enterprise data management. Build solutions to backup, mirror, or replicate object state in your account for disaster management or compliance. And build connected application pipelines that react to change events or schedule executions based on created or changed objects. Many on-premises systems comprising a network of in-house computers make use of file shares. A file share enables you to store a file on one computer and grant access to that file to users and applications running on other computers. This strategy can work well for computers in the same local area network, but doesn't scale well as the number of users increases or if users are located at different sites. Azure File Storage enables you to create file shares in the cloud and access these file shares from anywhere with an internet connection. Azure File Storage exposes file shares using the Server Message Block 3.0 SMB protocol. This is the same file sharing protocol used by many existing on-premises applications. These applications should continue to work unchanged if you migrate your file shares to the cloud. The applications can be running on-premises or in the cloud. You can control access to shares in Azure File Storage using authentication and authorization services available through Azure Active Directory domain services. You create Azure File Storage in a storage account. Azure File Storage enables you to share up to 100 terabytes of data in a single storage account. This data can be distributed across any number of file shares in the account. The maximum size of a single file is 1 terabyte, but you can set quotas to limit the size of each share below this figure. Currently, Azure File Storage supports up to 2,000 concurrent connections per shared file. Once you've created a storage account, you can upload files to Azure File Storage using the Azure portal or tools such as the AZ Copy utility. You can also use the Azure File Sync service to synchronize locally cached copies of shared files with the data in Azure File Storage. Azure File Storage offers 2 performance tiers. The standard tier uses hard disk-based hardware in a data center, and the premium tier uses solid-state disks. The premium tier offers greater throughput, but is charged at a higher rate. Azure File Storage is designed to support many scenarios. One scenario allows you to migrate existing applications to the cloud. Many existing applications access data using file-based APIs and are designed to share data using SMB file shares. Azure File Storage enables you to migrate your on-premises file or file share-based applications to Microsoft Azure without having to provision or manage highly available file server virtual machines. Another scenario allows you to share server data across on-premises and cloud. Customers can now store server data such as log files, event data, and backups in the cloud to leverage the availability, durability, scalability, and geo-redundancy built into the Microsoft Azure Storage Platform. With encryption in SMB 3.0, you can securely mount Azure File Storage shares from anywhere. Applications running in the cloud can share data with on-premises applications using the same consistencies guaranteed implemented by on-premises SMB servers. A third scenario is when you integrate modern applications with Azure File Storage. By leveraging the modern REST API that Azure File Storage implements in addition to SMB 3.0, you can integrate legacy applications with modern cloud applications or develop new file or file share-based applications. And finally, Azure File Storage can offer support to simplify hosting high-availability workload data. Azure File Storage delivers continuous availability, so it simplifies the effort to host high availability, sometimes called HA, workload data in the cloud. The persistent handles enabled in SMB 3.0 increases availability of the file share, which makes it possible to host applications such as SQL Server and IIS in Microsoft Azure with data stored in shared file storage. It is important to note that you should not use Azure File Storage for files that can be written by multiple concurrent processes simultaneously. Multiple writers require careful synchronization, otherwise the changes made by one process can be overwritten by another. The alternative solution is to lock the file as it is written and then release the lock when the write operation is complete. However, this approach can severely impact concurrency and limit performance. Azure File Storage is a fully managed service. Your shared data is replicated locally within a region, but can also be geo-replicated in a second region. Microsoft Azure aims to provide up to 300 megabytes per second of throughput for a single standard file share, but you can increase throughput capacity by creating a premium file share for additional cost. All data is encrypted at rest, and you can enable encryption for data in transit between Azure File Storage and your applications. Tables, blobs, and files are all specialized types of storage aimed at helping to solve specific problems. Reading and writing a table is a significantly different task from storing data in a blob or processing a file. Sometimes you require a more generalized solution that enables you to store and query data more easily without having to worry about the exact mechanism for performing these operations. This is where a database management system proves useful. Relational databases store data in relational tables, but sometimes the structure imposed by this model can be too rigid and often leads to poor performances unless you spend time implementing detailed tuning. Other models, collectively known as NoSQL databases, exist. These models store data in other structures, such as documents, graphs, key value stores, and column family stores. Azure Cosmos DB is a multi-model NoSQL database management system. Cosmos DB manages data as a partitioned set of documents. A document is a collection of fields identified by a key. The fields in each document can vary, and a field can contain child documents. Many document databases use JSON, JavaScript object notation, to represent the document structure. In this format, the fields in a document are enclosed between braces, and each field is prefixed with its name. Let's assume an example with a pair of documents representing customer information. Each customer document will include child documents containing the name and address, but the fields in these child documents can vary between customers. A document can hold up to 2 megabytes of data, including small binary objects. If you need to store larger blobs as part of a document, use Azure Blob Storage and add a reference to the blob in the document. Cosmos DB provides APIs to enable you to access these documents using a set of well-known interfaces. API stands for Application Programming Interface. Database management systems and other software frameworks provide a set of APIs that developers can use to write programs that need to access data. The APIs will often be different from different database management systems. Here are some APIs that Cosmos DB currently supports. The SQL API interface provides a SQL-like query language over documents that enables you to identify and retrieve documents using select statements. You can run queries against the database to find specific information such as a customer's address. The Table API interface enables you to use the Azure Table Storage API to store and retrieve documents. The purpose of this interface is to enable you to switch from table storage to Cosmos DB without requiring that you modify your existing applications. MongoDB is another well-known document database with its own programmatic interface. Many organizations run MongoDB on-premises. You can use the MongoDB API for Cosmos DB to enable a MongoDB application to run unchanged against a Cosmos DB database. You can migrate the data in the MongoDB database to Cosmos DB running in the cloud, but you continue to run your existing applications to access this data. Cassandra is a column family database management system. This is another database management system that many organizations run on-premises. The Cassandra API for Cosmos DB provides a Cassandra-like programmatic interface for Cosmos DB. Cassandra API requests are mapped to Cosmos DB document requests. As with the MongoDB API, the primary purpose of the Cassandra API is to enable you to quickly migrate Cassandra databases and applications to Cosmos DB. And finally, the Gremlin API implements a graph database interface to Cosmos DB. A graph is a collection of data objects and directed relationships. Data is still held as a set of documents in Cosmos DB, but the Gremlin API enables you to perform graph queries over data. Using the Gremlin API, you can walk through the objects and relationships in the graph to discover all manner of complex relationships, such as what is the name of the pet of Sam's landlord. It's important to note that the primary purpose of the table, MongoDB, Cassandra, and Gremlin APIs is to support existing applications. If you are building a new application and database, you should use the SQL API. Documents in a Cosmos DB database are organized into containers. These documents in a container are grouped together into partitions. A partition holds a set of documents that share a common partition key. You designate one of the fields in your documents as the partition key. You should select the partition key that collects all related documents together. This approach helps to reduce the amount of I/O disk reads that queries might need to perform when retrieving a set of documents for a given entity. For example, in a document database for an e-commerce system recording the details of customers and the orders they've placed, you could partition the data by customer ID and store the customer and order details for each customer in the same partition. To find all the information and orders for a customer, you simply need to query that single partition. There's a superficial similarity between Cosmos DB container and a table in Azure Table Storage. In both cases, data is partitioned and documents, rows in a table, are identified by a unique ID within a partition. However, the similarity ends there. Unlike Azure Table Storage, documents in a Cosmos DB partition aren't sorted by ID. Instead, Cosmos DB maintains a separate index. This index contains not only the document IDs, but also tracks the value of every other field in each document. This index is created and maintained automatically. It enables you to perform queries that specify criteria referencing any fields in a container without incurring the need to scan the entire partition to find that data. For a detailed description of how Cosmos DB indexing works, read Indexing in Azure Cosmos DB Overview in the additional readings of this lesson. Cosmos DB is a highly scalable database management system. Cosmos DB automatically allocates space in a container for your partitions, and each partition can grow up to 10 gigabytes in size. Indexes are created and maintained automatically. There's virtually no administrative overhead. To ensure availability, all databases are replicated within a single region. This replication is transparent, and failover from a failed replica is automatic. Cosmos DB guarantees 99.99% high availability. Additionally, you can choose to replicate data across regions at additional cost. This feature enables you to place copies of data anywhere in the world and enable applications to connect to the copy of the data that happens to be the closest, reducing query latency. All replicas are synchronized, although there may be a small window while updates are transmitted and applied. The multi-master replication protocol supports 5 well-defined consistency choices. From strongest to weakest, the levels are strong, bounded staleness, session, consistent prefix, and eventual. For more information, see consistency levels in Azure Cosmos DB, which can be found in the additional readings at the end of this lesson. Cosmos DB guarantees less than 10 milliseconds latencies for both reads and writes at the 99th percentile all around the world. This capability enables sustained ingestion of data and fast queries for highly responsive apps. Cosmos DB is certified for a wide array of compliance standards. Additionally, all data in Cosmos DB is encrypted at rest and in transit. Cosmos DB provides row-level authorization and adheres to strict security standards. Cosmos DB is a foundational service in Microsoft Azure and has been used by many of Microsoft's products for mission-critical applications at global scale, including Skype, Xbox, Microsoft 365, Microsoft Azure, and many others. Cosmos DB is highly suitable for the following scenarios. IoT and telematics. These systems typically ingest large amounts of data in frequent bursts of activity. Cosmos DB can accept and store this information very quickly. The data can then be used by analytics services such as Azure Machine Learning, Azure HC Insight, and Power BI. Additionally, you can process the data in real time using Azure functions that are triggered as data arrives in the database. Microsoft uses Cosmos DB for its own e-commerce platforms that run as part of Windows Store and Xbox Live. It's also used in the retail industry for storing catalog data and for event sourcing in order processing pipelines. Gaming. The database tier is a crucial component of gaming applications. Modern games perform graphical processing on mobile or console clients, but rely on the cloud to deliver customized and personalized content like in-game stats, social media integration, and high-score leaderboards. Games often require single millisecond latencies for reads and writes to provide an engaging in-game experience. A game database needs to be fast and be able to handle massive spikes in request rates during game launches and feature updates. Web and mobile applications. Azure Cosmos DB is commonly used within web and mobile applications and is well suited for modeling social interactions, integrating with third-party services, and for building rich personalized experiences. The Cosmos DB software development kits, or SDK, can be used to build rich iOS and Android applications using the popular Xamarin framework. For additional information about uses for Cosmos DB, read common Azure Cosmos DB use cases in the additional readings of this lesson. Microsoft Azure provides a range of technologies for storing non-relational data. Each technology has its own strengths and is suited to specific scenarios. In this lesson, you've learned about the following technologies and how you can use them to meet the requirements of various scenarios: Azure Table Storage, Azure Blob Storage, Azure File Storage, and Azure Cosmos DB. Hello and welcome. In this module, you will explore provisioning and deploying non-relational data services in Microsoft Azure. Microsoft Azure supports a number of non-relational data services, including Azure File Storage, Azure Blob Storage, Azure Data Lake Store, and Azure Cosmos DB. These services support different types of non-relational data. For example, you can use Cosmos DB to store documents and Blob Storage as a repository for large binary objects such as video and audio data. Before you can use a service, you must provision an instance of that service. You can then configure the service to enable you to store and retrieve data and to make it accessible to the users and applications that require it. Suppose you're a data engineer working at Contoso, an organization with a large manufacturing operation. The organization has to gather and store information from a range of sources, such as real-time data monitoring of the status of production line machinery, product quality control data, historical production logs, product volumes in stock, and raw materials inventory data. This information is critical to the operation of the organization. Contoso has decided to store this information in various non-relational databases according to the different data processing requirements for each dataset. You've been asked to provision a range of Microsoft Azure data services to enable applications to store and process the information. In this lesson, you will provision non-relational data services, configure non-relational data services, explore basic connectivity issues, and explore data security components. In the sample scenario, Contoso has decided that the organization will require a number of different non-relational stores. As the data engineer, you're asked to set up data stores using Azure Cosmos DB, Azure Blob Storage, Azure Data Lake Store, and Azure File Storage. Now you learn more about what the provisioning process entails and what actually happens when you provision a service. Provisioning is the act of running a series of tasks that a service provider, such as Azure Cosmos DB, performs to create and configure a service. Behind the scenes, the service provider will set up the various resources such as disks, memory, CPUs, networks, and so on, which are required to run the service. You'll be assigned these resources, and they remain allocated to you and charged to you until you delete the service. How the service provider provisions resources is opaque, and you don't need to be concerned with how this process works. All you do is specify parameters that determine the size of the resources required. How much disk space, memory, computing power, and network bandwidth. These parameters are determined by estimating the size of the workload that you intend to run using the service. In many cases, you can modify these parameters after the service has been created, perhaps increasing the amount of storage space or memory if the workload is greater than you initially anticipated. The act of increasing or decreasing the resources used by a service is called scaling. Let's look at the process that Microsoft Azure performs when you provision a service. First, the user specifies the provisioning parameters such as the type of service, storage, memory, and compute power. The provisioning parameters are then sent to Microsoft Azure to provision the service. Microsoft Azure allocates the necessary resources to create the service. Finally, the service is then ready for use. Microsoft Azure provides several tools you can use to provision services. The Azure portal is the most convenient way to provision a service for most users. The Azure portal displays a series of service-specific pages that prompt you for the settings required and validates these settings before actually provisioning the service. The Azure Command Line Interface, or CLI, provides a set of commands that you can run from the operating system command prompt or the Cloud Shell in the Azure portal. You can use these commands to create and manage Azure resources. The CLI is suitable if you need to automate service creation. You can store CLI commands in scripts, and you can run these scripts programmatically. The CLI can run on Windows, Mac OS, and Linux computers. For detailed information about the Azure CLI, read What is Azure CLI in the additional readings at the end of this lesson. Many administrators are familiar with using PowerShell commands to script and automate administrative tasks. Microsoft Azure provides a series of commandlets. These are Azure-specific commands that you can use in PowerShell to create and manage Azure resources. Like the CLI, PowerShell is available for Windows, Mac OS, and Linux. You can find further information about Azure PowerShell online at Azure PowerShell documentation, which is linked to in the additional readings at the end of this lesson. An Azure Resource Manager template describes the service or services that you want to deploy in a text file in a format known as JSON or JavaScript Object Notation. You can use templates to provision an Azure storage account. You send the template to Azure using the AZ deployment group create command in the Azure CLI or the new AZ resource group deployment command in Azure PowerShell. For more information about creating and using Azure Resource Manager templates to provision Azure resources, see What are Azure Resource Manager templates in the additional readings at the end of this lesson. Azure Cosmos DB is a document database suitable for a range of applications. In the sample scenario, Contoso decided to use Cosmos DB for part of their data storage and processing. In Cosmos DB, you organize your data as a collection of documents stored in containers. Containers are held in a database. A database runs in the context of a Cosmos DB account. You must create the account before you can set up any databases. You will now learn how to provision a Cosmos DB account and then create a database and a container in this account. You have already learned how to provision a Cosmos DB account interactively using the Azure portal. You can also perform this task programmatically through the Azure CLI, Azure PowerShell, or an Azure Resource Manager template. If you prefer to use the Azure CLI or Azure PowerShell, you can run commands to create a Cosmos DB account. The parameters to these commands correspond to many of the options you can select using the Azure portal. For example, you can create an account for the core SQL API with geo-redundancy between the East US and West US regions and support for multi-region writes using Azure CLI. Similarly, you can use PowerShell to accomplish the same goal. For more information about these commands, see the AZ Cosmos DB Create page for the Azure CLI or the new AZ Cosmos DB account page for PowerShell, which are linked to in the additional readings at the end of this lesson. It's important to note that in order to use Azure PowerShell to provision a Cosmos DB account, you must first install the AZ Cosmos DB PowerShell module by using the command install module name AZ Cosmos DB. The other deployment option is to use an Azure Resource Manager template. The template for Cosmos DB can be rather lengthy because of the number of parameters. To make life easier, Microsoft has published a number of example templates for handling different configurations. A link to these templates on the Microsoft website can be found in the additional readings at the end of this lesson. An Azure Cosmos DB account by itself doesn't really provide any resources other than a few pieces of static infrastructure. Databases and containers are the primary resource consumers. Resources are allocated in terms of the storage space required to hold your databases and containers and the processing power required to store and retrieve data. Azure Cosmos DB uses the concept of request units per second, or RUs, to manage the performance and cost of databases. This measure abstracts the underlying physical resources that need to be provisioned to support the required performance. You can think of a request unit as the amount of computation and I/O resources required to satisfy a simple read request made to the database. Microsoft gives a measure of approximately 1 RU as the resources required to read a 1 kilobyte document with 10 fields. So a throughput of 1 RU per second will support an application that reads a single 1 kilobyte document each second. You can specify how many RUs of throughput you require when you create a database or when you create individual containers in a database. If you specify throughput for a database, all the containers in that database share that throughput. If you specify throughput for a container, the container gets that throughput all to itself. If you under-provision by specifying too few RUs, Cosmos DB will start throttling performance. Once throttling begins, requests will be asked to retry later when hopefully there are available resources to satisfy it. If an application makes too many attempts to retry a throttled request, the request could be aborted. The minimum throughput you can allocate to a database or container is 400 RUs. You can increase and decrease the RUs for a container at any time. Allocating more RUs increases the cost. However, once you allocate throughput to a database or container, you'll be charged for the resources provisioned, whether you use them or not. You should note that if you applied the free tier discount to your Cosmos DB account, you get the first 400 RUs for a single database or container for free. 400 RUs is generally enough capacity for most small to moderate databases. The Azure portal provides a graphical user interface where you can create a database and a container more easily, which will be explored in detail in the next video. However, if you prefer to use the Azure CLI or Azure PowerShell, you can run commands to create documents and containers, which we will cover now. In Azure CLI, you can create a database by using the AZ Cosmos DB SQL database create command. Then you specify parameters such as account name, database name, resource group, subscription, and throughput. And you can create a container by using the AZ Cosmos DB SQL container create command. Then you specify the parameters account name, database name, container name, resource group, and partition key path. In Azure PowerShell, you can create a database by using the new AZ Cosmos DB SQL database command. Then you specify the parameters resource group name, account name, database name, and throughput. And you can create a container by using the new AZ Cosmos DB SQL container command, specifying the parameters, partition key kind, and partition key path. Besides Cosmos DB, Microsoft Azure supports other non-relational data services. These services are optimized for more specific cases than a generalized document database store. In the sample scenario, Contoso wants to use Azure Blob Storage to store video and audio files, Azure Data Lake Storage to support large volumes of data, and Azure File Storage to create file shares. Now you'll learn how to provision Data Lake Storage, Blob Storage, and File Storage. As with Cosmos DB, you can provision these services using the Azure Portal, the Azure CLI, Azure PowerShell, and Azure Resource Manager templates. Data Lake Storage, Blob Storage, and File Storage all require that you first create an Azure Storage account. Use the Create Storage Account page to set up a new storage account using the Azure Portal. On the Basics tab, provide for the following details. Under Subscription, select your Microsoft Azure subscription. And under Resource Group, either select an existing resource group or create a new one as appropriate. In Storage Account Name, note that as with a Cosmos DB account, each storage account must have a unique name that hasn't already been used by someone else. Under Location, select the region that is nearest to you if you're in the process of developing a new application, or the region nearest to your users if you're deploying an existing application. The performance setting has two options. Standard storage accounts are based on hard disks. They're the lowest cost of the two storage options, but have higher latency. This type of storage account is suitable for applications that require bulk storage that is accessed infrequently, such as archives. Premium storage uses solid-state drives and has much lower latency and better read-write performance than standard storage. Solid-state drives are best used for I/O-intensive applications, such as databases. You can also use premium storage to hold Azure Virtual Machine disks. A premium storage account is more expensive than a standard account. It is important to note that data lake storage is only available with a standard storage account, not premium. You will notice that under Account Kind, Azure Storage supports several different types of account. You can use General Purpose V2 storage account for blobs, files, queues, and tables, and is recommended for most scenarios that require Azure Storage. If you want to provision Azure Data Lake storage, you should specify this account type. General Purpose V1 is a legacy account type for blobs, files, queues, and tables. Use General Purpose V2 accounts when possible. The other types of accounts are block blob storage, file storage, and blob storage. Block blob storage is only available for premium accounts. You can use this account type for block blobs and append blobs. It's recommended for scenarios with high transaction rates or that use smaller objects or require consistently low storage latency. File storage is also only available for premium accounts. You use it to create files-only storage accounts with premium performance characteristics. It's recommended for enterprise or high-performance scale applications. Use this type if you're creating an account to support file storage. Blob storage is another legacy account type that can only hold blobs. Use General Purpose V2 accounts instead when possible. You can use this account type for Azure Data Lake storage, but the General Purpose V2 account type is preferable. Data in an Azure storage account is always replicated 3 times in the region you specify as the primary location for the account. Azure Storage offers 2 options for how your data is replicated in the primary region. Locally redundant storage, or LRS, copies your data synchronously 3 times within a single physical location in the region. LRS is the least expensive replication option, but isn't recommended for applications requiring high availability. Geo-redundant storage, or GRS, copies your data synchronously 3 times within a single physical location in the primary region using LRS. It then copies your data asynchronously to a single physical location in the secondary region. This form of replication protects you against regional outages. Read Access Geo-redundant storage, or RA GRS, replication is an extension of GRS that provides direct read-only access to the data in the secondary location. In contrast, the GRS option doesn't expose the data in the secondary location, and it's only used to recover from a failure in the primary location. RA GRS replication enables you to store a read-only copy of the data close to users that are located in a geographically distant location, helping to reduce read latency times. Zone Redundant Storage, or ZRS, replicates your Azure storage data synchronously across 3 Azure availability zones in the primary region. Each availability zone is a separate physical location with independent power, cooling, and networking. This is useful for applications requiring high availability. You should note that in order to maintain performance, premium storage accounts only support LRS replication. This is because replication is performed synchronously to maintain data integrity. Replicating data to a distant region can increase latency to the point at which any advantages of using premium storage are lost. The Access Tier option is only available for standard storage accounts. You can select between hot and cool. The hot access tier has higher storage costs than cool and archive tiers, but the lowest access costs. Example usage scenarios for the hot access tier include data that's in active use or expected to be accessed, read from and written to frequently. Data that's staged for processing and eventual migration to the cool access tier. The cool access tier has lower storage costs and higher access costs compared to hot storage. This tier is intended for data that will remain in the cool tier for at least 30 days. Example usage scenarios for the cool access tier include short-term backup and disaster recovery datasets, older media content not viewed frequently anymore but is expected to be available immediately when accessed, Large data sets that need to be stored cost effectively while more data is being gathered for future processing. For example, long-term storage of scientific data or raw telemetry data from a manufacturing facility. If you're using the Azure CLI, run the AZ storage account command to create a new storage account. You have 3 options available. First, the SKU is a combination of a performance tier and replication options. It can be one of Premium LRS, Premium ZRS, Standard GRS, Standard GZRS, Standard LRS, Standard RAGRS, Standard RAGZRS, or Standard ZRS. Next, the kind parameter should be one of blob storage, block blob storage, file storage, or storage v2. And finally, the access tier parameter can either be cool or hot. You use the new AZ storage account PowerShell commandlet to create a new storage account with the following parameters: name, resource group name, location, SKU name, kind, and access tier. The values for SKU name, kind, and access tier are the same as those in the Azure CLI command. First, let's look at how to provision data lake storage in a storage account using the Azure portal. But before we proceed, it's important to note that if you're provisioning a data lake store, you must specify the appropriate configuration settings when you create the storage account. You can configure data lake store after the storage account has been set up. In the Azure portal, on the Advanced tab of the Create Storage Account page in the Data Lake Storage Gen 2 section, select Enabled for the hierarchical namespace option. After the storage account has been created, you can add one or more data lake storage containers to the account. Each container supports a directory structure for storing data lake files. When you use the Azure CLI to provision data lake storage in a storage account, you run the AZ storage account command. And you add the Enable hierarchical namespace parameter with the value true to create a new storage account that supports data lake storage. And when you use Azure PowerShell, you run the new AZ storage account PowerShell commandlet. Here you add the Enable hierarchical namespace parameter with the value true. Blobs are stored in containers, and you create containers after you've created a storage account. In the Azure portal, you can add a container using the features on the overview page for your storage account. The Containers page enables you to create and manage containers. Each container must have a unique name within the storage account. You can also specify the access level. By default, data held in a container is only accessible by the container owner. You can set the access level to blob to enable public read access to any blobs created in the container, or container to allow read access to the entire contents of the container, including the ability to list all blobs. You can also configure role-based access control for a blob if you need a more granular level of security. Once you've provisioned a container, your applications can upload blobs into the container. In the Azure CLI, the AZ storage container create command establishes a new blob container in a storage account. The public access parameter can be blob, container, or off for private access only. In Azure PowerShell, you can use the new AZ storage container commandlet to add a container to a storage account. You must first retrieve a storage account object with the Get AZ storage account commandlet. Then you use the permission parameter. It accepts the values blob, container, or off. You provision file storage by creating one or more file shares in the storage account. In the Azure portal, select File Shares on the Overview page for the account. Using the File Shares page, create a new file share. Give the file share a name and optionally set a quota to limit the size of files on the share. The total size of all files across all file shares in a storage account can't exceed 5,120 gigabytes to 5 terabytes. After you've created the file share, applications can read and write shared files using the file share. The Azure CLI provides the AZ storage share create to create a new file share in a storage account. Then you specify the share name and account name parameters. The new AZ storage share commandlet creates a new file share in a storage account. You must retrieve the storage account details first. Then you specify the parameters: resource group, storage account name, and share name. After you've provisioned a resource, you'll often need to configure it to meet the needs of your applications and environment. For example, you might need to set up network access or open a firewall port to enable your applications to connect to the resource. Now you'll learn how to enable network access to your resources and how you can prevent accidental exposure of your resources to third parties. You'll see how to use authentication and access control to protect the data managed by your resources. The default connectivity for Azure Cosmos DB and Azure Storage is to enable access to the world at large. You can connect to these services from an on-premises network, the internet, or from within an Azure virtual network. Although this level of access sounds risky, most Microsoft Azure services mitigate this risk by requiring authentication before granting access. Authentication is described later in this lesson. You should note that an Azure virtual network is a representation of your own network in the cloud. A virtual network enables you to connect virtual machines and Azure services together in much the same way that you might use a physical network on premises. Microsoft Azure ensures that each virtual network is isolated from other virtual networks created by other users and from the internet. Microsoft Azure enables you to specify which machines, real and virtual, and services are allowed to access resources on the virtual network and which ports they can use. To restrict connectivity, you should use the networking page for a service. To limit connectivity, choose selected networks. 3 further sections will appear, labeled Virtual Network, Firewall, and Exceptions. In the Virtual Network section, you can specify which virtual networks are allowed to route traffic to the service. When you create items such as web applications and virtual machines, you can add them to a virtual network. If these applications and virtual machines require access to your resource, add the virtual network containing these items to the list of allowed networks. If you need to connect to the service from an on-premises computer, in the Firewall section, add the IP address of the computer. This setting creates a firewall rule that allows traffic from that address to reach the service. The Exceptions setting allows you to enable access to any other of your services created in your Azure subscription. For detailed information, read Configure Azure Storage Firewalls and Virtual Networks in the additional readings at the end of this lesson. Azure Private Endpoint is a network interface that connects you privately and securely to a service powered by Azure Private Link. Private Endpoint uses a private IP address from your VNet, effectively bringing the service into your VNet. The service could be an Azure service such as Azure Storage, Azure Cosmos DB, SQL, or your own private link service. For detailed information, read What is Azure Private Endpoint, which is linked to in the additional readings at the end of this lesson. The Private Endpoint Connections page for a service allows you to specify which private endpoints, if any, are permitted to access your service. You can use the settings on this page together with the Firewalls and Virtual Networks page to completely lock down users and applications from accessing public endpoints to connect to your Cosmos DB account. Many services include an access key that you can specify when you attempt to connect to the service. If you provide an incorrect key, you'll be denied access. To find the access key for an Azure Storage account, you select Access Keys under Settings on the main page for the account. Many other services allow you to view the access key in the same way from the Azure portal. If your key is compromised, you can generate a new access key. You should note that Azure services actually provide 2 keys, labeled Key 1 and Key 2. An application can use either key to connect to the service. Any user or application that knows the access key for a resource can connect to that resource. However, access keys provide a rather coarse-grained level of authentication. Additionally, if you need to regenerate an access key after accidental disclosure, for example, you may need to update all applications that connect using that key. Azure Active Directory, or Azure AD, provides superior security and ease of use over access key authorization. Microsoft recommends using Azure AD authorization when possible to minimize potential security vulnerabilities inherent in using access keys. Azure AD is a separate Azure service. You add users and other security principles, such as an application, to a security domain managed by Azure AD. Let's take a closer look at how authentication works with Microsoft Azure. When a user or application attempts to authenticate, they specify the domain to authenticate against. Azure AD will typically require the user or application to provide some credentials, often a password, to prove their identity. It's also possible to configure multi-factor authentication to reduce the possibility of a fraudulent user with a stolen password from authenticating. For example, you could specify that not only does the user have to provide a password, but must also respond to a text or phone message sent to their mobile device before authentication. If authentication is successful, Azure AD creates an authentication token for the user or application. After a security principal has been authenticated, it might then attempt to access a resource. The authentication token is passed as part of a request to the service. The token is used by the service to authorize access to the specified resource. Azure AD enables you to specify who or what can access your resources. Access control defines what a user or application can do with your resources after they've been authenticated. Access management for cloud resources is a critical function for any organization that is using the cloud. Azure Role-Based Access Control, Azure RBAC, helps you manage who has access to Azure resources and what they can do with those resources. For example, using RBAC, you could allow one user to manage virtual machines in a subscription and another user to manage virtual networks. Allow a database administrator group to manage SQL databases in a subscription. Allow a user to manage all resources in a resource group, such as virtual machines, websites, and subnets. And allow an application to access all resources in a resource group. You control access to resources using Azure RBAC to create role assignments. A role assignment consists of 3 elements: a security principal, a role definition, and a scope. A security principal is an object that represents a user, group, service, or managed identity that is requesting access to Azure resources. A role definition, often abbreviated to role, is a collection of permissions. A role definition lists the operations that can be performed, such as read, write, and delete. Roles can be given high-level names, like owner, or specific names, like virtual machine reader. Microsoft Azure includes several built-in roles that you can use, including, starting with the least set of permissions. Reader can view existing Azure resources. Contributor can create and manage all types of Azure resources but can't grant access to others. Owner has full access to all resources, including the right to delegate access to others. User Access Administrator lets you manage user access to Azure resources. You can also create your own custom roles. For detailed information, see Create or Update Azure Custom Roles using the Azure portal on the Microsoft website. A scope lists the set of resources that the access applies to. When you assign a role, you can further limit the actions allowed by defining a scope. This is helpful if, for example, you want to make someone a website contributor, but only for one resource group. You add role assignments to a resource in the Azure portal using the Access Control or IAM page. The Role Assignments tab enables you to associate a role with a security principal, defining the level of access the role has to the resource. For further information, read Add or Remove Azure Role Assignments using the Azure portal. Apart from authentication and authorization, many services provide additional protection through security. Security implements threat protection and assessment. Threat protection tracks security incidents and alerts across your service. This intelligence monitors the service and detects unusual patterns of activity that could be harmful or compromise the data managed by the service. Recommendations identifies potential security vulnerabilities and recommends actions to mitigate them. You can control the security settings from the security page for Azure Storage. The corresponding page for other non-relational services, such as Cosmos DB, is similar. Apart from the general configuration settings applicable to many services, most services also have specific features that you can set up. For example, in the sample scenario, after you've provisioned a Cosmos DB account, you may need to configure replication or database consistency settings. Now you'll look at specific configuration settings for Azure Cosmos DB and Azure Storage accounts. Azure Cosmos DB enables you to replicate the databases and containers in your account across multiple regions. When you initially provision an account, you can specify that you want to copy data to another region. You don't have control over which region is used, as the next nearest region is automatically selected. The Replicate Data Globally page enables you to configure replication in more detail. You can replicate to multiple regions and you select the regions to use. In this way, you can pick the regions that are closest to your consumers to help minimize the latency of requests made by those consumers. You can also use this page to configure automatic failover to help ensure high availability. If the database is in the primary region, the region in which you created the account, become unavailable, one of the replicated regions will take over processing and become the new primary region. By default, only the region in which you created the account supports write operations. The replicas are all read-only. However, you can enable multi-region writes. Multi-region writes can cause conflicts though, if applications running in different regions modify the same data. In this case, the most recent write will overwrite changes made earlier when data is replicated, although you can write your own code to apply a different strategy. Replication is asynchronous, so there's likely to be a lag between a change made in one region and that change becoming visible in other regions. Also note that each replica increases the cost of the Cosmos DB service. For example, if you replicate your account to 2 regions, your cost will be 3 times that of a non-replicated account. Within a single region, Cosmos DB uses a cluster of servers. This approach helps to improve scalability and availability. A copy of all data is held in each server in the cluster. Let's take a closer look on how this works and the effects it can have on consistency. When an application writes data, the change is recorded by one server and then propagated to the other servers in the cluster asynchronously. While this strategy helps to minimize latency, it can lead to inconsistencies in the data. For example, Application App 1 makes a change to a document. Application App 2 reads the same document. If App 2 retrieves the data from a different server in the cluster than that which App 1 used, there will be a small window of opportunity during which App 2 sees the old data. This issue doesn't just arise with multiple applications. Inconsistencies can occur in a single application if a write is directed towards one server in the cluster, but a subsequent read operation is performed against a different server. Cosmos DB enables you to specify how such inconsistency should be handled. It provides the following options. The eventual option is the least consistent. It's based on the situation just described. Changes won't be lost, they'll appear eventually, but they might not appear immediately. Additionally, if an application makes several changes, some of those changes might be immediately visible, but others might be delayed. Changes could appear out of order. The consistent prefix option ensures that changes will appear in order, although there may be a delay before they become visible. In this period, applications may see old data. In the session option, if an application makes a number of changes, they'll all be visible to that application and in order. Other applications may see old data, although any changes will appear in order as they did for the consistent prefix option. This form of consistency is sometimes known as read your own writes. In the bounded staleness, there's a lag between writing and then reading the updated data. You specify this staleness either as a period of time or number of previous versions the data will be inconsistent for. In the strong option, all writes are only visible to clients after the changes are confirmed as written successfully to all replicas. This option is unavailable if you need to distribute your data across multiple global regions. Eventual consistency provides the lowest latency and least consistency. Strong consistency results in the highest latency but also the greatest consistency. You should select the default consistency level that balances the performance and requirements of your applications. You can change the default consistency for a Cosmos DB account using the default consistency page in the Azure portal. Applications can override the default consistency level for individual read operations. However, they can't increase the consistency above that specified on this page. They can only decrease it. There are some general settings that you can modify to configure your storage account. On the configuration page, you can enable or disable secure communications with the service. By default, all requests and responses are encrypted by using the HTTPS protocol as they traverse the internet. You can disable encryption if required, although this isn't recommended. Switch the default access tier between cool and hot. Change the way in which the account is replicated. And finally, enable or disable integration with Azure AD for requests that access file shares. Other options, such as the account kind and performance tier, are displayed on this page for information only. You can't change them. All data held in an Azure storage account is automatically encrypted. By default, encryption is performed using keys managed and owned by Microsoft. If you prefer, you can provide your own encryption keys. To use your own key, add them to Azure Key Vault. You then provide the details of the vault and key, or the URI, or the Universal Resource Identifier of the key in the vault. All new data will be encrypted as it's written. Existing data will be encrypted using a process running in the background. This process may take a little time. You can use Shared Access Signatures, SAS, to grant limited rights to resources in an Azure storage account for a specified time period. This feature enables applications to access resources such as blobs and files without requiring that they're authenticated first. You should only use SAS for data that you intend to make public. An SAS is the token that an application can use to connect to the resource. The application appends the token to the URL of the resource. The application can then send requests to read or write data using this URL and token. You can create a token that grants temporary access to the entire service, containers in the service, or individual objects such as blobs and files. Use the Shared Access Signature page in the Azure portal to generate SAS tokens. You specify the permissions. You could provide read-only access to a blob, for example, the period for which the SAS token is valid, and the IP address range of computers allowed to use the SAS token. The SAS token is encrypted using one of the access keys. You specify which key they use, key 1 or key 2. Provisioning is the act of creating an instance of a service. Microsoft Azure takes care of allocating the resources required to run a service as part of the provisioning process. After you've provisioned a service, you can then configure it to enable your applications and users to access the service. In this lesson, you've learned how to provision non-relational data services, configure non-relational data services, explore basic connectivity issues, and explore data security components. Hello and welcome. In this module, you will explore managing non-relational data stores in Microsoft Azure. Non-relational data stores can take many forms. Microsoft Azure enables you to create non-relational databases using Azure Cosmos DB. Cosmos DB supports several NoSQL models, including document stores, graph databases, key value stores, and column family databases. Other non-relational stores available in Microsoft Azure include Azure Storage, which you can use to store blobs and files. In this module, you'll learn how to use these various storage services to store and retrieve data. Suppose you're a data engineer working at Contoso, an organization with a large manufacturing operation. The organization has to gather and store information from a range of sources, such as real-time data monitoring of the status of production line machinery, product quality control data, historical production logs, product volumes in stock, and raw materials inventory data. This information is critical to the operation of the organization. Contoso has created stores for holding this information. You've been asked to upload data to these stores and investigate how to query this data using the features provided by Azure. In this lesson, you will upload data to a Cosmos DB database and learn how to query this data, upload and download data in an Azure storage account. Azure Cosmos DB is a NoSQL database management system. It's compatible with some existing NoSQL systems, including MongoDB and Cassandra. In the Contoso scenario, you've created a Cosmos DB database for holding information about the quantity of items in stock. Now you need to understand how to populate this database and how to query it. Now you'll review how Cosmos DB stores data. Then you'll learn how to upload data to a Cosmos DB database and configure Cosmos DB to support bulk loading. Cosmos DB manages data as a set of documents. It uses JSON or JavaScript object notation to represent the document structure. In this format, the fields in a document are enclosed between braces and each field is prefixed with its name. A document is a collection of fields identified by a key. The fields in each document can vary and a field can contain child documents. As an example, you can have a pair of documents representing customer information. In both cases, each customer document includes child documents containing the name and address, but the fields in these child documents vary between customers. Documents in a Cosmos DB database are organized into containers. The documents in a container are grouped together into partitions. A partition holds a set of documents that share a common partition key. You designate one of the fields in your documents as the partition key. You should select a partition key that collects all related documents together. This approach helps to reduce the amount of I/O disk reads that queries might need to perform when retrieving a set of documents for a given entity. For example, in a document database for an e-commerce system recording the details of customers and the orders they've placed, you could partition the data by customer ID and store the customer and order details for each customer in the same partition. To find all the information and orders for a customer, you simply need to query that single partition. Cosmos DB is a foundational service in Microsoft Azure and has been used by many of Microsoft products for mission-critical applications at global scale, including Skype, Xbox, Microsoft 365, and Microsoft Azure. Cosmos DB is highly suitable for IoT and telematics, retail and marketing, gaming, and web and mobile applications. For additional information about uses for Cosmos DB, read Common Azure Cosmos DB use cases, which is linked to in the additional readings at the end of this lesson. You access the data in a Cosmos DB database through a set of commands and operations, collectively known as an API. API stands for Application Programming Interface. Here are some APIs that Cosmos DB currently supports. Cosmos DB provides its own native API called the SQL API. This API provides a SQL-like query language over documents that enables you to retrieve documents using select statements. For example, to retrieve the address for a specific customer whose details are stored in the customer container, you can select the address field in the customer container where the customer ID is equal to your desired search term. Cosmos DB also provides other APIs that enable you to access these documents using the command sets of other NoSQL database management systems. These other APIs are the Table API interface, which enables you to use the Azure Table Storage API to store and retrieve documents. The purpose of this interface is to enable you to switch from table storage to Cosmos DB without requiring that you modify your existing applications. MongoDB is another well-known document database with its own programmatic interface. Many organizations run MongoDB on-premises. You can use the MongoDB API for Cosmos DB to enable a MongoDB application to run unchanged against a Cosmos DB database. You can migrate the data in the MongoDB database to Cosmos DB running in the cloud, but continue to run your existing applications to access this data. Cassandra is a column family database management system. This is another database management system that many organizations run on-premises. The Cassandra API for Cosmos DB provides a Cassandra-like programmatic interface for Cosmos DB. Cassandra API requests are mapped to Cosmos DB document requests. As with the MongoDB API, the primary purpose of the Cassandra API is to enable you to quickly migrate Cassandra databases and applications to Cosmos DB. And finally, the Gremlin API implements a graph database interface to Cosmos DB. A graph is a collection of data objects and directed relationships. Data is still held as a set of documents in Cosmos DB, but the Gremlin API enables you to perform graph queries over data. Using the Gremlin API, you can walk through the objects and relationships in the graph to discover all manner of complex relationships, such as what is the name of the pet of Sam's landlord. The principal use of the Table, MongoDB, and Cassandra APIs is to support existing applications written using these data stores. If you're building a new application and database, you should use the SQL API or Gremlin API. Cosmos DB provides several options for uploading data to a Cosmos DB database and querying that data. You can use Data Explorer in the Azure portal to run ad hoc queries. You can also use this tool to load data, but you can only load one document at a time. The data load functionality is primarily aimed at uploading a small number of documents, up to 2 megabytes in total size, for test purposes, rather than importing large quantities of data. You can also use the Cosmos DB data migration tool to perform a bulk load or transfer of data from another data source. Additionally, you can use Azure Data Factory to import data from another source. You can write a custom application that imports data using the Cosmos DB bulk executor library. This strategy is beyond the scope of this module. Finally, you can create your own application that uses the functions available through the Cosmos DB SQL API client library to store data. This approach is also beyond the scope of this module. You can use the data migration tool to import data to Azure Cosmos DB from a variety of sources, including JSON files, MongoDB, SQL Server, CSV files, Azure Table Storage, Amazon DynamoDB, HBase, and Azure Cosmos containers. The data migration tool is available as a download from GitHub. The tool guides you through the process of migrating data into a Cosmos DB database. You're prompted for the source of the data, one of the items listed earlier, and the destination, the Cosmos DB database and container. The tool can either populate an existing container or create a new one if the specified container doesn't already exist. You should note that you can also use the data migration tool to export data from a Cosmos DB container to a JSON file, either held locally or in Azure Blob Storage. If you have a large amount of data, the data migration tool can make use of multiple concurrent threads to batch your data into chunks and load the chunks in parallel. Each thread acts as a separate client connection to the database. Bulk loading can become a write-intensive task. When you upload data to a container, if you have insufficient throughput capacity configured to support the volume of write operations occurring concurrently, some of the upload requests will fail. Cosmos DB reports a HTTP 429 error, request rate is large. Therefore, if you're planning on performing a large data import, you should increase the throughput resources available to the target Cosmos container. If you're using the data migration tool to create the container as well as populate it, the target information page enables you to specify the throughput resources to allocate. If you've already created the container, use the scale settings of the database in the Data Explorer page for your database in the Azure portal to specify the maximum throughput or set the throughput to autoscale. Once the data has been loaded, you may be able to reduce the throughput resources to lower the cost of the database. Now that you've learned how you can import and export data to and from an Azure Cosmos DB database, let's see how you can query a Cosmos DB database. Although Azure Cosmos DB is described as a NoSQL database management system, the SQL API enables you to run SQL-like queries against Cosmos DB databases. These queries use a syntax similar to that of SQL, but there are some differences. This is because the data in a Cosmos DB is structured as documents rather than tables. Now you'll learn about the dialect of SQL implemented by the SQL API. You'll see how to use the Data Explorer in the Azure portal to run queries. The Cosmos DB SQL API supports a dialect of SQL for querying documents using select statements that may be familiar if you have written select statements in a relational database using an ANSI SQL compliant database engine, which is similar to Microsoft SQL Server. The SQL API returns results in the form of JSON documents. All queries are executed in the context of a single container. To better understand the SQL API select, let's take an example where the data is stored in a container named customers. The information we have about customers includes their title, name and address, which includes street, number, city and state. Now let's start with the select clause. The clause starts with the keyword select, followed by a comma-separated list of properties to return. The keyword asterisk is used to select all the properties in the document. You can simply write select asterisk to select all properties. To limit the output to specified fields, you can use the select clause followed by a comma-separated list of properties that you want to retrieve. For example, to select the title, the first and last names, you write select title, comma, name dot first, comma, name dot last. Next, we have the from clause. This clause starts with the keyword from, followed by an identifier representing the source of the records and an alias that you can use for this identifier in other clauses. The alias is optional. In this lesson, we will omit the alias whenever it is appropriate. In a relational database query, the from clause would contain a table name. In the SQL API, all queries are limited to the scope of a container, so the identifier represents the name of the container. To select the title and names of customers in the customers container, you could write select title, comma, name from customers. Next, we have the where clause. This clause is optional. It starts with the keyword where, followed by one or more logical conditions that must be satisfied by a document returned by the query. You use the where clause to filter the results of a query. If you would like to know in which city customers in California live, you could write a query like select name, comma, address.city from customers where address.state equals California. It's important to note that a logical condition results in a true or false. For example, city equals San Francisco might evaluate to true, but price is greater than $10 might evaluate to false. Finally, the order by clause is also optional. It starts with the phrase order by followed by one or more properties used to order the output result set. If you would like to know in which city customers in California live and have customers ordered by name, you simply add the clause, order by name, to the statement we used previously. It's also important to note that a query can also contain a join clause. In a relational database management system, such as Azure SQL Database, join clauses are used to connect data from different tables. In the SQL API, you use join clauses to connect fields in a document with fields in a subdocument that is part of the same document. You can't perform joins across different documents. The SQL API includes many common mathematical and string operations, in addition to functions for working with arrays and for checking data types. The operators supported in SQL API queries include unary, arithmetic, bitwise, logical, comparison, string or concatenate, and ternary or if. The SQL API also supports the distinct operator that you use as part of the select clause to eliminate duplicates in the result data. The top operator that you can use to retrieve only the first few rows returned by a query that might otherwise generate a large result set. The between operation that you use as part of the where clause to define an inclusive range of values. The condition between A and B is equivalent to the condition field greater than or equal to A and smaller than or equal to B. And finally, the isDefined operator that you can use for detecting whether a specified field exists in a document. Let's go over a few examples to illustrate the use of these operators. First, if you want to list all customer cities and remove duplicates for customers living in states with codes between Alaska and Maryland, you can write select distinct address.city from customers where addresses.state between Alaska and Maryland. To find the 3 most common customer names, you could write select top 3 asterisk from customers order by name. Finally, to display the details of every customer for which the date of birth is recorded, you could write select asterisk from P where is defined P.date of birth. You can use aggregate functions to summarize data in select queries. You place aggregate functions in the select clause. The SQL API query language supports the following aggregate functions. Count P. This function returns a count of the number of instances of field P in the result set. To count all the items in the result set, set P to a scalar value, such as 1. Sum P. This function returns the sum of all the instances of field P in the result set. The values of P must be numeric. Average P. This function returns the mathematical mean of all the instances of field P in the result set. The values of P must be numeric. Max P. This function returns the maximum value of field P in the result set. And finally, min P. This function returns the minimum value of field P in the result set. Although the syntax of aggregate functions is similar to ANSI SQL, unlike ANSI SQL, the SQL API query language doesn't support the group by clause. You can't generate subtotals for different values of the same field in a single query. You're able to include more than one aggregate function in the select clause of your queries. For example, if you want your query to return the average, maximum, and sum of the age field of documents in a collection, you write select average age as average, max age as maximum, sum age as sum from customers. And if you want your query to return a count of all the documents in the collection, you add count1 as count before the from clause. The SQL API also supports a large number of mathematical, trigonometric, string, array, and spatial functions. For detailed information on the syntax of queries and the functions and operators supported by the Cosmos DB SQL API, visit the page Getting Started with SQL Queries in Azure Cosmos DB, which is linked to on the additional readings at the end of this lesson. You can use Data Explorer in the Azure portal to create and run queries against a Cosmos DB container. The items page for a container provides the new SQL query command in the toolbar. In the query pane, you can enter a SQL query. Select Execute Query to run it. The results are displayed as a list of JSON documents. You can save the query text if you need to repeat it in the future. The query is saved in a separate container. You can retrieve it later using the Open Query command in the toolbar. You should note that the Items page also lets you modify and delete documents. Select a document from the list displayed in the main pane. You can modify any of the fields and select Update to save the changes. Select Delete to remove the document from the collection. The New Item command enables you to manually add a new document to the collection. You can use the Upload item to create new documents from a file containing JSON data. Azure Blob Storage is a suitable repository for holding large binary objects such as images, video, and audio files. In the Contoso scenario, you've created a blob container for holding images of the products the company manufactures. Microsoft Azure currently supports 3 different types of blobs. Page blobs are used to implement virtual disk storage for Azure virtual machines. They are optimized to support random read and write operations. Append blobs are suitable for storing data that grows in chunks, such as logs or other archived data. And block blobs are best for static data and are the most appropriate type of storage for holding the image data held by Contoso. Now you'll learn how to create and manage blobs and the containers that hold them. You should note that we will now concentrate on using the Azure portal, the Azure CLI, and Azure PowerShell for managing blobs and blob storage. You can also use the AZ copy utility to upload and download files, including blobs. Later, we'll describe how to use AZ copy. In an Azure storage account, you store blobs in containers. A container provides a convenient way of grouping related blobs together, and you can organize blobs in a hierarchy of folders inside a container, similar to files in a file system on disk. You create a container in an Azure storage account. You can do this using the Azure portal or using the Azure CLI or Azure PowerShell from the command line. First, let's learn how to create an Azure storage container using the Azure portal. In the Azure portal, go to the Overview page for your Azure storage account and select Containers. On the Containers page, select Add Container and provide a name for the new container. You can also specify the public access level. For a container that will be used to hold blobs, the most appropriate access level is blob. This setting supports anonymous read-only access for blobs. However, unauthenticated clients can't list the blobs in the container. This means they can only download a blob if they know its name and location within the container. If you prefer to use the Azure CLI, the AZ Storage Container Create command creates a new container. This command takes a number of optional parameters, and you can find the full details on the AZ Storage Container Create page on the Microsoft website. You can create a container named Images for storing blobs. The container is created in a storage account named Azure Data. The container provides anonymous blob access. To accomplish that, you use the AZ Storage Container Create command with the parameters name, account name, resource group, and public access blob. You can use the new AZ Storage Container PowerShell commandlet to create a new storage container. The details are available on the new AZ Storage Container page on the Microsoft website. To create a new storage container, you must first obtain a reference to the storage account by using the Get AZ Storage Account command with the parameters resource group name and name for the storage account. Then use the commandlet new AZ Storage Container with the parameters name for the container and permission blob. After you've created a container, you can upload blobs. Depending on how you want to organize your blobs, you can also create folders in the container. If you're using the Azure portal, go to the page for your storage account and select Containers under Blob Service. On the Containers page, select the container you want to use. You should note that if you created the storage account with support for hierarchical namespaces for data lake storage, the Blob Service section doesn't appear in the Azure portal. Instead, select Containers under Data Lake Storage. On the page for the container, in the toolbar, select Upload. In the Upload Blob dialog box, browse to the file container the data to upload. The Advanced drop-down section provides options you can modify the default options. For example, you can specify the name of a folder in the container. The folder will be created if it doesn't exist, the type of blob and the access tier. The blob that is created is named after the file you uploaded. Note that you can select multiple files. They will each be uploaded into separate blobs. Use the AZ Storage Blob Upload command to upload a file to a blob in a container. The details describing the parameters for this command are available on the AZ Storage Blob Upload page on the Microsoft website. You can upload a local file named racergreenlarge.gif in the data folder to a blob called racergreen in the bikes folder in the images container in the Contoso data storage account. To do that, you use the AZ Storage Blob Upload command with the parameters container name, account name, file, and name to specify the blob and folder names. If you need to upload several files, use the AZ Storage Blob Upload Batch command. This command takes the name of a local folder rather than a file name and uploads the files in that folder to separate blobs. To upload all GIF files in the data folder to the bikes folder in the images container, you can use the AZ Storage Blob Upload Batch command with the following parameters: account name, source, pattern, and destination. Azure PowerShell provides the Set AZ Storage Blob Content commandlet to upload blob data to Azure Storage. To perform the upload, use the Set AZ Storage Account command with the parameters resource group name and name for the account, plus the commandlet Set AZ Storage Blob Content with the parameters container, file, and blob. Azure PowerShell doesn't currently include a batch blob upload command. If you need to upload multiple files, you can write your own PowerShell script. Use the getChildItem commandlet to iterate through the files and upload each one individually. If you've been granted the appropriate access rights, you can view the blobs in a container. If you're using the Azure portal, go to the page for your storage account and select Containers under Blob Service. On the Containers page, select the container holding your blobs. If the container has a folder structure, move to the folder containing the blobs you want to see. The blobs in that folder should be displayed. In the Azure CLI, you can use the AZ Storage Blob List command to view the blobs in a container. This command iterates recursively through any folders in the container. For example, you can list the blobs previously uploaded to the images container by using the AZ Storage Blob List command with the parameters account name and container name. From Azure PowerShell, you can run the Get AZ Storage Blob commandlet. You can do that by using the Get AZ Storage Account command with the parameters resource group name, and name for the account name. Plus the commandlet get AZ storage blob with the parameter container. You can retrieve a blob from Azure Storage and save it in a local file on your computer. If you're using the Azure portal, go to the page for your storage account and select Containers under Blob Service. On the Containers page, select the container holding your blobs. If the container has a folder structure, move to the folder containing the blobs you want to download. Select the blob to view its details. On the Details page, select Download. The Azure CLI provides the AZ Storage Blob Download and AZ Storage Blob Download batch commands. These commands are analogous to those available for uploading blobs. You can retrieve the racer green blob from the bikes folder in the images container by using the AZ Storage Blob Download command with the parameters container name, account name, file, and name for the blob and folder names. In Azure PowerShell, use the Get AZ Storage Blob Content commandlet. You can use the Get AZ Storage Account command with the parameters resource group name and name for the account. Plus the commandlet Get AZ Storage Blob Content with the parameters container, blob, and destination. Deleting a blob can reclaim the resources used in the storage container. However, if you've enabled the soft delete option for the storage account, the blob is hidden rather than removed, and you can restore it later. You can enable or disable soft delete in the Azure portal and specify the time for which the blob is retained. Select the Data Protection page under Blob Service. If the blob isn't restored by the end of the retention period, it will be removed from storage. But pay attention. If you created the storage account with support for hierarchical namespaces for data lake storage, the soft delete option isn't available. All blob delete operations will be final. If you're using the Azure portal, go to the page for your storage account and select Containers under Blob Service. On the Containers page, select the container holding your blobs. If the container has a folder structure, move to the folder containing the blobs you want to download. Select the blob to view its details. On the Details page, select Delete. You'll be prompted to confirm the operation. If you've enabled soft delete for the storage account, the blobs page listing the blobs in a container includes the option Show Deleted Blobs. If you select this option, you can view and undelete a deleted blob. You can delete a single blob with the AZ Storage Blob Delete command or a set of blobs with the AZ Storage Blob Delete Batch command. To remove the racer green blob from the bikes folder in the images container, you use the AZ Storage Blob Delete command with the parameters account name, container name, and name for the blob and folder names. Use the Remove AZ Storage Blob commandlet to delete a storage blob from Azure PowerShell. By default, deletion runs without prompts. You can add the confirm flag to prompt the user to confirm that they really want to delete the blob. To accomplish that, you can use the Get AZ Storage Account command with the parameters resource group name and name for the account. Plus the commandlet Remove AZ Storage Blob with the parameters container, blob, and the confirm flag. Removing a container automatically deletes all blobs held in that container. If you aren't careful, you can lose a great deal of data. In the Azure portal, select Containers under Blob Service, select the container to delete, and then select Delete in the toolbar. In the Azure CLI, use the AZ Storage Container Delete command. You can delete the images container referenced in previous examples by using the AZ Storage Container Delete command with the parameters account name and name for the container. The Remove AZ Storage Container commandlet deletes a storage container. The confirm flag prompts the user to confirm the delete operation. You can do that by using the Get AZ Storage Account command with the parameters resource group name and name for the account. Plus the commandlet Remove AZ Storage Container with the parameters name for the container and the confirm flag. Now that you've learned how to manage Azure Blob Storage, let's now see how to manage Azure File Storage. You can use Azure File Storage to store shared files. Users can connect to a shared folder, also known as a file share, and read and write files if they have the appropriate privileges, in much the same way as they would use a folder on a local machine. In the Contoso scenario, Azure File Storage is used to hold reports and product documentation that users across the company need to be able to read. Now you'll learn how to create and manage file shares and upload and download files in Azure File Storage. It's important to note that files in a file share tend to be handled in a different manner from blobs. In many cases, users simply read and write files as though they were local objects. For this reason, although the Azure CLI and Azure PowerShell both provide programmatic access to Azure File Storage, this unit concentrates on the tools available in the Azure portal and the AZ copy command. Microsoft provides two graphical tools you can use to create and manage file shares in Azure Storage, the Azure Portal and Azure Storage Explorer. Let's look at how to do that in the Azure Portal first. Select File Shares in the main pane of the Overview page for an Azure Storage account. This is also available in the File Service section of the command bar. On the File Share page, select Add File Share. Give the file share a name and optionally specify a quota. Azure allows you to store up to 5 PB of files across all file shares in a storage account. A quota enables you to limit the amount of space an individual file share consumes to prevent it from starving other file shares of file storage. If you have only one file share, you can leave the quota empty. After you've created a share, you can use the Azure Portal to add directions to the share, upload files to the share, and delete the share. The connect command generates a PowerShell script that you can run to attach to the share from your local computer. You can then use the share as though it was a local disk drive. Azure Storage Explorer is a utility that enables you to manage Azure storage accounts from your desktop computer. You can download it from the Azure Storage Explorer page on the Microsoft website. You can use Storage Explorer to create blob containers and file shares, as well as upload and download files. A version of this utility is also available in the Azure Portal on the Overview page for an Azure Storage account. To create a new file share, right-click File Shares and then select Create File Share. In the Azure Portal, Storage Explorer displays the same dialog box that you saw earlier. In the desktop version, you simply enter a name for the new file share. You don't get the option to set a quota at this point. As with the Azure Portal, once you've created a new share, you can use Storage Explorer to create folders and upload and download files. You can upload and download individual files to and from Azure File Storage manually. You can do that by using Storage Explorer, the Azure Portal, or by connecting the file share to your desktop computer and dragging and dropping files in File Explorer. However, if you need to transfer a significant number of files in and out of Azure File Storage, you should use the AZCopy utility. AZCopy is a command line utility optimized for transferring large files and blobs between your local computer and Azure File Storage. It can detect transfer failures and restart a failed transfer at the point an error occurred. You don't have to repeat the entire operation. Before you can use AZCopy, you need to generate a Shared Access Signatures (SAS) token. A Shared Access Signatures, or SAS token, provides controlled, time-limited, anonymous access to services and resources in a storage account. Users don't have to provide any additional credentials. SAS tokens are useful in situations where you don't know in advance which users will require access to your resources. You should note that the AZCopy command also supports authentication using Azure Active Directory, but this approach requires adding all of your users to the Azure Active Directory first. You can create an SAS token for connecting to Azure File Storage using the Azure Portal. On the page for your storage account, under Settings, select Shared Access Signature. On the Shared Access Signature page, under Allowed Services, select File. Under Allowed Resource Types, select Container and Object. Finally, under Permissions, select the privileges that you want to grant to users. Then, set the start and end time for the SAS token and specify the IP address range of the computers your users will be using. Select Generate SAS and Connection String to create the SAS token, and then copy the value in the SAS token field somewhere safe. To transfer a single file into file storage using AZCopy, use the AZCopy command followed by the copy keyword. Run this command from the command line. Make sure to use the name of your storage account according to the AZCopy command syntax. Also, use the name of the file share in your account and use the SAS token you created using the Azure Portal. You must include the quotes according to the AZCopy command syntax. Don't forget to include the copy keyword after the AZCopy command. AZCopy supports other operations, such as deleting files and blobs, listing files and blobs, and creating new file shares. Each of these operations has its own keyword. You can transfer the entire contents of a local folder to Azure File Storage using a similar command. You replace the file name in the command syntax with the name of the folder. If the folder contains subfolders that you want to copy, add the recursive flag. As the process runs, AZCopy displays a progress report. When the transfer is complete, you'll see a summary of the work performed. The AZCopy command has other options as well. For more information, see the page Upload Files on the Microsoft website. You can also use the AZCopy command to transfer files and folders from Azure File Storage to your local computer. The command is similar to that for uploading files, except that you switch the order of the arguments. Specify the files and folders in the file share first and the local files and folders second. For example, to download the files from a folder named My Folder in a file share named My Share to a local folder called Local Folder, you specify the name of the storage account, the name of the file share, and the local folder. For full details on downloading files using AZ Copy, see Download Files on the support page Transfer Data with AZ Copy and File Storage. In this lesson, you've seen how to use Azure Cosmos DB and Azure Storage accounts to store and retrieve non-relational data. You've learned how to upload data to a Cosmos DB database and query this data, and upload and download data in an Azure Storage account. The sandbox automatically cleans up your resources when you're finished with this module. When you're working in your own subscription, it's a good idea at the end of a project to identify whether you still need the resources you created. Resources left running can cost you money. You can delete resources individually or delete the resource group to delete the entire set of resources.
Hello and welcome. In this course, you will explore modern data warehouse analytics in Microsoft Azure. To begin with, you will explore the components of a modern data warehouse. You will gain an insight into the role of services such as Azure Databricks, Azure Synapse Analytics, and Azure HD Insight. You will also learn how to use Azure Synapse Analytics to load and process data. To achieve this, you will learn about data ingestion and the different options available when you are building a data warehouse with Microsoft Azure. You will learn how to use Azure Data Factory to ingest data into a data warehouse. And you will also explore Azure services for performing data analytics. Finally, you will learn what Power BI is, including its building blocks and how they work together. So, to summarise, you will examine the components of a modern data warehouse, explore data ingestion in Azure, explore data storage and processing in Azure, and get started with Power BI. Hello. In this lesson, you will learn about the components of a modern data warehouse. Most organisations have multiple data stores, often with different structures and varying formats. They often have live incoming streams of data, such as sensor data, that can be expensive to analyse. There's often a plethora of useful information available outside of organisations. This information could be combined with local data to add insights and enrich understanding. By combining all local data with useful external information, it's often possible to gain insights into the data that weren't previously possible. The process of combining all the local data sources is known as data warehousing. The process of analysing streaming data and data from the internet is known as big data analytics. Azure Synapse Analytics combines data warehousing with big data analytics. Suppose you're a data engineer working at Contoso, an organisation with a large manufacturing operation. The organisation has to gather and store information from a range of sources, such as real-time data monitoring the status of production line machinery, product quality control data, historical production logs, product volumes in stock, and raw materials inventory data. This information is critical to the operation of the organisation. You've been asked to determine how best to store this information so that it can be analysed quickly and queried easily. In this lesson, you will explore data warehousing concepts, explore Azure Data Services for modern data warehousing, explore modern data warehousing architecture and workload, and explore Azure Data Services in the Azure portal. A data warehouse gathers data from many different sources within an organisation. This data is then used as the source for analysis, reporting, and online analytical processing, or OLAP. The focus of a data warehouse is to provide answers to complex queries, unlike a traditional relational database, which is focused on transactional performance. Data warehouses have to handle big data. Big data is the term used for large quantities of data collected in escalating volumes at higher velocities and in a greater variety of formats than ever before. This data can be historical, meaning stored, or real-time, meaning streamed from the source. Businesses typically depend on their big data to help them make critical business decisions. A modern data warehouse might contain a mixture of relational and non-relational data, including files, social media streams, and Internet of Things, or IoT, sensor data. Azure provides a collection of services you can use to build a data warehouse solution, including Azure Data Factory, Azure Data Lake Storage, Azure Databricks, Azure Synapse Analytics, and Azure Analysis Services. You can use tools such as Power BI to analyze and visualize the data, generating reports, charts, and dashboards. We will describe each of these services in a little more detail later in this lesson. Let's take a look at how batch and stream processing are combined now. A typical large-scale business requires a combination of up-to-the-second data and historical information. The up-to-the-second data might be used to help monitor real-time critical manufacturing processes where an instant decision is required. Other examples include streams of stock market data, where the current prices are required to make informed split-second buy or sell decisions. Historical data is equally important to give a business a more stabilised view of trends in performance. A manufacturing organisation will require information such as the volumes of sales by products across a month, a quarter, or a year to determine whether to continue producing various items or whether to increase or decrease production according to seasonal fluctuations. This historical data can be generated by batch processes at regular intervals based on the live sales data that might be captured continually. Any modern data warehouse solution must be able to provide access to the streams of raw data and the cooked business information derived from this data. As a data engineer working at an organisation with a large manufacturing operation, you want to understand more about the components that form a modern data warehouse. This information will help you determine which elements most closely meet your organisation's requirements. In this part, you'll learn more about the data services that Azure provides. These services enable you to combine data from multiple sources, reformat it into analytical models, and save these models for subsequent querying, reporting, and visualization. Let's start with Azure Data Factory. Azure Data Factory is described as a data integration service. The purpose of Azure Data Factory is to retrieve data from one or more data sources and convert it into a format that you process. The data sources might present data in different ways and contain noise that you need to filter out. Azure Data Factory enables you to extract the interesting data and discard the rest. The interesting data might not be in a suitable format for processing by the other services in your warehouse solution, so you can transform it. For example, your data might contain dates and times formatted in different ways in different data sources. You can use Azure Data Factory to transform these items into a single uniform structure. Azure Data Factory can then write the ingested data to a data store for subsequent processing. You define the work performed by Azure Data Factory as a pipeline of operations. A pipeline can run continuously as data is received from the various data sources. You can create pipelines using the graphical user interface provided by Microsoft or by writing your own code. The pipeline editor can be accessed in Azure Data Factory from the Azure portal. Let's take a look at Azure Data Lake Storage now. A data lake is a repository for large quantities of raw data. Because the data is raw and unprocessed, it's very fast to load and update, but the data hasn't been put into a structure suitable for efficient analysis. It's important to note that a data warehouse also stores large quantities of data, but the data in a warehouse has been processed to convert it into a format for efficient analysis. A data lake holds raw data, but a data warehouse holds structured information. You can think of a data lake as a staging point for your ingested data before it's massaged and converted into a format suitable for performing analytics. Azure Data Lake Storage combines the hierarchical directory structure and file system semantics of a traditional file system with security and scalability provided by Azure. Azure Data Lake Storage is essentially an extension of Azure Blob Storage, organized as a near-infinite file system. It has the following characteristics. Data Lake Storage organizes your files into directories and subdirectories for improved file organization. Blob Storage can only mimic a directory structure. Data Lake Storage supports the Portable Operating System Interface, or POSIX file and directory permissions, to enable granular role-based access control, or RBAC, on your data. Azure Data Lake Storage is compatible with the Hadoop Distributed File System, or HDFS. Hadoop is a highly flexible and programmable analysis service used by many organizations to examine large quantities of data. All Apache Hadoop environments can access data in Azure Data Lake Storage Gen 2. In an Azure Data Services data warehouse solution, data is typically loaded into Azure Data Lake Storage before being processed into a structure that enables efficient analysis in Azure Synapse Analytics. You can use a service such as Azure Data Factory to ingest and load the data from a variety of sources into Azure Data Lake Storage. Okay, let's take a look at Azure Databricks now. Azure Databricks is an Apache Spark environment running on Azure to provide big data processing, streaming, and machine learning. Apache Spark is a highly efficient data processing engine that can consume and process large amounts of data very quickly. There are a significant number of Spark libraries you can use to perform tasks such as SQL processing, aggregations, and to build and train machine learning models using your data. Azure Databricks provides a graphical user interface where you can define and test your processing step by step before submitting it as a set of batch tasks. You can create Databricks scripts and query data using languages such as R, Python, and Scala. You write your Spark code using notebooks. A notebook contains cells, each of which contains a separate block of code. When you run a notebook, the code in each cell is passed to Spark in turn for execution. For example, you could have a cell in a workbook that runs a query and then generates a graph. Azure Databricks also supports structured stream processing. In this model, Databricks performs your computations incrementally and continuously updates the result as streaming data arrives. In this part, you will explore Azure Data Analytical components for modern data warehousing. Let's start with Azure Synapse Analytics. Azure Synapse Analytics is an analytics engine. It's designed to process large amounts of data very quickly. Using Synapse Analytics, you can ingest data from external sources, such as flat files, Azure Data Lake, or other database management systems, and then transform and aggregate this data into a format suitable for analytics processing. You can perform complex queries over this data and generate reports, graphs, and charts. Reading and transforming data from an external source can consume considerable resources. Azure Synapse Analytics enables you to store the data you've read in and processed locally within the service. This is described later. This approach enables you to repeatedly query the same data without the overhead of fetching and converting it each time. You can also use this data as input to further analytical processing using Azure Analysis Services. Azure Synapse Analytics leverages a massively parallel processing, or MPP, architecture. This architecture includes a control node and a pool of compute nodes. The control node is the brain of the architecture. It's the front end that interacts with all applications. The MPP engine runs on the control node to optimize and coordinate parallel queries. When you submit a processing request, the control node transforms it into smaller requests that run against distinct subsets of the data in parallel. The compute nodes provide the computational power. The data to be processed is distributed evenly across the nodes. Users and applications send processing requests to the control node. The control node sends the queries to compute nodes, which run the queries over the portion of the data that they each hold. When each node has finished its processing, the results are sent back to the control node, where they're combined into an overall result. Azure Synapse Analytics supports two computational models, SQL pools and Spark pools. In a SQL pool, each compute node uses an Azure SQL database and Azure Storage to handle a portion of the data. You submit queries in the form of transact SQL statements, and Azure Synapse Analytics runs them. However, unlike an ordinary SQL Server database engine, Azure Synapse Analytics can receive data from a wide variety of sources. To do this, Azure Synapse Analytics uses a technology named Polybase. Polybase enables you to retrieve data from relational and non-relational sources, such as Azure Blob Storage, Azure Data Lake Storage, and delimited text files. You can save the data read in as SQL tables within the Synapse Analytics service. Note, you can only scale a SQL pool when it's not running a transactional SQL query. You specify the number of nodes when you create a SQL pool. You can scale the SQL pool manually to add or remove compute nodes as necessary. It's important to note that you can only scale a SQL pool when it's not running a transact SQL query. In a Spark pool, the nodes are replaced with a Spark cluster. You run Spark jobs comprising code written in notebooks in the same way as Azure Databricks. You can write the code for Notebook in C#, Python, Scala or Spark SQL, which is a different dialect of SQL from Transact SQL. As with a SQL pool, the Spark cluster splits the work out into a series of parallel tasks that can be performed concurrently. You can save data generated by your notebooks in Azure Storage or Data Lake Storage. Now for an important note on in-memory processing. Spark is optimized for in-memory processing. A Spark job can load and cache data into memory and query it repeatedly. In-memory computing is much faster than disk-based applications, but requires additional memory resources. When you create the Spark cluster, you specify the number of nodes required. Spark pools can have auto-scaling enabled so that pools scale by adding or removing nodes as needed. And auto-scaling can occur while processing is active. It's also important to note that Azure Synapse Analytics can consume a lot of resources. If you aren't planning on performing any processing for a while, you can pause the service. This action releases the resources in the pool to other users and reduces your costs. Let's look at Azure Analysis Services now. This enables you to build tabular models to support online analytical processing, or OLAP queries. You can combine data from multiple sources, including Azure SQL Database, Azure Synapse Analytics, Azure Data Lake Store, Azure Cosmos DB, and many others. You use these data sources to build models that incorporate your business knowledge. A model is essentially a set of queries and expressions that retrieve data from the various data sources and generate results. The results can be cached in memory for later use, or they can be calculated dynamically, directly from the underlying data sources. Analysis Services includes a graphical designer to help you connect data sources together and define queries that combine, filter, and aggregate data. You can explore this data from within Analysis Services, or you can use a tool such as Microsoft Power BI to visualize the data presented by these models. Azure Analysis Services has significant functional overlap with Azure Synapse Analytics, but it's more suited for processing on a smaller scale. To give this some context, you generally use Azure Synapse Analytics for the following: very high volumes of data, multi-terabyte to petabyte size datasets, very complex queries and aggregations, data mining and data exploration, complex ETL operations. ETL stands for extract, transform and load, and refers to the way in which you can retrieve raw data from multiple sources, convert this data into a standard format and store it. And low to mid concurrency, 128 users or fewer. On the other hand, use Azure Analysis Services for smaller volumes of data, such as a few terabytes, multiple sources that can be correlated, high read concurrency, thousands of users, detailed analysis and drilling into data using functions in Power BI, and rapid dashboard development from tabular data. Many scenarios can benefit from using Synapse Analytics and Analysis Services together. If you have large amounts of ingested data that require pre-processing, you can use Synapse Analytics to read this data and manipulate it into a model that contains business information rather than a large amount of raw data. The scalability of Synapse Analytics gives it the ability to process and reduce many terabytes of data down into a smaller, succinct dataset that summarizes and aggregates much of this data. You can then use Analysis Services to perform detailed interrogation of this information and visualize the results of these inquiries with Power BI. Let's now look at Azure HD Insight. Azure HD Insight is a big data processing service that provides the platform for technologies such as Spark in an Azure environment. HD Insight implements a clustered model that distributes processing across a set of computers. This model is similar to that used by Synapse Analytics, except that the nodes are running the Spark processing engine rather than Azure SQL database. You can use Azure HD Insight in conjunction with or instead of Azure Synapse Analytics. As well as Spark, HD Insight supports streaming technologies such as Apache Kafka and the Apache Hadoop processing model. This is an example scenario of where you might use the components of HD Insight in a data warehousing solution. Apache Hadoop, which is an open source framework, breaks large data processing problems down into smaller chunks and distributes them across a cluster of servers. This is similar to the way in which Synapse Analytics operates. Then Hive, which is a SQL-like query facility, can be used with a HD Insight cluster to examine data held in a variety of formats. You can use it to create, load and query external tables in a manner similar to Polybase for Azure Synapse Analytics. This lesson has described how a data warehouse solution works and given you an overview of the services you can use to construct a modern data warehouse in Azure. In this lesson, you've seen how to explore data warehousing concepts, explore Azure Data Services for modern data warehousing, explore modern data warehousing architecture and workload, and explore Azure Data Services in the Azure portal. Hello. In this lesson, you will learn about data ingestion in Microsoft Azure. Data ingestion is the process used to load data from one or more sources into a data store. Once ingested, the data becomes available for use. Data can be ingested using batch processing or streaming, depending on the nature of the data source. Organizations often have numerous disparate data sources. To deliver a full cloud solution, it's important to have a flexible approach to data ingestion into an Azure data store. Microsoft Azure offers many ways to ingest data. In this lesson, you will explore some of these tools and techniques that you can use to ingest data with Microsoft Azure. When you have completed this lesson, you will be able to describe data ingestion in Azure, describe components of Azure Data Factory, and describe how to use Azure Data Factory to load data into a data warehouse. Data ingestion is the first part of any data warehousing solution. It is arguably the most important part. If you lose any data at this point, then any resulting information can be inaccurate, failing to represent the facts on which you might base your business decisions. In this part, you will examine some of the more popular tools used with Microsoft Azure, such as Azure Data Factory, Polybase, SQL Server Integration Services, and Azure Databricks. Let's begin with the process of data ingestion using Azure Data Factory. Azure Data Factory is a data ingestion and transformation service that allows you to load raw data from many different sources, both on-premises and in the cloud. As it ingests the data, Data Factory can clean, transform and restructure the data before loading it into a repository such as a data warehouse. Once the data is in the data warehouse, you can analyze it. Data Factory contains a series of interconnected systems that provide a complete end-to-end platform for data engineers. You can load static data, but you can also ingest streaming data. Ingesting data from a stream offers a real-time solution for data that arrives quickly or that changes rapidly. Using streaming, you can use Azure Data Factory to continually update the information in a data warehouse with the latest data. Data Factory provides an orchestration engine. Orchestration is the process of directing and controlling other services and connecting them together to allow data to flow between them. Data Factory uses orchestration to combine and automate sequences of tasks that use different services to perform complex operations. Azure Data Factory uses a number of different resources, such as linked services, datasets, and pipelines. The following sections describe how Data Factory uses these resources. Data Factory moves data from a data source to a destination. A linked service provides the information needed for Data Factory to connect to a source or destination. For example, you can use an Azure Blob Storage linked service to connect a storage account to Data Factory, or the Azure SQL Database linked service to connect to a SQL database. The information a linked service contains varies according to the resource. For example, to create a linked service for Azure Blob Storage, you provide information such as the name of the Azure subscription that owns the storage account, the name of the storage account, and the information necessary to authenticate against the storage account. Or to create a linked service to a different resource, such as Azure SQL Database, you specify the database server name, the database name, and the appropriate credentials. Azure Data Factory provides a graphical user interface for creating linked services. Okay, let's look at data sets now. A data set in Azure Data Factory represents the data that you want to ingest or store. If your data has a structure, a dataset specifies how the data is structured. Not all datasets are structured. Blobs held in Azure Blob Storage are an example of unstructured data. A dataset connects to an input or an output using a linked service. For example, if you're reading and processing data from Azure Blob Storage, you create an input dataset that uses a Blob Storage linked service to specify the details of the storage account. The dataset specifies which blob to ingest and the format of the information in the blob. This can be binary data, JSON, delimited text, and so on. Let's look at another example that uses Azure Data Factory to store data in a table in a SQL database. You define an output dataset that uses a SQL database linked service to connect to the database and specify which table to use in that database. Let's switch to pipelines now. A pipeline is a logical grouping of activities that together perform a task. The activities in a pipeline define actions to perform on your data. For example, you can use a copy activity to transform data from a source dataset to a destination dataset. You can include activities that transform the data as it is transferred, or you can combine data from multiple sources. Other activities enable you to incorporate processing elements from other services. For example, you can use an Azure Function activity to run an Azure function to modify and filter data, or an Azure Databricks notebook activity to run a notebook that performs more advanced processing. Pipelines don't have to be linear. You can include logic activities that repeatedly perform a series of tasks while some condition is true using a for each activity. You can also follow different processing paths depending on the outcome of previous processing using an if condition activity. Sometimes when ingesting data, the data you're bringing in can have different column names and data types to those required by the output. In these cases, you can use mapping to transform your data from the input format to the output format. For example, you can use the mapping canvas for the copy data activity. It illustrates how the columns from the input data can be mapped to the data format required by the output. You can run a pipeline manually, or you can arrange for it to be run later using a trigger. A trigger enables you to schedule a pipeline to occur according to a planned schedule, for example, every Saturday evening or at repeated intervals such as every few hours or minutes. A trigger can also be run when a specific event occurs, such as the arrival of a file in Azure Data Lake Storage or the deletion of a blob in Azure Blob Storage. Okay, let's switch to how data is ingested using Polybase. Polybase is a feature of SQL Server and Azure Synapse Analytics that enables you to run Transact SQL queries that read data from external data sources. Polybase makes these external data sources appear like tables in a SQL database. Using Polybase, you can read data managed by Hadoop, Spark, and Azure Blob Storage, as well as other database management systems such as Cosmos DB, Oracle, Teradata, and MongoDB. Polybase enables you to transfer data from an external data source into a table, as well as copy data from an external data source in Azure Synapse Analytics or SQL Server. You can also run queries that join tables in a SQL database with external data. This enables you to perform analytics that span multiple data stores. It's important to note that Azure SQL Database does not support Polybase. Azure Data Factory provides Polybase support for loading data. For instance, Data Factory can directly invoke Polybase on your behalf if your data is in a Polybase-compatible data store. In the next part, we will describe data ingestion using Polybase, SQL Server integration services, and Azure Databricks. In this part, we will continue to describe common practices for data loading. SQL Server Integration Services, SSIS, is a platform for building enterprise-level data integration and data transformation solutions. You can use SSIS to solve complex business problems by copying or downloading files, loading data warehouses, cleaning and mining data, and managing SQL database objects and data. SSIS is part of Microsoft SQL Server. SSIS can extract and transform data from a wide variety of sources, such as XML data files, flat files, and relational data sources, and then load the data into one or more destinations. SSIS includes a rich set of built-in tasks and transformations. A set of graphical tools is available for building packages. It also includes the Integration Services Catalog database where you store, run and manage packages. A package is an organized collection of connections, control flow elements, data flow elements, event handlers, variables, parameters and configurations. A package can be assembled using either the graphical design tools that SQL Server Integration Services provides or built programmatically. You then save the completed package to SQL Server, the Integration Services Package Store, or the file system. You can use the graphical SSIS tools to create solutions without writing a single line of code. You can also program the extensive Integration Services object model to create packages programmatically and code custom tasks and other package objects. SSIS is an on-premises utility. However, Azure Data Factory allows you to run your existing SSIS packages as part of a pipeline in the cloud. This allows you to get started quickly without having to rewrite your existing transformation logic. The SSIS feature pack for Azure is an extension that provides components that connect to Azure services, transfer data between Azure and on-premises data sources, and process data stored in Azure. The components in the feature pack support transfer to or from Azure Storage, Azure Data Lake, and Azure HD Insight. Using these components, you can perform large-scale processing of ingested data. Okay, let's look at ingesting data using Azure Databricks. Azure Databricks is an analytics platform optimized for the Microsoft Azure Cloud Services platform. Databricks is based on Spark, which is a parallel processing engine that supports large-scale analytics and is integrated with Microsoft Azure to streamline workflows. It provides an interactive workspace that enables collaboration between data scientists, data engineers, and business analysts. Databricks can process data held in many different types of storage, including Azure Blob Storage, Azure Data Lake Store, Hadoop Storage, flat files, SQL databases, data warehouses, and Azure services such as Cosmos DB. Databricks can also process streaming data. For example, you could capture data being streamed from sensors and other devices. You write and run Spark code using notebooks. A notebook is like a program that contains a series of steps called cells. A notebook can contain cells that read data from one or more data sources, process the data, and write the results out to a data store. The scalability of Azure Databricks makes it an ideal platform for performing complex data ingestion and analytics tasks. Azure Data Factory can incorporate Azure Databricks notebooks into a pipeline. A pipeline can pass parameters to a notebook. These parameters can specify which data to read and analyze. The notebook can save the results, which the Azure Data Factory pipeline can use in subsequent activities. Hello. In this lesson, you will learn about data storage and processing in Microsoft Azure. Data lives in many locations throughout an organization. When you design your cloud data solution, you'll want to ingest your raw data into a data store for analysis. A common approach that you can use with Azure Synapse Analytics is to extract the data from where it's currently stored, load this data into an analytical data store, and then transform the data, shaping it for analysis. This approach is known as ELT, for Extract, Load and Transform. Azure Synapse Analytics is particularly suitable for this approach. Using Apache Spark and automated pipelines, Synapse Analytics can run parallel processing tasks across massive datasets and perform big data analytics. The term big data refers to data that is too large or complex for traditional database systems. Systems that process big data have to perform rapid data ingestion and processing. They must have capacity to store the results and sufficient compute power to perform analytics over these results. Another option is to analyze operational data in its original location. This strategy is known as Hybrid Transactional Analytical Processing, or HTAP. You can perform this style of analysis over data held in repositories, such as Azure Cosmos DB, using Azure Synapse Link. In this lesson, you will describe data processing options for performing analytics in Azure and explore Azure Synapse Analytics. Organizations generate data throughout their business. For analysis purposes, this data can be left in its raw ingested format, or the data can be processed and saved to a specially designed data store or data warehouse. Microsoft Azure enables businesses to implement either of these scenarios. The most common options for processing data in Azure include Azure Databricks, Azure Data Factory, Azure Synapse Analytics, and Azure Data Lake. In this lesson, you'll explore these options in more detail. Let's begin with Azure Synapse Analytics. Azure Synapse Analytics is a generalized analytics service. You can use it to read data from many sources, process this data, generate various analyses and models, and save the result. You can select between two technologies to process data: Transact SQL, which is sometimes referred to as T-SQL, and Apache Spark. Transact SQL is the same dialect of SQL used by Azure SQL Database, with some extensions for reading data from external sources, such as databases, files, and Azure Data Lake storage. You can use these extensions to load data quickly, generate aggregations and other analytics, create tables and views, and store information using these tables and views. You can use the results for later reporting and processing. Spark is the same open source technology used to power Azure Databricks. You write your analytical code using notebooks in a programming language such as C#, Scala, Python, or SQL. The Spark libraries provided with Azure Synapse Analytics enable you to read data from external sources and also write out data in a variety of different formats if you need to save your results for further analysis. Azure Synapse Analytics uses a clustered architecture. Each cluster has a control node that is used as the entry point to the system. When you run Transact SQL statements or start Spark jobs from a notebook, the request is sent to the control node. The control node runs a parallel processing engine that splits the operation into a set of tasks that can be run concurrently. Each task performs part of the workload over a subset of the source data, and each task is sent to a compute node to actually do the processing. Finally, the control node gathers the results from the compute nodes and combines them into an overall result. We will discuss the components of Azure Synapse Analytics in more detail later in this lesson. For further information, read What is Azure Synapse Analytics on the Microsoft website. There is a link to this resource from the additional readings at the end of this lesson. Let's look at Azure Databricks now. Azure Databricks is an analytics platform optimized for the Microsoft Azure Cloud Services platform and was designed with the founders of Apache Spark. Databricks is integrated with Azure to provide one-click setup, streamlined workflows, and an interactive workspace. This enables collaboration between data scientists, data engineers, and business analysts. Databricks can process data held in many different types of storage, including Azure Blob Storage, Azure Data Lake Storage, Hadoop Storage, flat files, databases, and data warehouses. Databricks can also process streaming data and uses an extensible architecture based on drivers. It's important to note that a driver is a piece of code that connects to a specific data source and enables you to read and write that source. A driver is typically provided as part of a library that you can load into the Databricks environment. Drivers are available for many Azure services, including Azure SQL Database, Azure Cosmos DB, Azure Blob Storage, and Azure Data Lake Storage, as well as many services and databases produced by third parties, such as MySQL and PostgreSQL. The processing engine is provided by Apache Spark. Spark offers a parallel processing engine that supports large-scale analytics. You write application code that consumes data from one or more sources and merge, reformat, filter, and remodel this data, and then store the results. Spark distributes the work across a cluster of computers. Each computer can process its data in parallel with the other computers, and this strategy helps to reduce the time required to perform the work. Spark is designed to handle massive quantities of data. You can write the Spark application code using several languages such as Python, R, Scala, Java, and SQL. Spark has a number of libraries for these languages, providing complex analytical routines that have been optimized for the clustered environment. These libraries include modules for machine learning, statistical analysis, linear and non-linear modeling, predictive analytics, and graphics. You write Databricks applications using a notebook. A notebook contains a series of steps or cells, each of which contains a block of code. For example, one cell might contain the code that connects to a data source. The next cell reads the data from that source and converts it into a model in memory. The next cell plots a graph, and a final cell saves the data from the in-memory model to a repository. The first line in the cell defines the language that will be used, prefixed with the percentage symbol. For example, percentage Scala. For more information, read What is Azure Databricks on the Microsoft website. There is a link to this resource from the additional readings at the end of this lesson. Let's switch now to Azure HD Insight. Azure HD Insight is a managed analytics service in the cloud. It's based on Apache Hadoop, which is a collection of open source tools and utilities that enable you to run processing tasks over large amounts of data. HD Insight uses a clustered model similar to that of Synapse Analytics. HD Insight stores data using Azure Data Lake storage. You can use HD Insight to analyze data using frameworks. Such frameworks can include Hadoop MapReduce, Apache Spark, Apache Hive, Apache Kafka, Apache Storm, R, and more. Let's explore each of these frameworks in a little more detail now. Hadoop MapReduce uses a simple framework to split a task over a large dataset into a series of smaller tasks. These smaller tasks or subsets of the data can be run in parallel, and the results are then combined. You write your MapReduce code in a language such as Java and then submit this code as a job to the Hadoop cluster. Hadoop MapReduce has largely been replaced by Spark, which offers a more advanced set of operations and a simpler interface. Like MapReduce jobs, Spark jobs are parallelized into a series of subtasks that run on the cluster. You can write Spark jobs as part of an application, or you can use interactive notebooks. These notebooks are the same as those that you can run from Azure Databricks. Spark includes libraries that you can use to read and write data in a wide variety of data stores, not just HDFS. For example, you can connect to relational databases such as Azure SQL Database and other services such as Azure Cosmos DB. Apache Hive provides interactive SQL-like facilities for querying, aggregating, and summarizing data. The data can come from many different sources. Queries are converted into tasks and parallelized. Each task can run on a separate node in the HD Insight cluster, and the results are combined before being returned to the user. Apache Kafka is a clustered streaming service that can ingest data in real time. It's a highly scalable solution that offers publish and subscribe features. Apache Storm is a scalable, fault-tolerant platform for running real-time data processing applications. Storm can process high volumes of streaming data using comparatively modest computational requirements. Storm is designed for reliability, so that events shouldn't be lost. Storm solutions can also provide guaranteed processing of data with the ability to replay data that wasn't successfully processed the first time. You write a Storm application using the APIs provided by Apache. Storm can interoperate with a variety of event sources, including Azure Event Hubs, Azure IoT Hub, Apache Kafka, and RabbitMQ, which is a message queuing service. Storm can also write to data stores such as HDFS, Hive, HBase, Redis, and SQL databases. To summarize, Azure HD Insight allows the processing of data from various sources by utilizing a collection of frameworks and clusters. Examples include Kafka and Storm stream processing, interactive queries through Hive, Spark jobs using notebooks, or MapReduce jobs using Hadoop. You can find out more information by reading What is Azure HD Insight, which is located on the Microsoft website. A link to this resource is available from the additional readings at the end of this lesson. Azure Data Factory is a service that can ingest large amounts of raw, unorganized data from relational and non-relational systems and convert this data into meaningful information. Data Factory provides a scalable and programmable ingestion engine. Data Factory supports processes such as ETL, extract, transform, load, and ELT, extract, load, transform, and can be used to implement data integration projects. Azure Data Factory is described as a data integration service. The purpose of Azure Data Factory is to retrieve data from one or more data sources and convert it into a format that you process. The data sources might present data in different ways and contain noise that you need to filter out. For example, imagine a gaming company that collects petabytes of game logs that are produced by games in the cloud. The company wants to analyze these logs to gain insights into customer preferences, demographics, and usage behavior. It also wants to identify upsell and cross-sell opportunities, develop compelling new features, drive business growth, and provide a better experience to its customers. To analyse these logs, the company needs to use reference data such as customer information, game information, and marketing campaign information that is in an on-premises data store. The company wants to utilise this data from the on-premises data store, combining it with the additional log data that it has in a cloud data store. To extract insights, the company wants to process the joined data by using a Spark cluster in the cloud, using Azure HD Insight, and publish the transformed data into a cloud data warehouse, such as Azure Synapse Analytics. The company can use the information in the data warehouse to generate and publish reports. They want to automate this workflow and monitor and manage it on a daily schedule. They also want to execute it when files land in a blob store container. Using Azure Data Factory, you can create and schedule data-driven workflows, called pipelines, that can ingest data from the disparate data stores used by the gaming company. You can build complex ETL processes that transform data visually with data flows, or by using compute services such as Azure HD Insight, Azure Databricks, and Azure SQL Database. You can then publish the transformed data to Azure Synapse Analytics for business intelligence applications to consume. A pipeline is a logical grouping of activities that performs a unit of work. Together, the activities in a pipeline perform a task. For example, a pipeline might contain a series of activities that ingests raw data from Azure Blob Storage and then runs a Hive query on a HD Insight cluster to partition the data and store the results in a Cosmos DB database. Azure Data Lake is a collection of analytics and storage services that you can combine to implement a big data solution. It's comprised of three main elements: Data Lake Store, Data Lake Analytics, and HD Insight. Data Lake Store provides a file system that can store near limitless quantities of data. It uses a hierarchical organization, like the Windows and Linux file systems, but you can hold massive amounts of raw data, blobs, and structured data. It is optimized for analytics workloads. Azure Data Lake Store is compatible with the Hadoop Distributed File System, HDFS. You can run Hadoop jobs using Azure HD Insight that can read and write data in Data Lake Store efficiently. Azure Data Lake Store provides granular security over data using access control lists. An access control list specifies which accounts can access which files and folders in the store. If you are more familiar with Linux, you can use POSIX-style permissions to grant read, write, and search access based on file ownership and group membership of users. Services such as Azure Data Factory, Azure Databricks, Azure HD Insight, Azure Data Lake Analytics, and Azure Stream Analytics can read and write Data Lake Store directly. Azure Data Lake Analytics is an on-demand analytics job service that you can use to process big data. It provides a framework and set of tools that you use to analyze data held in Microsoft Azure Data Lake Store and other repositories. You write jobs that contain queries to transform data and extract insights. You define a job using a language called USQL. This is a hybrid language that takes features from both SQL and C# and provides declarative and procedural capabilities that you can use to process data. It's important to note that in a CSV file, each line consists of one or more fields, and each field is separated by a comma. The first line of the file typically contains the names of the fields. For example, a USQL block could read data from a file named stockprices.csv, which is held in a folder named Stock Market in Data Lake Storage. Stockprices.csv is a text file that contains stock market information, such as tickers and prices and possibly other data, stored in comma-separated format, commonly referred to as CSV. You could use the extract statement to read the file line by line and pull out the data in the ticker and price fields. The first line of the CSV file is skipped, as this is where a CSV file typically holds field name information rather than data. You could then use the select statement to calculate the maximum price for each ticker. Finally, you could use the output statement to store the results to another file in Data Lake Storage. It's important to understand that the USQL code only provides a description of the work to be performed. Azure Data Lake Analytics determines how best to actually carry out this work. It takes the USQL description of a job, parses it to make sure it is syntactically correct, and then compiles it into an internal representation. Then it breaks down this internal representation into stages of execution. Each stage performs a task, such as extracting the data from a specified source, dividing the data into partitions, processing the data in each partition, aggregating the results in a partition, and then combining the results from across all partitions. Partitioning is used to improve parallelization, and the processing for different partitions is performed concurrently on different processing nodes. The data for each partition is determined by the USQL compiler according to the way in which the job retrieves and processes the data. A USQL job can output results to a single CSV file, partition the results across multiple files, or can write to other destinations. For example, Data Lake Analytics enables you to create custom outputters if you want to save data in a particular format such as XML or HTML. You can also write data to the Data Lake catalog. The catalog provides a SQL-like interface to Data Lake storage, enabling you to create tables and views and run insert, update, and delete statements against these tables and views. Azure Synapse Analytics provides a suite of tools to analyze and process an organization's data. It incorporates SQL technologies, Transact SQL query capabilities, and open-source Spark tools to enable you to quickly process very large amounts of data. Now you'll look more closely at the features of Synapse Analytics and when you should consider using it. Azure Synapse Analytics is an integrated analytics service that allows organizations to gain insights quickly from all their data at any hyperscale, from both data warehouses and big data analytics systems. Azure Synapse is composed of the following elements: Synapse SQL Pool, Synapse Spark Pool, Synapse Pipelines, Synapse Link, and Synapse Studio. Synapse SQL Pool is a collection of servers running Transact SQL, which is the dialect of SQL used by Azure SQL Database and Microsoft SQL Server. You write your data processing logic using Transact SQL. Synapse Spark Pool is a cluster of servers running Apache Spark to process data. You write your data processing logic using one of the 4 supported languages: Python, Scala, SQL, and C# via .NET for Apache Spark. Spark pools support Azure Machine Learning through integration with the Spark ML and Azure ML packages. A Synapse pipeline is a logical grouping of activities that together perform a task. The activities in a pipeline define actions to perform on your data. For example, you might use a copy activity to transform data from a source dataset to a destination dataset. You can include activities that transform the data as it is transferred, or you might combine data from multiple sources together. Synapse Link is a component that allows you to connect to Cosmos DB. You can use it to perform near real-time analytics over the operational data stored in a Cosmos DB database. Synapse Studio is a web user interface that enables data engineers to access all the Synapse Analytics tools. You can use Synapse Studio to create SQL and Spark pools, define and run pipelines, and configure links to external data sources. It's important to note that any data stored in Azure Synapse Analytics can be used to build and train models with Azure Machine Learning. The following sections describe each of these elements in more detail. When you use Synapse SQL, your analytics workload runs using a SQL pool. In a SQL pool, the control and compute nodes in the cluster run a version of Azure SQL Database that supports distributed queries. You define your logic using Transact SQL statements. You send your Transact SQL statements to the control node, which splits up the work into queries that operate over a subset of the data, and then sends these smaller queries to the compute nodes. The data is split into chunks called distributions. A distribution is the basic unit of storage and processing for parallel queries that run on distributed data. Each of the smaller queries runs on one of the data distributions. The control and compute nodes use the Data Movement Service, or DMS, to move data across the nodes as necessary to run queries in parallel and return accurate results. Synapse Analytics uses a technology called Polybase to make external data look like SQL tables. You can run queries against these tables directly, or you can transfer the data into a series of SQL tables managed by Synapse Analytics for querying later. Synapse uses Azure Storage to manage your data while it's being processed. By default, an on-demand SQL pool is created in each Azure Synapse Analytics workspace. You can then provision additional pools, either on demand or provisioned. It's important to note that on-demand pools only allow you to query data held in external files. If you want to ingest and load the data into Synapse Analytics, you must create your own SQL pool. Azure Synapse Analytics is designed to run queries over massive data sets. You can manually scale the SQL pool up to 60 nodes. You can also pause a SQL pool if you don't require it for a while. Pausing releases the resources associated with the pool. You aren't charged for these resources until you manually resume the pool. However, you can't run any queries until the pool is resumed, and resuming a pool can take several minutes. Use SQL pools in Synapse Analytics for the following scenarios. Complex reporting. You can use the full power of Transact SQL to run complex SQL statements that summarize and aggregate data. Data ingestion. Polybase enables you to retrieve data from many external sources and convert it into a tabular format. You can reformat this data and save it as tables and materialized views in Azure Synapse. Synapse Spark runs clusters based on Apache Spark rather than Azure SQL Database. You write your analytics jobs as notebooks using code written in Python, Scala, C# or Spark SQL, which is a different dialect from T-SQL. You can combine code written in multiple languages in the same notebook. Notebooks also allow you to visualize data through graphs and transform data as it's loaded. The data can then be used by Spark Machine Learning, Spark ML, and Azure Machine Learning, Azure ML, to train machine learning models that support artificial intelligence. It's important to note that Spark pools and SQL pools can coexist in the same Azure Synapse Analytics instance. Spark pools enable you to process data held in many formats, such as CSV, JSON, XML, Parquet, ORC, and Avro. Spark can also be extended to support many more formats with external data sources. Spark pools provide the basic building blocks for performing in-memory cluster computing. A Spark job can load and cache data into memory and query it repeatedly. In-memory computing is much faster than disk-based applications. Spark pools in Azure Synapse are compatible with Azure Storage and Azure Data Lake Storage, so you can use Spark pools to process your data stored in Azure. Spark pools can have auto-scaling enabled, so that pools scale by adding or removing nodes as needed. Also, Spark pools can be shut down with no loss of data, since all the data is stored in Azure Storage or Data Lake Storage. Spark pools in Synapse Analytics are especially suitable for the following scenarios: data engineering or data preparation, and machine learning. Apache Spark includes many language features to support preparation and processing of large volumes of data. It can be made more valuable and then consumed by other services within Synapse Analytics. This is enabled through the Spark libraries that support processing and connectivity. Apache Spark comes with MLlib, a machine learning library built on top of Spark that you can use from a Spark pool in Synapse Analytics. Spark pools in Synapse Analytics also include Anaconda, a Python distribution with a variety of packages for data science, including machine learning. When combined with built-in support for notebooks, you have an environment for creating machine learning applications. In the next part, we will explore the components of Synapse Pipelines, Synapse Link, and Synapse Studio. Let's continue with components of Azure Synapse Analytics and start with Synapse Pipelines. A pipeline is a logical grouping of activities that together perform a task. For example, a pipeline could contain a set of activities that ingest and clean log data, and then kick off a mapping data flow to analyze the log data. The pipeline allows you to manage the activities as a set instead of each one individually. You deploy and schedule the pipeline instead of the activities independently. The activities in a pipeline define actions to perform on your data. For example, you may use a copy activity to copy data from Azure Blob Storage into Azure Synapse using a SQL pool. Then use a data flow activity or a notebook activity using a Spark pool to process and generate a machine learning model. Synapse pipelines use the same data integration engine used by Azure Data Factory. This gives you the power in Synapse Studio to create pipelines that can connect to over 90 sources from flat files, databases, or online services. You can create codeless data flows that let you do complex mappings and transformations on data as it flows into your analytics solutions. For example, you could have a pipeline with 3 activities. First, the pipeline ingests data. Then it uses a Spark notebook to generate a machine learning model. Finally, the pipeline contains an Azure function at the end to test the machine learning model and validate it. For more information, you can read the pipelines and activities in Azure Data Factory page on the Microsoft website. You will find a link to this resource from the additional reading at the end of this lesson. Okay, let's talk about Azure Synapse Link now. Azure Synapse Link for Azure Cosmos DB is a cloud-native hybrid transactional and analytical processing, or HTAP, capability that enables you to run near real-time analytics over operational data stored in Azure Cosmos DB. Synapse Link uses a feature of Cosmos DB named Cosmos DB Analytical Store. Cosmos DB Analytical Store contains a copy of the data in a Cosmos DB container, but organized as a column store. Column stores group data by column rather than by row. Column stores are a more optimal format for running analytical workloads that need to aggregate data down a column rather than across a row, such as generating sum totals, averages, maximum or minimum values for a column. Cosmos DB automatically keeps the data in its containers synchronized with the copies in the column store. Azure Synapse Link enables you to run workloads that retrieve data directly from Cosmos DB and run analytics workloads using Azure Synapse Analytics. The data doesn't have to go through an ETL, extract, transform and load process, because the data isn't copied into Synapse Analytics. It remains in the Cosmos DB Analytical Store. Business analysts, data engineers and data scientists can now use Synapse Spark Pools or Synapse SQL Pools to run near real-time business intelligence, analytics and machine learning pipelines. You can achieve this without impacting the performance of your transactional workloads on Azure Cosmos DB. Synapse Link has a wide range of uses, including supply chain analytics and forecasting, operational reporting, batch data integration and orchestration, real-time personalization, and IoT maintenance. Let's take a closer look at each of these now. Supply chain analytics and forecasting. You can query operational data directly and use it to build machine learning models. You can use the results generated by these models and write back into Cosmos DB for near real-time scoring. You can use these assessments to successively refine the models and generate more accurate forecasts. Operational reporting. You can use Synapse Analytics to query operational data using Transact SQL running in a SQL pool. You can publish the results to dashboards using the support provided to familiar tools such as Microsoft Power BI. Batch data integration and orchestration. With supply chains getting more complex, supply chain data platforms need to integrate with a variety of data sources and formats. The Azure Synapse Data Integration Engine allows data engineers to create rich data pipelines without requiring a separate orchestration engine. Real-time personalization. You can build engaging e-commerce solutions that allow retailers to generate personalized recommendations and special offers for customers in real time. IoT maintenance. Industrial IoT innovations have drastically reduced downtimes of machinery and increased overall efficiency across all fields of industry. One such innovation is predictive maintenance analytics for machinery at the edge of the cloud. The historical operational data from IoT device sensors could be used to train predictive models such as anomaly detectors. These anomaly detectors are then deployed back to the edge for real-time monitoring. Looping back allows for continuous retraining of the predictive models. Finally, let's take a look at Synapse Studio. Synapse Studio is a web interface that enables you to create pools and pipelines interactively. With Synapse Studio, you can develop, test and debug Spark notebooks and Transact SQL jobs. You can monitor the performance of operations that are currently running, and you can manage the serverless or provisioned resources. All of these capabilities are accessed via the web-native Synapse Studio that allows for model management, monitoring, coding and security. You can access Synapse Studio directly from the Azure portal. This module has described how a data warehouse solution works and given you an overview of the services you can use to construct a modern data warehouse in Azure. These services included Azure Data Factory, Azure Data Lake Storage, Azure Databricks, Azure Synapse Analytics, and Azure HD Insight. You also learned about the tools for ingesting data into an Azure database. You've seen how to use Azure Data Factory to read, process and store data in a data warehouse. You learned some of the common practices for data loading using linked services and datasets in Azure Data Factory. You explored pipelines and data ingestion using Polybase, QL Server integration services, and Azure Databricks. Finally, you explored data storage and processing in Azure using Azure Synapse Analytics, Azure Databricks, Azure HD Insight, Azure Data Factory, and Azure Data Lake. Hello. In this lesson, you will learn about the fundamentals of Microsoft Power BI. Microsoft Power BI is a collection of software, services, apps, and connectors that work together to turn your unrelated sources of data into coherent, visually immersive, and interactive insights. Whether your data is a simple Microsoft Excel workbook or a collection of cloud-based and on-premises hybrid data warehouses, Power BI lets you easily connect to your data sources, visualize and discover what's important, and share that information. Power BI can be simple and fast, capable of creating quick insights from an Excel workbook or a local database. But Power BI is also robust and enterprise grade, ready not only for extensive modelling and real-time analytics, but also for custom development. Therefore, it can be your personal report and visualization tool, but can also serve as the analytics and decision engine behind group projects, divisions, or entire corporations. If you're a beginner with Power BI, this lesson will focus on the basic building blocks. Let's take a look at the parts that make up Power BI now. Power BI consists of a Microsoft Windows desktop application called Power BI Desktop, an online SaaS, software as a service, called the Power BI Service, and mobile Power BI apps that are available on any device, with native mobile BI apps for Windows, iOS, and Android. These three elements, desktop, the service, and mobile apps, are designed to let people create, share, and consume business insights in the way that serves them or their role most effectively. How you use Power BI can depend on your role within a project or a team. Other people in other roles might use Power BI differently. For example, you might view reports and dashboards in the Power BI service, and that might be all you do with Power BI. But your co-worker, who is a business analyst, might make extensive use of Power BI Desktop and publish Power BI Desktop reports to the Power BI service, which you then use to view them. And another co-worker in sales might mainly use her Power BI phone app to monitor progress of sales quotas and drill into new sales lead details. You also might use certain features of Power BI at different stages. How you use Power BI can depend on which feature or service is the best tool for your current needs. For example, perhaps you view inventory and manufacturing progress in real-time dashboard in the service. Or you can also use Power BI Desktop to create reports for your own team about customer engagement statistics. To download Power BI Desktop, you have two options. You can download it from the Microsoft website or as an app from the Microsoft Store. It's important to note that the apps downloaded from the Microsoft Store will update automatically. Downloads from the website need to be manually updated periodically. Before you can sign into Power BI, you'll need an account. To get a free trial, go to app.powerbi.com and sign up with your details. For detailed steps on setting up an account, see Sign into Power BI Service on the Microsoft website. There is a link to this resource from the additional readings at the end of this lesson. Let's look at the flow of work in Power BI. A common flow of work begins in Power BI Desktop, where a report is created. That report is then published to the Power BI service and finally shared so that users of Power BI mobile apps can consume the information. We will use this common flow as our example, as it is a useful way of discovering how the different parts of Power BI complement each other. In the next part, we will look at what it's like to use Power BI. Now that you have been introduced to the basics of Microsoft Power BI, let's explore these features in a little more detail. The activities and analyses that you'll learn with Power BI generally follow a common flow. The common flow of activity may look like the following. Load data into Power BI Desktop and create reports or visualizations. Publish to the Power BI service. Here you can also create additional visualizations or build dashboards. Share dashboards with others, especially people who are on the go. And view and interact with shared dashboards and reports in Power BI mobile apps. In this next part, you will learn about the basic building blocks of Power BI, which will provide a solid basis for turning data into reports and visuals. Everything you do in Microsoft Power BI can be broken down into a few basic building blocks. After you understand these building blocks, you can expand on each of them and begin creating elaborate and complex reports. After all, even seemingly complex things are built from basic building blocks. Let's take a look at these basic building blocks. These can include visualizations, data sets, reports, dashboards, and tiles. A visualization is a representation of data, like a chart or a color-coded map that you can create to represent your data visually. Power BI contains many visualization types, with more being added all the time. Visualizations can be simple, like a single number that represents something significant, or they can be visually complex, like a gradient-colored map that shows voter sentiment about a certain social issue or concern. The goal of a visual is to present data in a way that provides context and insights, both of which would probably be difficult to discern from a raw table of numbers or text. A dataset is a collection of data that Power BI uses to create its visualizations. For example, you could have a simple dataset that's based on a single table from a Microsoft Excel workbook. Datasets can include a combination of data from many different sources. When combined, they can provide a unique collection called a dataset. An important and enabling part of Power BI is the multitude of data connectors that are included. Whether the data you want is in Excel or a Microsoft SQL Server database, or in a service like Facebook or Salesforce, Power BI has built-in data connectors that let you easily connect to that data. Focus on the data that matters to you by filtering data before loading it into Power BI. After you've loaded the dataset, you can create unique visualizations to gain new insights. You can generate a collection of related insights in the form of a report. In Power BI, a report is a collection of visualizations that appear together on one or more pages. Just like any other report you might create for a sales presentation or write for a college assignment, a report in Power BI is a collection of items that are related to each other. For example, you can generate a multi-page report in Power BI Desktop. You can also create reports in the Power BI service. Reports let you create many visualizations on multiple pages if necessary, and let you arrange those visualizations in whatever way best tells your story. Whatever your subject, reports lets you gather and organize your visualizations onto one or more pages. When you're ready to share a report or a collection of visualizations, you create a dashboard. Power BI Dashboard is a collection of visuals from a single page that you can share with others. Often, it's a selected group of visuals that provide a quick insight into the data or story that you're trying to present. A dashboard must fit on a single page, often called a canvas. The canvas is the blank backdrop in Power BI Desktop, or the service where you put visualizations. You can think of the canvas as a workspace where you create, combine, and rework interesting and compelling visuals. You can share dashboards with other users or groups who can then interact with your dashboards from the Power BI service or on their mobile device. Finally, we have tiles. In Power BI, a tile is a single visualization on a dashboard. It's the rectangular box that holds an individual visual. For example, it's common for a dashboard to contain multiple tiles where one tile is surrounded by other tiles. When you're creating a dashboard in Power BI, you can move or arrange tiles however you want. You can make them bigger, change their height or width, and reposition them with other tiles. Only the report administrator can edit the tiles. When sharing a report with users, it's worth noting that they can only view and interact with it. Those are the basics of Power BI and its building blocks. Let's take a moment to review. Power BI is a collection of services, apps, and connectors that lets you connect to your data wherever it resides. Data can be filtered if necessary and then loaded into Power BI, allowing you to create visualizations that you can share with others. Using the basic building blocks of Power BI, you can create datasets that make sense to you or your organization. From there, you can create visuals and reports that tell a story. Stories told with Power BI can range from simple to complex. An example of simple implementation is the use of a single Excel table in a dataset. You can then share a dashboard with colleagues. An example of a complex implementation is the use of an Azure SQL data warehouse to build a near real-time dataset. Regardless of complexity, the process is the same. Create datasets, build compelling visuals, and share them with others. The result is the same. You harness your ever-expanding world of data and turn it into actionable insights. Whether your data insights require straightforward or complex data sets, Power BI helps you get started quickly and you can expand with your business requirements. As we learned earlier, the common flow of work in Microsoft Power BI is as follows. Create a report in Power BI Desktop, publish it to the Power BI service and then share it with others so that they can view it in the service or on a mobile app. However, some people begin in the Power BI service. Let's take a quick look at that first and introduce Power BI apps. An app is a Power BI content type that combines related dashboards and reports all in one place. An app can have one or more dashboards and one or more reports all bundled together. You can sign into the service from your web browser at powerbi.microsoft.com. With Power BI, connecting to data is a very straightforward process. For example, from the Power BI service, you can just select the Get Data button, which is located in the lower left corner of the homepage. The canvas shows you the available sources of data in the Power BI service. In addition to common data sources, Power BI can just as easily connect to software services such as Salesforce, Facebook, Google Analytics, and more. The Power BI service provides a collection of ready-made visuals for other software services that are pre-arranged on dashboards and reports for your organization. This collection of visuals is called an app. Apps get you up and running quickly with data and dashboards that your organization has created for you. For example, when you use the GitHub app, Power BI connects to your GitHub account after you provide your credentials. Then it populates a predefined collection of visuals and dashboards. There are apps for a variety of online services available from the apps page. Let's take a look at GitHub. GitHub is an application for online source control. When you select the Get It Now button in the box for the GitHub app, the Connect to GitHub dialog box appears. It's important to note that GitHub does not support Internet Explorer, so make sure you are working in another browser. After you enter the information and credentials for the GitHub app, installation of the app begins. After the data is loaded, the predefined GitHub app dashboard appears. The dashboard visuals are based on reports generated when the data is loaded. You can select and interact with any of the visuals. The other visuals on the page will respond to your selection. In this example, the user, Adam BJ, is selected in the tree map on the pull requests report. The other visuals on the page have adjusted to reflect that selection by displaying the chosen user's data. You can also choose to update the data set for an app or other data that you use in Power BI. To set update settings, select the Schedule Update icon for the dataset to update and then use the menu that appears. You can also select the Update icon to update the dataset immediately. The Datasets tab is selected on the Settings app page that appears. In the right pane, select the arrow next to the Scheduled Refresh to expand that selection. The Settings dialog box appears on the canvas, letting you set the update settings that meet your needs. That concludes our quick tour of the Power BI service. There is much more that you can do with Power BI. You can connect to many sources of data and create your own apps utilizing dashboards and visualizations. You can also avail of the many pre-made solutions available, with new solutions being released all the time. Let's do a quick review of what we covered in this lesson. Microsoft Power BI is a collection of software services, apps and connectors that work together to turn your data into interactive insights. You can use data from single basic sources like a Microsoft Excel workbook or pull in data from multiple databases and cloud sources to create complex data sets and reports. Power BI can be as straightforward as you want or as enterprise ready. Power BI consists of three main elements: Power BI Desktop, the Power BI Service and Power BI Mobile, which work together to let you create, interact with, share and consume your data the way you want. We also discuss the basic building blocks in Power BI. We use visualizations to create a visual representation of data. These are sometimes just called visuals. We create visualizations from datasets. A dataset is a collection of data that Power BI uses to create visualizations. We generate a collection of visuals from a dataset in the form of a report. These span one or more pages. A single-page collection of visuals built from a report are generated on a dashboard. A single visualization on a report or dashboard is a tile. In the Power BI service, we explored app installation. You learned that an app is a ready-made collection of visuals and reports. You can use it to easily connect to a software service to populate the app. Finally, we set up a refresh schedule for our data to ensure that we are viewing the latest version of the data.